The cloud is enabling dramatic changes in the way we live our lives.
From the healthcare sector
to the entertainment industry.
The cloud allows small businesses to go global, developing countries to expand into new markets, and language barriers to fade.
Doctors can remotely monitor patients in their own home.
scientists can predict hurricanes.
And education can now be distributed to more people than ever before.
From universities to refugee camps.
We can use the cloud, AI, and machine learning to help us quickly search through large amounts of data, helping us make important decisions with the right kind of information. So instead of guessing and making decisions based on only part of the story, we are helping scientists, doctors, and many other people make better decisions. With the right knowledge and skills, you can be part of this change.
Cloud computing is rapidly expanding to all businesses, creating new career opportunities. Career opportunities in cloud computing cover a broad range of roles, from developers and architects to security professionals and data scientists. Given the constantly evolving nature of the cloud, working in the cloud requires continuously updating your knowledge and skills.
However, maybe you don't have that specific university degree, the right certifications, and hands-on experience, or maybe the cost is just too high.
For these reasons, Microsoft and Coursera have partnered to develop the first in a series of programs to prepare you for a career in the cloud. This program consists of 4 courses that will act as a bedrock of fundamental knowledge to prepare you for the AZ900 certification exam.
The AZ900 certification is designed to give you the fundamental knowledge, skills, and confidence to begin your Azure certification journey. We've assembled a great team of instructors to prepare you for this journey.
I'm Rachel. In Course 1, Introduction to Azure Core Concepts and Services, you'll learn the basics of cloud computing, its advantages, and how to determine whether Azure is the right solution for your business needs. You'll learn about several of the database and big data services that are available on Microsoft Azure. You'll also learn how to take advantage of several virtualization services in Azure Compute, which can help your applications scale out quickly and efficiently to meet increasing demands. Finally, you'll learn about the different storage and virtual network options available in Azure.
I'm Barry. In Course 2, Azure Management Tools and Security Solutions, you'll learn about AI and software development tools and services from Microsoft Azure. You'll learn about monitoring and management tools and services from Azure. You'll then look at the serverless computing technology and Azure IoT service that best addresses different business scenarios. Finally, you'll learn how Azure can help you protect the workloads that you run, both in the cloud and in your on-premises data center.
I'm Anita. In Course 3, Azure Services and Lifecycles, you'll learn how Azure Active Directory provides identity and access management. Then you'll learn how to make organizational decisions about your cloud environment by using the Cloud Adoption Framework for Azure. You'll learn how to control and audit how your resources are created by using Azure Policy, and enable governance at scale across multiple Azure subscriptions by using Azure Blueprints. You'll use the Total Cost of Ownership calculator to compare your current data center costs to running the same workloads on Azure.
I'm Kaylisha, and finally in Course 4, preparing for the AZ900 Azure Fundamentals exam. You'll get a more detailed overview of the Microsoft certification program and where you can go next in your career. You'll get tips and tricks, testing strategies, useful resources, and information on how to sign up for the AZ900 exam. You'll also get a recap of the key topics and concepts covered in each course, along with a practice exam. Finally, you'll get to take the practice exam that tests all the main topics covered in the AZ900 proctored exam, ensuring you're well prepared for certification success.
Hello and welcome to the first course in this program, Introduction to Azure Core Concepts and Services. Before we start diving into the detail, let's take a look at an overview of the program and how you can benefit from Microsoft certification in this area. Becoming AZ900 Microsoft Azure Fundamentals Certified can be the launch pad for your learning journey into cloud computing and Azure technologies. This certification is a good fit if you are beginning to work with cloud-based solutions and services or are new to Azure. Acquiring the Azure Fundamentals certification is also an opportunity for you to prove your knowledge of cloud concepts and Azure's main features. These include Azure Services, Azure Workloads, Azure Security and Privacy, and finally, Azure Pricing and Support. This course will help you to develop these skills and prepare you to pass the official Azure AZ900 exam. To get the most out of this course, it helps if you are familiar with the general technology concepts, including concepts of networking, storage, compute, application support, and application development. Microsoft certifications provide globally recognized and industry-endorsed evidence of mastering technical skills. Microsoft certification provides you with the pathway to upgrade your skills, validate your abilities, enhance your professional performance, and develop your career. Microsoft certifications validate your skills and capabilities and leads you to success. Achieving certification shows employers that you have drive and initiative. If you get hired in a new role, or promoted, or change your career, your certification speaks volumes about you and what you know. In this course, you will explore various modules relating to Azure core concepts and services. You'll start off with an introduction to Azure Fundamentals. Here, you'll explore basic cloud concepts, get a streamlined overview of many Azure services, and be able to access hands-on exercises to deploy your very first services for free. As you navigate this module, you will become familiar with cloud concepts, cloud models and platforms such as infrastructure as a service, platform as a service, and software as a service. You'll also cover all the core things you need to know about cloud computing, such as elasticity, scalability, and agility. Next, you will work through Azure fundamental concepts and architectural components. In this module, you'll learn about the advantages of using cloud computing services and how to differentiate between the categories and types of cloud computing. You'll also examine the various concepts, resources, and terminology that are necessary to work with the Azure architecture. As you dive deeper, you'll explore Azure Database, Analytics, and Compute services. In this module, you will identify several of the database services that are available on Microsoft Azure, such as Azure Cosmos DB, Azure SQL Database, Azure SQL Managed Instance, Azure Database for MySQL, and Azure Database for PostgreSQL. In addition, you'll learn about several of the big data and analysis services in Azure. You'll also learn how to take advantage of several virtualization services in Azure Compute, which can help your applications scale out quickly and efficiently to meet increasing demands. And as things become even more exciting, you will navigate the different storage options that are available in Azure Storage and Networking services. As you complete the individual units in this module, you'll learn about Azure Blob Storage, Azure Disk Storage, Azure Files, and Blob Access tiers. You'll also take a look at several of the core networking resources that are available in Azure. You'll learn about Azure Virtual Network, which can configure into a customized network environment that meets your company's needs. You'll also learn how you can use Azure VPN Gateway and Azure ExpressRoute to create secure communication tunnels between your company's different locations. Throughout this course, you will have an opportunity to get your hands-on experience with Azure through interactive exercises, practice quizzes, and practice exams. The interactive exercises offer opportunities to practice and implement what you are learning. As an example, when you learn about creating a SQL database, you'll work in a temporary Azure environment called the Sandbox. The beauty about this is that you will be working with real technology, but in a controlled environment, which allows you to apply what you learn and at your own pace. As you explore the concepts and services that are available through Azure, you'll be given a case study to apply what you are learning to real-world examples. In the case study, you'll assume the role of an IT specialist and address the technology challenges of tailwind traders so that you can help them conduct business more efficiently. Using real-world examples helps you to reinforce concepts, prepare you for the exam, and gives you confidence in your approach. Now that you have a good idea of what you'll cover in this course, you can review what you'll learn through the modules in more detail. Good luck! Earning Microsoft certifications is a great option as it shows that you are keeping pace with today's technical roles and requirements. The AZ900 Azure Fundamentals forms part of the fundamental level of the Azure journey. Each certification pathway starts with AZ900 as the fundamental level, and although it is optional for those who have experience, it is recommended as a foundation for next level certifications. Depending on your goals, there are many certifications and certification paths to choose from. Let's look at a few examples so that you can get some ideas on how to build your career. John started his career in an IT support department at the help desk. He was brand new to cloud services. He decided to learn the fundamentals and then explore further opportunities. He enrolled for the AZ900 exam as a starting point. These exams do not assume any prior knowledge, and this was a great place for him to get his feet wet. John's plan for his career was to become an Azure administrator. The Azure Administrator Certification, AZ104, is an associate level certification. Candidates for the Azure Administrator Associate certification should have subject matter expertise implementing, managing, and monitoring an organization's Microsoft Azure environment. John successfully completed the AZ900 examination and was promoted into an Azure support role. He went on to gain 6 months of experience administering his company's Azure environment. He needed this experience as a prerequisite to register for the Azure Administrator certification. Today, John is a successful Azure administrator. He keeps the Azure environment running and responds to daily business expectations. Letitia has always believed that it's important to upskill in a competitive work environment and has made plans to advance her existing career. She decided to add new credentials to her portfolio and to step beyond software development. She has more than 2 years' experience in her existing field and supports the solutions architect with her company's evolving Azure infrastructure. Letitia decided that she could achieve her goal by completing the developer certification. Developers implement applications and services by partnering with solution architects and customers. Responsibilities for this role include participating in all phases of cloud development, from requirements definition and design to development, deployment, and maintenance, performance tuning, and monitoring. Letitia started off with the AZ900 exam as she believed this would be a good foundation for success. Letitia has become an Azure developer at her company and successfully completed the developer certification path, which includes Azure Fundamentals, AZ900, and Azure Developer Associate, AZ204. Jose lost his job during the COVID crisis. He had graduated with a bachelor's degree in history a few years ago. Jose gathered 2 years' experience as an Azure administrator, but he did not have any certification to validate his knowledge and skills. Jose has always wanted to be a DevOps engineer, and he decided that achieving certification would open new career opportunities for him. Jose was an ideal candidate for DevOps engineer certification, given the experience he had gathered as an Azure administrator. He completed the AZ900 Fundamentals exam as a foundation for further studies and went on to successfully complete the DevOps engineer certification pathway. After certification, Jose was able to secure a role as an Azure administrator with a large company and will be considered for a DevOps engineer position in the near future. Microsoft DevOps professionals combine people, process, and technologies to continuously deliver valuable products and services that meet user needs and business objectives. Based on these scenarios, you can see that Microsoft provides you with the ability to start a specific certification path that matches your job role while providing you with the opportunity to improve your skills at the same time. There are different certification paths for you to choose from depending on your expertise and background. The certifications are structured into 3 expertise levels. The fundamentals certifications are targeted towards those just starting out with the technologies covered or looking to change careers. The associate certifications are targeted towards professionals that already have at least 2 years of practical experience working with the technologies covered. The expert certifications are targeted towards professionals that have a minimum of 5 years advanced levels of practical experience and skills with the technologies covered. We have provided the link to the Microsoft certifications at the end of this lesson so that you can explore them in more detail. The Microsoft AZ900 exam covers a basic understanding of cloud concepts, including core Azure services, security, privacy, compliance, and trust, as well as Azure pricing and support. You can expect between 40 to 60 questions in your Microsoft AZ900 exam. There are different question types used during the exam, including case study, short answers, multiple choice, mark review, and drag and drop. The exam requires you to demonstrate high-level knowledge of the Azure cloud and its various service offerings across the following 6 domain areas. Describe cloud concepts. Describe core Azure services. Describe core solutions and management tools on Azure. Describe general security and network security features. Describe identity, governance, privacy, and compliance features. Describe Azure cost management and service level agreements. The percentages for each domain highlights the weighting of that section to the overall exam. The higher the percentage, the more questions that specific section of the exam will contain. At this point, you may be wondering if you will have access to the information that you'll need to successfully pass the Azure Fundamentals exam. The answer is yes. Each domain area is mapped to the Microsoft AZ900 Azure Fundamentals Professional Certificate Program. Once you have successfully completed the courses in this specialization program, you will receive a notification that gives you an opportunity to unlock a discount certification voucher code. Once you have unlocked the code, you can use this to register and schedule the exam through Microsoft and Pearson VUE. The discount certification voucher code gives you 50% discount on the price that it costs to take the AZ900 Microsoft certification exam. Please note that the content of this exam was updated on November the 9th, 2020. Be sure to read the Microsoft Azure Fundamentals exam page for more information about what skills are covered in each domain area. Remember to contact us if you have any questions. Good luck with your preparation. Hello and welcome to Azure Fundamentals. In this lesson, you'll take an entry-level, end-to-end look at Azure and its capabilities. You'll gain a solid foundation on Azure Fundamentals that you will rely on throughout the rest of this course. In this lesson, you will be introduced to the basics of cloud computing. You will get a big picture view of the available services and features in Azure and determine whether Azure is the right solution for your needs. And if you're new to Azure, you can sign up for a free account on the Azure website to start exploring. At this point, you may have some questions, like what is Azure and what can it do for your business? When you've completed this lesson, you'll have the answers to these questions. Microsoft Azure is a cloud computing platform with an ever-expanding set of services. Azure gives you the freedom to build, manage, and deploy applications on a massive global network using your favorite tools and frameworks. The Azure Cloud Platform has more than 200 products and cloud services that you can use to build, run, and manage applications across multiple clouds, on-premises, and at the edge. It delivers computing services over the internet, including servers, storage, databases, networking, software, analytics, and intelligence. Azure Cloud Computing offers faster innovation, flexible resources, and economies of scale. The cloud helps you move faster and innovate in ways that were once nearly impossible. But critically, it does this while lowering your costs. Cloud computing provides computing services over the internet using a pay-as-you-go pricing model. Typically, you only pay for the cloud services you use, which helps you lower your operating costs, run your infrastructure more efficiently, and scale as your business needs change. To put it another way, cloud computing is a way to rent compute power and storage from someone else's data center. When you're done using them, you give them back. You're billed only for what you use. Instead of maintaining CPUs and storage in your data center, you rent them for the time that you need them. The cloud provider takes care of maintaining the underlying infrastructure for you. The cloud enables you to quickly solve your toughest business challenges and bring cutting-edge solutions to your users. In our ever-changing digital world, two trends emerge. Teams deliver new features to their users at record speeds, and users expect an increasingly rich and immersive experience with their devices and with software. To power your services and deliver innovative and novel user experiences more quickly, the cloud provides on-demand access to a nearly limitless pool of raw compute, storage, and networking components. Speech recognition and other cognitive services that help make your applications stand out from the crowd. Analytics services that deliver telemetry data from your software and devices. You were briefly introduced to Azure at the beginning of this lesson. By the end of this video, you should be able to determine whether Azure is the right solution for your business needs. Azure runs business applications by providing global scale, consistency, and seamless integration with on-premises environments. With help from Azure, businesses have everything they need to build the next great solution. Let's explore several benefits that Azure offers. Azure offers businesses the option to be ready for the future. Continuous innovation from Microsoft supports development today and product visions for tomorrow. Build on your terms. You have choices, with a commitment to open source and support for all languages and frameworks. Businesses can build how they want and deploy where they want to. Operate hybrid seamlessly. They can integrate and manage their environments with tools and services designed for a hybrid cloud solution. Trust your cloud. Get security from the ground up, backed by a team of experts, and proactive compliance trusted by enterprises, governments, and startups. Now that you have an overview of some of the benefits Azure offers, let's take a look at what you can do with Azure. Many teams start exploring the cloud by moving their existing applications to virtual machines that run in Azure. Migrating your existing apps to virtual machines is a good start, but the cloud is much more than a different place to run your virtual machine. Imagine communicating naturally with your users through vision, hearing, and speech using AI and machine learning services. With Azure, you can explore everything from running existing applications on virtual machines to using new software paradigms such as intelligence bots and mixed reality. Azure also provides storage solutions that dynamically grow to accommodate massive amounts of data. You may be wondering how Azure can help you to manage your cloud resources. Imagine an integrated, easy-to-use console built just for you. The Azure portal is exactly that, a web-based unified console that provides an alternative to command line tools. You can organize the Azure portal to custom fit your workflow, projects, and style. With the Azure portal, you can manage your Azure subscription by using a graphical user interface. You can build, manage, and monitor everything from simple web apps to complex cloud deployments. Create custom dashboards for an organized view of resources, and configure accessibility options for an optimal experience. The Azure portal is designed for resiliency and continuous availability. It maintains a presence in every Azure data center. The Azure portal updates continuously and requires no downtime for maintenance activities. This configuration makes the Azure portal resilient to individual data center failures and avoids network slowdowns by being close to users. Azure Marketplace helps connect users with Microsoft partners, independent software vendors, and startups that are offering their solutions and services, which are optimized to run on Azure. Azure Marketplace customers can find, try, purchase, and provision applications and services from hundreds of leading service providers. All solutions and services are certified to run on Azure. The solution catalog spans several industry categories. These include virtual machine images, databases, application build and deployment software, development tools, threat detection, and blockchain. Azure Marketplace is designed for IT pros and cloud developers interested in commercial and IT software. Microsoft partners also use it as a launch point for all joint go-to-market activities. Using Azure Marketplace, you can provision end-to-end solutions quickly and reliably, hosted in your own Azure environment. To explore the Azure Marketplace online, you can access the link in the resource section at the end of this lesson. Throughout the Azure Fundamentals learning paths, we'll work with Tailwind Traders, a fictitious home improvement retailer. It operates retail hardware stores across the globe and online. Tailwind Traders currently manages an on-premises data center that hosts the company's retail website. The data center also stores all of the data and streaming video for its applications. Let's suppose that you work as an IT specialist in Tailwind Traders' IT department. Your IT team buys new hardware, installs and configures software, and deploys everything throughout the data center. These management responsibilities create some obstacles for delivering your applications to your users in a timely fashion. As an IT professional, you realize it would be advantageous to have servers, storage, databases, and other services immediately available when you develop and deploy applications. You want to be able to easily start a new server or add services to your solutions. Throughout this course, you'll learn about some of the cloud-based services that Tailwind Traders can use to address its technology challenges. With that in mind, the services that are available through Azure can help Tailwind Traders conduct its business more efficiently. As you complete the various modules in the Azure Fundamentals learning paths, we'll analyze the challenges that Tailwind Traders is facing. You'll see how you can use Azure Services to address each of the issues as they arise. After you've completed each of the modules, the knowledge that you gained from resolving the hypothetical challenges that the fictional Tailwind Traders company encountered should benefit you in your real-world environments. Congratulations! You have completed this lesson on core Azure concepts. We defined what cloud computing is and saw some examples, then covered what Azure is and went through some of the most used categories of services. We also saw how to get started with Azure accounts. Finally, we introduced a case study, which we will be expanding and using throughout this course. Hello and welcome to Azure Fundamental Concepts and Architectural Components. In this module, you'll learn about the main concepts of cloud computing and how Azure implements these concepts. We will also see in our case study how Tailwind Traders can benefit from migrating to a cloud computing environment. More specifically, after completing this lesson, you will identify benefits and considerations of using cloud services. You will describe the differences between categories of cloud services, and you will describe the differences between types of cloud computing. So let's dive right into our case study. You work in the IT department for Tailwind Traders, which has decided to migrate its applications and data to Microsoft Azure. You're aware that cloud computing will save your company time and money by migrating from your existing on-premises physical hardware to a cloud solution. With this new solution, you'll only need to pay for the resources and computing time that you use. However, some of the cloud computing concepts are new to many members of your IT staff. They've been asking some specific questions about what cloud computing can do for them. For example, the team that manages Tailwind Traders' website wants to know how Azure improves the site's availability and scalability. The team that handles the deployment of new hardware is curious to see how cloud computing can make their deployment processes faster. In addition, your developer team wants to learn about the different options available to them as they are designing new applications. For example, is there a way to run their applications in a hybrid configuration, where part of their application runs on-premises and the rest of the application runs in the cloud? There are several benefits that a cloud environment has over a physical environment. For example, cloud-based applications employ a myriad of related strategies. High availability. Depending on the service level agreement that you choose, your cloud-based applications can provide a continuous user experience with no apparent downtime, even when things go wrong. Scalability. Applications in the cloud can be scaled in two ways. Vertically, computing capacity can be increased by adding RAM or CPUs to a virtual machine. Horizontally, computing capacity can be increased by adding instances of a resource, such as adding more virtual machines to your configuration. Elasticity. Cloud-based applications can be configured to take advantage of auto-scaling, so your applications will always have the resources they need. Agility. Cloud-based resources can be deployed and configured quickly as your application requirements change. Geo-distribution. Applications and data can be deployed to regional data centers around the globe, so your customers always have the best performance in their region. And disaster recovery. By taking advantage of cloud-based backup services, data replication, and geo-distribution, you can deploy your applications with the confidence that comes from knowing that your data is safe in the event that disaster should occur. Cloud service providers operate on a consumption-based model, which means that end users only pay for the resources that they use. Whatever they use is what they pay for. A consumption-based model has many benefits, including no upfront costs, no need to purchase and manage costly infrastructure that users might not use to its fullest, the ability to pay for additional resources when they are needed, the ability to stop paying for resources that are no longer needed. When analysing the benefits of cloud computing, there are two different types of expenses that you should consider. Capital expenditure, or CapEx, operational expenditure, or OpEx. Capital expenditure, or CapEx, is the upfront spending of money on physical infrastructure, and then deducting that upfront expense over time. The upfront cost from CapEx has a value that reduces over time. Operational expenditure, or OpEx, is where you spend money on products or services and are billed for them at the moment of use. You can think of these as the day-to-day expenses that are paid for immediately. In other words, when Tailwind Traders owns its infrastructure, it buys equipment that goes onto its balance sheets as assets. Because a capital investment was made, accountants categorize this transaction as a CapEx. Over time, to account for the asset's limited useful lifespan, assets are depreciated or amortized. Cloud services, on the other hand, are categorized as an OpEx because of their consumption model. There's no asset for Tailwind Traders to amortize, and its cloud service provider, Azure, manages the costs that are associated with the purchase and lifespan of the physical equipment. As a result, OpEx has a direct impact on net profit, taxable income, and the associated expenses on the balance sheet. To summarize, CapEx requires significant upfront financial costs as well as ongoing maintenance and support expenditures. By contrast, OpEx is a consumption-based model, so Tailwind Traders is only responsible for the cost of the computing resources that it uses. If you've been around cloud computing for a while, you've probably seen the terms Infrastructure as a Service, or IaaS, Platform as a Service, or PaaS, and Software as a Service, or SaaS, for the different cloud service models. These models define the different level of shared responsibility that a cloud provider and cloud tenant are responsible for. IaaS is the most flexible category of cloud services. It aims to give you complete control over the hardware that runs your application. Instead of buying hardware, with IaaS, you rent it. PaaS provides the same benefits and considerations as IaaS, but there are some additional benefits. SaaS is software that's centrally hosted and managed for you and your users or customers. Usually one version of the application is used for all customers, and it's licensed through a monthly or annual subscription. SaaS provides the same benefits as IaaS, but again, there are some additional benefits. You can see how when you move from IaaS to PaaS to SaaS, the shared responsibilities reduces for the client and increases for the provider. This chart illustrates the various levels of responsibility between a cloud provider and a cloud tenant. As you move from on-premises through IaaS and PaaS to SaaS, the responsibility for maintaining infrastructure, platform, and software responsibilities progressively transfer to the provider from the tenant. Like PaaS, serverless computing enables developers to build applications faster by eliminating the need for them to manage infrastructure. With serverless applications, the cloud service provider automatically provisions, scales, and manages the infrastructure required to run the code. Serverless architectures are highly scalable and event-driven, only using resources when a specific function or trigger occurs. It's important to note that servers are still running the code. The serverless name comes from the fact that the tasks associated with infrastructure provisioning and management are invisible to the developer. This approach enables developers to increase their focus on the business logic and deliver more value to the core of the business. Serverless computing helps teams increase their productivity and bring products to market faster. And it allows organizations to better optimize resources and stay focused on innovation. There are 3 deployment models for cloud computing: public cloud, private cloud, and hybrid cloud. Each deployment model has different aspects that you should consider as you migrate to the cloud. In a public cloud, services are offered over the public internet and available to anyone who wants to purchase them. Cloud resources such as servers and storage are owned and operated by a third-party cloud service provider and delivered over the internet. A private cloud consists of computing resources used exclusively by users from one business or organization. A private cloud can be physically located at your organization's on-site or on-premises data center. It can also be hosted by a third-party service provider. In the third model, hybrid cloud computing environments combine a public cloud and a private cloud by allowing data and applications to be shared between them. This image illustrates several of the cloud computing concepts that are presented in this unit. In this example, several factors are demonstrated when you are considering where to deploy a database server in a hybrid cloud environment. As your resources move from on-premises to off-premises, your costs are reduced and your administration requirements decrease. Congratulations! You have completed this lesson on cloud computing advantages. By now, you should be able to identify benefits and considerations of using cloud services, describe the differences between categories of cloud services, and describe the differences between types of cloud computing. Hello and welcome to this lesson on Azure architecture. In this lesson, you'll examine the various concepts, resources, and terminology that are necessary to work with Azure architecture. After completing this lesson, you'll be able to describe the benefits and usage of Azure subscriptions and management groups, Azure Resources, Resource Groups, and Azure Resource Manager, Azure Regions, Region Pairs, and Availability Zones. In this lesson, we will continue working on our case study as Tailwind Traders plans the adoption of Azure for their cloud computing platform. Let's say that you work as a developer for Tailwind Traders, a successful hardware manufacturing company. Your company's Chief Technology Officer recently decided to adopt Azure as the cloud computing platform. You're currently in the planning stages for the migration. Before you begin the migration process, you decide to study Azure concepts, resources, and terminology to ensure your migration is a success. So let's dive right into our case study. As part of your research for Tailwind Traders, you need to learn the organizing structure for resources in Azure, which has 4 levels: resources, resource groups, subscriptions, and management groups. Having seen the top-down hierarchy of organization, let's describe each of those levels from the bottom up. Resources. Resources are instances of services that you create, like virtual machines, storage, or SQL databases. Resource groups. Resources are combined into resource groups, which act as a logical container into which Azure resources like web apps, databases, and storage accounts are deployed and managed. Subscriptions. A subscription groups together user accounts and the resources that have been created by those user accounts. For each subscription, there are limits or quotas on the amount of resources that you can create and use. Organizations can use subscriptions to manage costs and the resources that are created by users, teams, or projects. Management groups. These groups help you manage access, policy, and compliance for multiple subscriptions. All subscriptions in a management group automatically inherit the conditions applied to the management group. You'll examine each of these 4 organizational levels in detail. As Tailwind Traders get started with Azure, one of your first steps will be to create at least one Azure subscription. You'll use it to create your cloud-based resources in Azure. An Azure resource is a manageable item that's available through Azure. Virtual machines, VMs, storage accounts, web apps, databases, and virtual networks are all examples of resources. Using Azure requires an Azure subscription. A subscription provides you with authenticated and authorized access to Azure products and services. It also allows you to provision resources. An Azure subscription is a logical unit of Azure services that links to an Azure account, which is an identity in Azure Active Directory, also called Azure AD, or in a directory that Azure AD trusts. There are two types of subscription boundaries that you can use. Billing boundary. This subscription type determines how an Azure account is billed for using Azure. You can create multiple subscriptions for different types of billing requirements. Azure generates separate billing reports and invoices for each subscription so that you can organize and manage costs. Access control boundary. Azure applies access management policies at the subscription level, and you can create separate subscriptions to reflect different organizational structures. An example is that within a business, you have different departments to which you apply distinct Azure subscription policies. This billing model allows you to manage and control access to the resources that users provision with specific subscriptions. You might want to create additional subscriptions for resource or billing management purposes. For example, you might choose to create additional subscriptions to separate environments. When managing your resources, you can choose to create subscriptions to set up separate environments for development and testing, security, or to isolate data for compliance reasons. This design is particularly useful because resource access control occurs at the subscription level. Organizational structures. You can create subscriptions to reflect different organizational structures. For example, you could limit a team to lower cost resources while allowing the IT department a full range. This design allows you to manage and control access to the resources that users provision within each subscription. Billing. You might want to also create additional subscriptions for billing purposes. Because costs are first aggregated at the subscription level, you might want to create subscriptions to manage and track costs based on your needs. For instance, you might want to create one subscription for your production workloads and another subscription for your development and testing workloads. You might also need additional subscriptions because of subscription limits. Subscriptions are bound to some hard limitations. For example, the maximum number of Azure Express Route circuits per subscription is 10. Those limits should be considered as you create subscriptions on your account. If there's a need to go over those limits in particular scenarios, you might need additional subscriptions. The diagram you will see next shows an overview of how billing is structured. If you've previously signed up for Azure, or if your organization has an enterprise agreement, your billing might be set up differently. If you have multiple subscriptions, you can organize them into invoice sections. Each invoice section is a line item on the invoice that shows the charges incurred that month. For example, you might need a single invoice for your organization, but want to organize charges by department, team, or project. Depending on your needs, you can set up multiple invoices within the same billing account. To do this, create additional billing profiles. Each billing profile has its own monthly invoice and payment method. If your organization has many subscriptions, you might need a way to efficiently manage access, policies, and compliance for those subscriptions. Azure Management Groups provide a level of scope above subscriptions. You organize subscriptions into containers called management groups and apply your governance conditions to the management groups. All subscriptions within a management group automatically inherit the conditions applied to the management group. Management groups give you enterprise-grade management at a large scale, no matter what type of subscriptions you might have. All subscriptions within a single management group must trust the same Azure AD tenant. For example, you can apply policies to a management group that limits the regions available for VM creation. This policy would be applied to all management groups, subscriptions, and resources under that management group by only allowing VMs to be created in that region. You can build a flexible structure of management groups and subscriptions to organize your resources into a hierarchy for unified policy and access management. The following diagram shows an example of creating a hierarchy for governance by using management groups. You can create a hierarchy that applies a policy. For example, you could limit VM locations to the US West region in a group called Production. This policy will inherit onto all the enterprise agreement subscriptions that are descendants of that management group and will apply to all VMs under those subscriptions. This security policy can't be altered by the resource or subscription owner, which allows for improved governance. Another scenario where you would use management groups is to provide user access to multiple subscriptions. By moving multiple subscriptions under that management group, you can create one role-based access control, RBAC, assignment on the management group, which will inherit that access to all the subscriptions. One assignment on the management group can enable users to have access to everything they need instead of scripting RBAC over different subscriptions. We will cover RBAC in more detail later in the course. There are some important facts about management groups that you should keep in mind. Up to 10,000 management groups can be supported in a single directory. A management group tree can support up to 6 levels of depth. This limit doesn't include the root level or the subscription level. Each management group and subscription can support only one parent. Each management group can have many children. All subscriptions and management groups are within a single hierarchy in each directory. After you've created a subscription for Tailwind traders, you're ready to start creating resources and storing them in resource groups. With that in mind, it's important to define those terms. Resource, a manageable item that's available through Azure. Virtual machines or VMs, storage accounts, web apps, databases, and virtual networks are examples of resources. Resource group, a container that holds related resources for an Azure solution. The resource group includes resources that you want to manage as a group. You decide which resources belong in a resource group based on what makes the most sense for your organization. Resource groups are a fundamental element of the Azure platform. A resource group is a logical container for resources deployed on Azure. These resources are anything you create in an Azure subscription, like VMs, Azure Application Gateway instances, and Azure Cosmos DB instances. All resources must be in a resource group, and a resource can only be a member of a single resource group. Many resources can be moved between resource groups, with some services having specific limitations or requirements to move. Resource groups can't be nested. Before any resource can be provisioned, you need a resource group for it to be placed in. Resource groups exist to help manage and organize your Azure resources. By placing resources of similar usage, type, or location in a resource group, you can provide order and organization to resources you create in Azure. Logical grouping is the aspect that you're most interested in here because resources can become disordered. It is a good idea to organize your resources by lifecycle in non-production environments. If you delete a resource group, all resources contained within it are also deleted. Organizing resources by lifecycle can be useful in non-production environments where you might try an experiment and then dispose of it. Resource groups make it easy to remove a set of resources all at once. You can also apply permissions to ease administration and limit access. Resource groups are also a scope for applying role-based access control permissions. By applying RBAC permissions to a resource group, you can ease administration and limit access to allow only what's needed. Azure Resource Manager, commonly referred to as ARM, is the deployment and management service for Azure. It provides a management layer that enables you to create, update, and delete resources in your Azure account. You use management features like access control, locks, and tags to secure and organize your resources after deployment. When a user sends a request from any of the Azure tools, APIs, or SDKs, Resource Manager receives the request. It authenticates and authorizes the request. Resource Manager sends the request to the Azure Service, which takes the requested action. Because all requests are handled through the same API, you see consistent results and capabilities in all the different tools. All capabilities that are available in the Azure portal are also available through PowerShell, the Azure CLI, REST APIs, and client SDKs. Functionality initially released through APIs will be represented in the portal within 180 days of initial release. Azure Resource Manager brings many benefits. With ARM, you can manage your infrastructure through declarative templates rather than scripts. An ARM template is a JSON file that defines what you want to deploy to Azure. Deploy, manage, and monitor all the resources for your solution as a group, rather than handling these resources individually. Redeploy your solution throughout the development lifecycle and have confidence your resources are deployed in a consistent state. Define the dependencies between resources so they're deployed in the correct order. Apply access control to all services because RBAC is natively integrated into the management platform. Apply tags to resources to logically organize all the resources in your subscription. Clarify your organization's billing by viewing costs for a group of resources that share the same tag. By now, you should have learned about Azure resources and resource groups. Resources are created in regions, which are different geographical locations around the globe that contain Azure data centers. Azure is made up of data centers located around the globe. When you use a service or create a resource, such as a SQL database or virtual machine, you're using physical equipment in one or more of these locations. These specific data centers aren't exposed to users directly. Instead, Azure organizes them into regions. As you'll see later in this lesson, some of these regions offer availability zones, which are different Azure data centers within that region. A region is a geographical area on the planet that contains at least one, but potentially multiple data centers that are nearby and networked together with a low latency network. Azure intelligently assigns and controls the resources within each region to ensure workloads are appropriately balanced. When you deploy a resource in Azure, you'll often need to choose the region where you want your resource deployed. It's important to note that some services or VM features are only available in certain regions, such as specific VM sizes or storage types. There are also some global Azure services that don't require you to select a particular region, such as Azure Active Directory, Azure Traffic Manager, and Azure DNS. Azure has more global regions than any other cloud provider. These regions give you the flexibility to bring applications closer to your users no matter where they are. Global regions provide better scalability and redundancy. They also preserve data residency for your services. A few examples of regions are West US, Canada Central, West Europe, Australia East, and Japan West. Here's a view of all the available regions as of June 2020. Azure has specialized regions that you might want to use when you build out your applications for compliance or legal purposes. A few examples include US Department of Defense Central, US Government Virginia, US Government Iowa, and more. These regions are physical and logical network isolated instances of Azure for US government agencies and partners. These data centers are operated by screened US personnel and include additional compliance certifications. China East, China North, and more. These regions are available through a unique partnership between Microsoft and 21Vianet, whereby Microsoft doesn't directly maintain the data centers. Regions are what you use to identify the location for your resources. There are two other terms you should also be aware of: geographies and availability zones. You want to ensure your services and data are redundant so you can protect your information in case of failure. When you host your infrastructure, setting up your own redundancy requires that you create duplicate hardware environments. Azure can help make your app highly available through availability zones. Availability zones are physically separate data centers within an Azure region. Each availability zone is made up of one or more data centers equipped with independent power, cooling, and networking. An availability zone is set up to be an isolation boundary. If one zone goes down, the other continues working. Availability zones are connected through high-speed private fiber optic networks. Not every region has support for availability zones. For an updated list, Check your documentation for Azure services that support availability zones. You can use availability zones to run mission-critical applications and build high availability into your application architecture by co-locating your compute, storage, networking, and data resources within a zone and replicating in other zones. Keep in mind that there could be a cost to duplicating your services and transferring data between zones. Availability zones are primarily for VMs, managed disks, load balancers, and SQL databases. Azure services that support availability zones fall into two categories. Zonal services. You pin the resource to a specific zone. For example, VMs, managed disks, and IP addresses. Zone redundant services. The platform replicates automatically across zones. For example, zone redundant storage, SQL database. Check the documentation to determine which elements of your architecture you can associate with an availability zone. Availability zones are created by using one or more data centers. There's a minimum of 3 zones within a single region. It's possible that a large disaster could cause an outage big enough to affect even 2 data centers. That's why Azure also creates region pairs. Each Azure region is always paired with another region within the same geography, such as US, Europe, or Asia, at least 300 miles away. This approach allows for the replication of resources, such as VM storage, across a geography that helps reduce the likelihood of interruptions because of events such as natural disasters, civil unrest, power outages, or physical network outages that affect both regions at once. If a region in a pair was affected by a natural disaster, for instance, services would automatically fail over to the other region in its region pair. An example of a region pair in Azure is West US paired with East US. Similarly, in Asia, Southeast Asia is paired with East Asia. Because the pair of regions is directly connected and far enough apart to be isolated from regional disasters, you can use them to provide reliable services and data redundancy. Some services offer automatic geo-redundant storage by using region pairs. And there are some additional advantages of region pairs. If an extensive Azure outage occurs, one region out of every pair is prioritized to make sure at least one is restored as quickly as possible for applications hosted in that region pair. Planned Azure updates are rolled out to paired regions, one region at a time, to minimize downtime and risk of application outage. Data continues to reside within the same geography as its pair, except for Brazil South, for tax and law enforcement jurisdiction purposes. Having a broadly distributed set of data centers allows Azure to provide a high guarantee of availability. Congratulations! You have completed this lesson on core Azure architecture. You saw the benefits of using cloud computing. We described the differences between categories of cloud services and the differences between types of cloud computing. We also covered Azure subscriptions and management groups. Then we described Azure Resources, Resource Groups, and Azure Resource Manager. Finally, we identified Azure regions, region pairs, and availability zones. Hello and welcome to Azure Database, Analytics, and Compute Services. In this module, you'll learn about several of the primary database services that are available on Azure. You'll analyze some of the reasons why each of these database services might be the right choice for your needs. In addition, you'll look at the big data and analysis services in Azure. You'll also examine how to take advantage of several virtualization services in Azure Compute, which can help your applications scale out quickly and efficiently to meet increasing demands. Let's take a look at our case study to see what is expected from you as the IT specialist of Tailwind Traders. Due to a growing number of acquisitions over the last decade, Tailwind Traders uses a variety of database and analytics technologies. As the company begins to migrate existing data workloads and deploy new data workloads to Azure, it needs to understand which Azure technology is the most appropriate for each workload. The company's Chief Technology Officer has assigned you the task of researching the different database options that are available. This will help Tailwind Traders choose the right options for each of their data scenarios. In this lesson, you'll focus on several of the database services that are available on Microsoft Azure, such as Azure Cosmos DB, Azure SQL Database and Azure SQL Managed Instance, Azure Database for MySQL, and Azure Database for PostgreSQL. In addition, you'll learn about several of the big data and analysis services in Azure. So let's dive right in and find out how you can help Tailwind traders. Over the years, Tailwind Traders has acquired several smaller companies. Each of these companies had teams of developers who used different database services and various APIs to work with their data. The long-term plan is to move all of the disparate data to a common database service. For now, though, you'd like to enable each of these teams to work with an environment where they can use their existing skills. Fortunately for you, Azure Cosmos DB can help out. Azure Cosmos DB is a globally distributed multi-model database service. Using Azure Cosmos DB, you can elastically and independently scale throughput and storage across any number of Azure regions worldwide. And take advantage of fast, single-digit millisecond data access by using any one of several popular APIs. The Azure Cosmos DB service offers comprehensive service-level agreements, which cover the guarantees for throughput, consistency, availability, and latency. It's important to note that servers are still running the code. Azure Cosmos DB also supports schemaless data, which lets you build highly responsive and always-on applications to support constantly changing data. You can use this feature to store data that's updated and maintained by users around the world. Now, let's take a look at an example of how Tailwind traders use Azure Cosmos DB. Tailwind Traders provides a public training portal that is used by customers across the globe to learn about the different tools that Tailwind Traders creates. Tailwind Traders developers maintain and update the data. This image shows a sample Azure Cosmos DB database that's used to store data for the Tailwind Traders training portal website. At the lowest level, Azure Cosmos DB stores data in Atom Record Sequence, ARS format. The data is then abstracted and projected as an API, which you specify when you're creating your database. Your choices include SQL, MongoDB, Cassandra, Tables, and Gremlin. Now, let's take a look at some of the key benefits you can provide to the CTO at Tailwind Traders. Azure Cosmos DB is a flexible database that provides guaranteed single-digit milliseconds response times and 99.999% availability backed by comprehensive SLAs. Elastic and independent scale throughput and storage on demand, access to multiple data models and APIs for working with your data, and the ability to globally distribute your data and build highly responsive applications. In this session, you will explore Azure SQL Database as a possible solution for Tailwind traders. So, what is Azure SQL Database? Azure SQL Database is a relational database based on the latest stable version of the Microsoft SQL Server database engine. Azure SQL Database provides you with a high-performance, reliable, fully managed and secure database. You can use it to build data-driven applications and websites in the programming language of your choice without needing to manage infrastructure. Let's take a look at some of the features provided by Azure SQL Database. Azure SQL Database is a platform as a service, PaaS database engine. It handles most of the database management functions, such as upgrading, patching, backups, and monitoring without user involvement. SQL Database also provides 99.99% availability. With Azure SQL Database, you can create a highly available and high-performance data storage layer for the applications and solutions in Azure. Microsoft handles all updates to the SQL and operating system code. You don't have to manage the underlying infrastructure. In a nutshell, Azure SQL Database is a fully managed service that has built-in high availability, backups, and other common maintenance operations. The PaaS capabilities that are built into SQL Database enable you to focus on the domain-specific database administration and optimization activities that are critical for your business. Azure SQL Database can be the right choice for a variety of modern cloud applications because it enables you to process both relational data and non-relational structures, such as graphs, JSON, spatial, and XML. You can also use advanced query processing features, such as high-performance in-memory technologies and intelligent query processing. In fact, the newest capabilities of SQL Server are released first to SQL Database and then to SQL Server itself. You get the newest SQL Server capabilities with no overhead for updates or upgrades, tested across millions of databases. Tailwind Traders currently uses several on-premises servers running SQL Server, which provide data storage for your public-facing website. For example, customer data, order history, and product catalogs. In addition, your on-premises servers running SQL Server also provide data storage for your internal-only training portal website. Tailwind Traders uses the website for new employee training materials, such as study materials, certification details, and training transcripts. This image illustrates the types of data that Tailwind Traders might store in the Azure SQL Database Training Portal website. You can migrate your existing SQL Server databases with minimal downtime by using the Azure Database Migration Service. After you assess and resolve any remediation required, you're ready to begin the migration process. The Azure Database Migration Service performs all of the required steps. You just change the connection string in your apps. Azure SQL Managed Instance is a scalable cloud data service that provides the broadest SQL Server database engine compatibility with all the benefits of a fully managed platform as a service. Depending on your scenario, Azure SQL Managed Instance might offer more options for your database needs. Like Azure SQL Database, Azure SQL Managed Instance is a platform as a service database engine, which means that your company will be able to take advantage of the best features of moving your data to the cloud in a fully managed environment. Let's take a look at an example of the benefits for Tailwind Traders. Using a fully managed environment, Tailwind Traders will no longer need to purchase and manage expensive hardware, and won't have to maintain the additional overheads of managing on-premises infrastructure. On the other hand, Tailwind Traders will benefit from the quick provisioning and service scaling features of Azure, together with automated patching and version upgrades. In addition, Tailwind Traders can rest assured that their data will always be there when they need it through built-in high availability features and a 99.99% uptime service level agreement. They'll also be able to protect their data with automated backups and a configurable backup retention period. Azure SQL Database and Azure SQL Managed Instance offer many of the same features. However, Azure SQL Managed Instance provides several options that might not be available to Azure SQL Database. In this example, Tailwind Traders currently uses several on-premises servers running SQL Server, and they would like to migrate their existing databases to a SQL database running in the cloud. However, several of their databases use Cyrillic characters for collation. In this scenario, Tailwind Traders should migrate their databases to an Azure SQL Managed Instance. One of the features of Azure SQL Managed Instance is that server-level collation can be specified when the instance is created. On the other hand, Azure SQL Database only uses the default SQL_Latin1_General_CP1_CI_AS server collation. It's important to note that although you can change server-level collation in SQL Managed Instance, it cannot be changed once the instance has been created. Azure SQL Managed Instance makes it easy to migrate your on-premises data on SQL Server to the cloud using the Azure Database Migration Service, DMS, or native backup and restore. This image illustrates the migration process flow. Let's go through this. After you've discovered all of the features that your company uses, you need to assess which on-premises SQL Server instances you can migrate to Azure SQL Managed Instance to see if you have any blocking issues. Once you have resolved any issues, you can migrate your data, then cut over from your on-premises SQL Server to your Azure SQL Managed Instance by changing the connection string in your applications. As part of your planning for your migration strategy, the different teams at Tailwind Traders have been researching the available service offerings that Azure provides. You've been tasked with investigating whether the database requirements for the web development team will continue to be met after the migration to Azure. Tailwind Traders currently manages several websites on premises that use the LAMP stack: Linux, Apache, MySQL, PHP. You'll discover that the Web Apps feature of the Azure App Service provides built-in functionality to create web applications that use PHP on a Linux server running Apache. Now, let's explore Azure Database for MySQL. Azure Database for MySQL is a relational database service in the cloud, and it's based on the MySQL Community Edition database engine. With it, you have a 99.99% availability service level agreement from Azure, powered by a global network of Microsoft managed data centers. This helps keep your app running 24/7. With every Azure Database for MySQL server, you take advantage of built-in security, fault tolerance, and data protection that you would otherwise have to buy or design, build, and manage. With Azure Database for MySQL, you can use point-in-time restore to recover a server to an earlier state as far back as 35 days. Azure Database for MySQL delivers built-in high availability with no additional cost, predictable performance, and inclusive pay-as-you-go pricing, scale as needed within seconds, ability to protect sensitive data at rest and in motion, automatic backups, and enterprise-grade security and compliance. These capabilities require almost no administration, and all are provided at no additional cost. They allow you to focus on rapid app development and accelerating your time to market rather than having to manage virtual machines and infrastructure. In addition, you can migrate your existing MySQL databases with minimal downtime by using the Azure Database Migration Service. After you've completed your migration, you can continue to develop your application with the open source tools and platform of your choice. You don't have to learn new skills. Azure Database for MySQL offers several service tiers, and each tier provides different performance and capabilities to support lightweight to heavyweight database workloads. You can build your first app on a small database for a few dollars a month and then adjust the scale to meet the needs of your solution. Dynamic scalability enables your database to transparently respond to rapidly changing resource requirements. You only pay for the resources you need and only when you need them. Now that you've explored the Azure Database for MySQL, let's go through some of the key findings in your investigation. By using Azure Database MySQL, Tailwind traders will be able to focus on rapid app development and accelerating time to market rather than having to manage virtual machines and infrastructure. Develop applications with the open source tools using a platform of their choice. Deliver with speed and efficiency without having to learn new skills. Use built-in features such as automated patching, high availability, automated backups, elastic scaling, enterprise-grade security, compliance and governance, monitoring and alerting. And pay only for what is used with options to scale up or scale out for greater control with no interruption. As part of its overall data strategy, Tailwind Traders has been using PostgreSQL for several years. You and your team probably already know the benefits of PostgreSQL. Part of your migration is to use Azure Database for PostgreSQL, and you want to make sure that you'll have access to the same benefits as your on-premises server before moving to the cloud. Let's take a closer look at Azure Database for PostgreSQL. Azure Database for PostgreSQL is a relational database service in the cloud. The server software is based on the community version of the open source PostgreSQL database engine. Your familiarity with tools and expertise with PostgreSQL is applicable when you're using Azure Database for PostgreSQL. Let's discuss the key benefits of Azure Database for PostgreSQL. Azure Database for PostgreSQL delivers the following benefits. Built-in high availability compared to on-premises resources. There's no additional configuration, replication, or cost required to make sure your applications are always available. Simple and flexible pricing. You have predictable performance based on a selected pricing tier choice that includes software patching, automatic backups, monitoring, and security. Scale up or down as needed within seconds. You can scale, compute, or storage independently as needed to make sure you adapt your service to match usage. Adjustable automatic backups and point-in-time restore for up to 35 days. And enterprise-grade security and compliance to protect sensitive data at rest and in motion. This security covers data encryption on disk and SSL encryption between client and server communication. Azure Database for PostgreSQL is available in 2 deployment options: single server and hyperscale Citus. First, let's take a look at the single server option capabilities. The single server option delivers built-in high availability with no additional cost and a 99.99% uptime service level agreement. Predictable performance and inclusive pay-as-you-go pricing. Vertical scale is needed within seconds. Enterprise-grade security and compliance. Monitoring and alerting to assess your server. Ability to protect sensitive data at rest and in motion. And automatic backups and point-in-time restore for up to 35 days. These capabilities require almost no administration and all are provided at no additional cost. They allow you to focus on rapid app development and accelerating your time to market, rather than having to manage virtual machines and infrastructure. You can continue to develop your application with the open source tools and platform of your choice without having to learn new skills. The single server option offers 3 pricing tiers: basic, general purpose, and memory optimized. Each tier offers different resource capabilities to support your database workloads. You can build your first app on a small database for a few dollars a month and then adjust the scale to meet the needs of your solution. Dynamic scalability enables your database to transparently respond to rapidly changing resource requirements. You only pay for the resources you need and only when you need them. Now, let's explore the second PostgreSQL deployment option, hyperscale Citus. The hyperscale Citus option horizontally scales queries across multiple machines by using sharding. Its query engine parallelizes incoming SQL queries across these servers for faster responses on large data sets. It serves applications that require greater scale and performance, generally workloads that are approaching or already exceed 100 gigabytes of data. The hyperscale Citus deployment option supports multi-tenant applications, real-time operational analytics, and high-throughput transactional workloads. Applications built for PostgreSQL can run distributed queries on hyperscale Citus with standard connection libraries and minimal changes. Thinking on Tailwind Traders' overall migration strategy, you can quickly and easily develop applications using Azure Database for PostgreSQL. Tailwind Traders will also be able to use native PostgreSQL tools, drivers, and libraries without worrying about having to manage and administrate the instances themselves. Several years ago, Tailwind Traders rolled out a new GPS tracking system for all of its delivery vehicles. The new system provides real-time tracking data to your primary data center. Your CTO wants your team to look at several years of tracking data in order to determine trends. For example, an important trend might be a spike in deliveries around the holidays that would require hiring additional staff. Through an in-depth analysis of the tracking data that you've recorded, your CTO seeks to predict when changes are necessary and proactively take the steps that are necessary to manage spikes appropriately. In this Tailwind Trader scenario, data is collected from the GPS sensors, which includes location information, data from weather systems, and many other sources that generate large amounts of data. This amount of data becomes increasingly hard to make sense of and to base decisions on. The volumes are so large that traditional forms of processing and analysis are no longer appropriate. Data comes in all forms and formats. When we talk about big data, we're referring to large volumes of data. Open source cluster technologies have been developed over time to try to deal with these large data sets. In this session, we will explore Microsoft Azure's broad range of technologies and services that provide big data and analytics solutions, including Azure Synapse Analytics, Azure HD Insight, Azure Databricks, and Azure Data Lake Analytics. Let's start exploring these solutions. Azure Synapse Analytics, formerly Azure SQL Data Warehouse, is a limitless analytics service that brings together enterprise data warehousing and big data analytics. You can query data on your terms by using either serverless or provisioned resources at scale. With Azure Synapse Analytics, you have a unified experience to ingest, prepare, manage, and serve data for immediate BI and machine learning needs. Azure HD Insight is a fully managed open source analytics service for enterprises. It's a cloud service that makes it easier, faster, and more cost effective to process massive amounts of data. You can run popular open source frameworks and create cluster types such as Apache Spark, Apache Hadoop, Apache Kafka, Apache HBase, Apache Storm, and machine learning services. HD Insight also supports a broad range of scenarios such as extraction, transformation and loading, ETL, data warehousing, machine learning, and IoT. Azure Databricks helps you unlock insights from all your data and build artificial intelligence solutions. You can set up your Apache Spark environment in minutes and then auto-scale and collaborate on shared projects in an interactive workspace. Azure Databricks supports Python, Scala, R, Java, and SQL, as well as data science frameworks and libraries, including TensorFlow, PyTorch, and scikit-learn. Azure Data Lake Analytics is an on-demand analytics job service that simplifies big data. Instead of deploying, configuring, and tuning hardware, you write queries to transform your data and extract valuable insights. The analytics service can handle jobs of any scale instantly by setting the dial for how much power you need. With Azure Data Lake Analytics, you only pay for your job when it's running, making it more cost-effective. Congratulations! You have completed this lesson on Azure Database Fundamentals. In this lesson, you explored several of the database services that are available on Microsoft Azure. In addition, you learned how you can use big data and analysis services like Azure Synapse Analytics, Azure HD Insight, Azure Databricks, and Azure Data Lake Analytics to analyze large volumes of data. By now, you should be able to describe the benefits and usage of Azure Cosmos DB, Azure SQL Database and SQL Managed Instance, Azure Database for MySQL and PostgreSQL, and Azure Synapse Analytics, HD Insight, and Azure Databricks. Hello and welcome back. In this lesson, you'll learn how to take advantage of several virtualization services in Azure Compute, which can help your applications scale out quickly and efficiently to meet increasing demands. Now, let's take a look at our case study. Imagine that you work as a development lead at Tailwind Traders, a company that specializes in hardware manufacturing. Your management team tells you that the company's website has been having a difficult time keeping up with the application demands. The team wants you to investigate a solution. The front-end web servers are operating near capacity during peak periods of the day, and you need to get a solution in place quickly. But there's a problem. You don't have any free servers to scale out your application. You could ask to buy new equipment, but your department's budget is tight. You want to make a good impression with leadership, but you don't know how many servers are necessary for this project, and you don't want to buy more hardware than you need. Even if you are able to procure several servers, you'd need to invest a lot of time to set them up and install software. Ideally, you'd obtain the resources you need to do the work without too much administration and configure them to do the work. You'd also pay only for the compute resources you need while you're using them. This is the ideal scenario for Tailwind Traders, and you can do this in Azure. Using Azure, you can create compute resources, configure them to do the work that's needed, and pay for only what you use. By the end of this lesson, you will be able to describe the benefits and usage of Azure Virtual Machines, Azure App Service, Azure Container Instances, Azure Kubernetes Service, Azure Functions, and Windows Virtual Desktop. Let's start this session by looking at an overview of Azure Compute. Azure Compute is an on-demand computing service for running cloud-based applications. It provides computing resources such as disks, processors, memory, networking, and operating systems. The resources are available on demand and can typically be made available in minutes or even seconds. You pay only for the resources you use and only for as long as you're using them. Azure supports a wide range of computing solutions for development and testing, running applications, and extending your data center. The service supports Linux, Windows Server, SQL Server, Oracle, IBM, and SAP. Azure also has many services that can run virtual machines. Each service provides different options depending on your requirements. In this lesson, you will examine some of the main services, including Azure Virtual Machines, including Virtual Machine Scale Set, Azure Container Instances, including Azure Kubernetes, Azure App Service, and Azure Functions or Serverless computing. So what are virtual machines? Virtual machines are software emulations of physical computers. They include a virtual processor, memory, storage, and networking resources. Virtual machines host an operating system, and you can install and run software just like a physical computer. When using a remote desktop client, you can use and control the virtual machine as if you were sitting in front of it. With Azure Virtual Machines, you can create and use virtual machines in the cloud. Virtual machines, also known as VMs, provide infrastructure as a service, IaaS, and can be used in different ways. When you need total control over an operating system and environment, virtual machines are an ideal choice. Just like a physical computer, you can customize all the software running on the virtual machine. This ability is helpful when you're running custom software or custom hosting configurations. For example, if Tailwind Traders wants to provision Linux and Windows virtual machines with the configurations of their choice, they could do so in seconds using Azure Virtual Machine services. You know that virtual machines are software emulations of physical computers, but what are virtual machine scale sets? Virtual machine scale sets are an Azure compute resource that you can use to deploy and manage a set of identical virtual machines. Azure Virtual Machine Scale Sets lets you create and manage a group of identical load-balanced virtual machines. Scale sets allow you to centrally manage, configure, and update a large number of virtual machines in minutes to provide highly available applications. The number of virtual machine instances can automatically increase or decrease in response to demand or a defined schedule. For this reason, it's easier to build large-scale services targeting big compute, big data, and containerized workloads. As demand goes up, more virtual machine instances can be added. As demand goes down, virtual machine instances can be removed. The process can be manual, automated, or a combination of both. For example, if Tailwind Traders want to achieve high availability by auto-scaling to create thousands of virtual machines, they could do so in minutes using virtual machine scale sets. Let's take a look at some more Azure compute resources. Container instances and Azure Kubernetes Service, or AKS, are Azure compute resources that you can use to deploy and manage containers. Containers are lightweight virtualized application environments. They're designed to be quickly created, scaled out, and stopped dynamically. You can run multiple instances of a containerized application on a single host machine. For example, if Tailwind Traders wants to containerize apps and easily run containers with a single command, they would use container instances. Azure Kubernetes Service is also ideal to simplify the deployment, management, and operations of Kubernetes. You have learned that Azure Virtual Machines provide infrastructure as a service, or IaaS. Azure App Service, on the other hand, is a platform as a service, or PaaS offering. With Azure App Service, you can quickly build, deploy, and scale enterprise-grade web, mobile, and API apps running on any platform. You can meet rigorous performance, scalability, security, and compliance requirements while using a fully managed platform to perform infrastructure maintenance. For example, if Tailwind Traders wants to quickly create cloud apps for web and mobile with fully managed platform, they can use Azure App Service. Let's suppose you're not concerned about the underlying platform or infrastructure, but only about the code running your service. Functions are ideal for this scenario. They're commonly used when you need to perform work in response to an event, often via a REST request, timer, or message from another Azure service, and when that work can be completed quickly, within seconds or less. For example, if Tailwind Traders wants to accelerate app development using an event-driven serverless architecture, they can use Azure Functions. In this session, you have started gathering information that will help you to resolve Tailwind Traders' challenges. You looked at an overview of Azure Virtual Machines, Azure App Service, Azure Container Instances, Azure Kubernetes, Azure Functions, and Virtual Machine Scale Set. In this session, you continue to explore the possible Azure solutions that can help you scale out your applications. One possible solution to tailwind traders' lack of physical service is using virtual machines. Let's dive right in and explore virtual machines as a solution. With Azure Virtual Machines, you can create and use virtual machines in the cloud. Virtual machines provide infrastructure as a service in the form of a virtualized server and can be used in many ways. Just like a physical computer, you can customize all of the software running on the virtual machines. Virtual machines are an ideal choice when you need total control over the operating system, the ability to run custom software, and to use custom hosting configurations. An Azure Virtual Machine gives you the flexibility of virtualization without having to buy and maintain the physical hardware that runs the virtual machine. You still need to configure, update, and maintain the software that runs on the virtual machine. You can create and provision a virtual machine in minutes when you select a pre-configured virtual machine image. Selecting an image is one of the most important decisions you'll make when you create a virtual machine. An image is a template used to create a virtual machine. These templates already include an operating system and often other software like development tools or web hosting environments. Here are some examples of when to use virtual machines. During testing and development, virtual machines provide a quick and easy way to create different operating system and application configurations. Test and development personnel can then easily delete the virtual machines when they no longer need them. When running applications in the cloud, the ability to run certain applications in the public cloud as opposed to creating a traditional infrastructure to run them can provide substantial economic benefits. For example, an application might need to handle fluctuations in demand. Shutting down VMs when you don't need them or quickly starting them up to meet a sudden increase in demand means you pay only for the resources you use. When extending your data center to the cloud, an organization can extend the capabilities of its own on-premises network by creating a virtual network in Azure and adding VMs to that virtual network. Applications like SharePoint can then run on an Azure VM instead of running locally. This arrangement makes it easier or less expensive to deploy than in an on-premises environment. During disaster recovery, as with running certain types of applications in the cloud and extending an on-premises network to the cloud, you can get significant cost savings by using an IaaS-based approach to disaster recovery. If a primary data center fails, you can create VMs running on Azure to run your critical applications and then shut them down when the primary data center becomes operational again. Virtual machines are also an excellent choice when you move from a physical server to the cloud. This is also known as lift and shift. You can create an image of the physical server and host it within a virtual machine with little or no changes. Just like a physical on-premises server, you must maintain the virtual machine. You update the installed operating system and the software it runs. You can run single virtual machines for testing, development, or minor tasks. Or you can group virtual machines together to provide high availability, scalability, and redundancy. No matter what your uptime requirements are, Azure has several features that can meet them. These features include virtual machine scale sets, Azure Batch. Let's start off by looking at virtual machine scale sets. Virtual machine scale sets lets you create and manage a group of identical load-balanced virtual machines. Imagine you're running a website that enables scientists to upload astronomy images that need to be processed. If you duplicated the virtual machine, you'd normally need to configure an additional service to route requests between multiple instances of the website. Virtual machine scale sets could do that work for you. Scale sets allow you to centrally manage, configure, and update a large number of virtual machines in minutes to provide highly available applications. The number of virtual machine instances can automatically increase or decrease in response to demand or a defined schedule. With virtual machine scale sets, you can build large-scale services for areas such as compute, big data, and other container workloads. Now that you have explored virtual scale sets, Let's take a look at Azure Batch. Azure Batch enables large-scale parallel and high-performance computing, or HPC, batch jobs with the ability to scale to tens, hundreds, or thousands of virtual machines. When you're ready to run a job, Batch does the following. Starts a pool of compute virtual machines for you. Installs applications and staging data. Runs jobs with as many tasks as you have. Identifies failures. Re-queues work. Scales down the pool as work completes. There might be situations in which you need raw computing power or supercomputer level compute power. Azure provides these capabilities. In this session, we learned that Tailwind Traders' front-end web servers are operating near capacity during peak periods of the day. As a solution to match customer demand, scale sets can automatically increase the number of virtual machine instances as application demand increases. Then reduce the number of VM instances as demand decreases. This ability helps reduce costs and efficiently create Azure resources as required. In the previous session, you identified that virtual machines are an ideal choice when you need total control over an operating system and environment. While virtual machines are an excellent way to reduce costs versus the investments that are necessary for physical hardware, they're still limited to a single operating system per virtual machine. If you want to run multiple instances of an application on a single host machine, containers are an excellent choice. Containers are a virtualization environment. Much like running multiple virtual machines on a single physical host, you can run multiple containers on a single physical or virtual host. Unlike virtual machines, you don't manage the operating system for a container. Virtual machines appear to be an instance of an operating system that you can connect to and manage, but containers are lightweight and designed to be created, scaled out, and stopped dynamically. While it's possible to create and deploy virtual machines as application demand increases, containers are designed to allow you to respond to changes on demand. With containers, you can quickly restart in case of a crash or hardware interruption. One of the most popular container engines is Docker, which is supported by Azure. As you investigate the possible Azure solutions that are available to meet your needs, it's important to compare the different features and benefits. If you were to select container instances as an option, how would you manage this? Containers are managed through a container orchestrator, which can start, stop, and scale out application instances as needed. There are two ways to manage both Docker and Microsoft-based containers in Azure. Azure Container Instances, or ACI, and Azure Kubernetes Service, or AKS. Azure Container Instances offers the fastest and simplest way to run a container in Azure without having to manage any virtual machines or adopt any additional services. It's a platform as a service offering that allows you to upload your containers, which it runs for you. Azure Kubernetes Service is a complete orchestration service for containers with distributed architectures and large volumes of containers. Orchestration is the task of automating and managing a large number of containers and how they interact. Containers are often used to create solutions by using a microservice architecture. A microservice architecture consists of a collection of small autonomous services. Each service is self-contained and should implement a single business capability. This image illustrates the microservices architecture. This architecture is where you break solutions into smaller, independent pieces. For example, you might split a website into a container hosting your front end, another hosting your back end, and a third for storage. This split allows you to separate portions of your app into logical sections that can be maintained, scaled, or updated independently. Imagine your website backend has reached capacity, but the front end and storage aren't being stressed. You could scale the backend separately to improve performance, decide to use a different storage service, and replace the storage container without affecting the rest of the application. In your research for Tailwind Traders, you've looked at two different ways that you can virtualize your application. Another alternative is to deploy your application's front-end websites to Azure App Service, which makes it easy to respond to application demand. App Service enables you to build and host web apps, background jobs, mobile backends, and RESTful APIs in the programming language of your choice without managing infrastructure. It offers automatic scaling and high availability. App Service supports Windows and Linux and enables automated deployments from GitHub, Azure DevOps, or any Git repo to support a continuous deployment model. This platform as a service environment allows you to focus on the website and API logic, while Azure handles the infrastructure to run and scale your web applications. You pay for the Azure compute resources your app uses while it processes requests based on the app service plan you choose. The app service plan determines how much hardware is devoted to your host. For example, the plan determines whether it's dedicated or shared hardware and how much memory is reserved for it. There's even a free tier you can use to host small, low-traffic sites. With App Service, you can host most common app service styles, like web apps, API apps, web jobs, and mobile apps. App Service handles most of the infrastructure decisions you deal with in hosting web-accessible apps. Deployment and management are integrated into the platform. Endpoints can be secured. Sites can be scaled quickly to handle high traffic loads. The built-in load balancing and traffic manager provide high availability. All of these app styles are hosted in the same infrastructure and share these benefits. This flexibility makes App Service the ideal choice to host web-oriented applications. App Service includes full support for hosting web apps by using ASP.NET, ASP.NET Core, Java, Ruby, Node.js, PHP, or Python. You can choose either Windows or Linux as the host operating system. Much like hosting a website, you can build REST-based web APIs by using your choice of language and framework. You get full Swagger support and the ability to package and publish your API in Azure Marketplace. The produced apps can be consumed from any HTTP or HTTPS-based client. You can use the web jobs feature to run a program, .exe, Java, PHP, Python, or Node.js, or script, .cmd, .bat, PowerShell, or Bash, in the same context as a web app, API app, or mobile app. They can be scheduled or run by a trigger. Web jobs are often used to run background tasks as part of your application logic. You can also use the mobile apps feature of App Service to quickly build a backend for iOS and Android apps. With just a few clicks in the Azure portal, you can store mobile app data in a cloud-based SQL database. Authenticate customers against common social providers such as MSA, Google, Twitter, and Facebook. Send push notifications. Execute custom backend logic in C# or Node.js. On the mobile app side, there's SDK support for native iOS and Android, Xamarin, and React native apps. To summarize, Azure App Service is a fully managed web hosting service for building web apps, mobile backends, and RESTful APIs. Azure App Service also provides pricing and performance options that cater for every need, from small websites to globally scaled web applications. After consulting with several of your fellow developers at Tailwind Traders, you've determined that some of your application logic is event-driven. In other words, for a large amount of time, your application is waiting for a particular input before it performs any processing. To reduce your costs, you want to avoid having to pay for the time that your application is waiting for input. With that in mind, you've decided to investigate Azure Functions to see if it can help. Azure Functions is the serverless computing service hosted on the Microsoft Azure public cloud. Azure Functions and serverless computing in general is designed to accelerate and simplify application development. Before launching straight in, let's first look at serverless computing. Serverless computing is the abstraction of servers, infrastructure, and operating systems. With serverless computing, Azure takes care of managing the server infrastructure and the allocation and deallocation of resources based on demand. Infrastructure isn't your responsibility. Scaling and performance are handled automatically. You're billed only for the exact resources you use. There's no need to even reserve capacity. Serverless computing includes the abstraction of servers, an event-driven scale, and microbilling. Let's explore each of these concepts. Serverless computing abstracts the servers you run on. You never explicitly reserve server instances. The platform manages that for you. Each function execution can run on a different compute instance. This execution context is transparent to the code. With serverless architecture, you deploy your code, which then runs with high availability. Serverless computing is an excellent fit for workloads that respond to incoming events. Events include triggers by timers, for example, if a function needs to run every day at 10 a.m. UTC. HTTP, for example, API and webhook scenarios. Queues, for example, with order processing, and much more. Instead of writing an entire application, the developer authors a function which contains both code and metadata about its triggers and bindings. The platform automatically schedules the function to run and scales the number of compute instances based on the rate of incoming events. Triggers define how a function is invoked. Bindings provide a declarative way to connect to services from within the code. Traditional computing bills for a block of time, like paying a monthly or annual rate for website hosting. This method of billing is convenient, but isn't always cost-effective. Even if a customer's website gets only one hit a day, they still pay for a full day's worth of availability. With serverless computing, they pay only for the time their code runs. If no active function executions occur, they're not charged. For example, if the code runs once a day for 2 minutes, they're charged for 1 execution and 2 minutes of computing time. Azure has 2 implementations of serverless compute. Functions can execute code in almost any modern language, and logic apps are designed in a web-based designer and can execute logic triggered by Azure services without writing any code. Let's first take a look at Azure Functions. When you're concerned only about the code running your service and not the underlying platform or infrastructure, using Azure Functions is ideal. Functions are commonly used when you need to perform work in response to an event, often via a REST request, timer, or message from another Azure service, and when that work can be completed quickly, within seconds or less. Using a virtual machine-based approach, you'd incur costs even when the virtual machine is idle. With Functions, Azure runs your code when it's triggered and automatically deallocates resources when the function is finished. In this model, you're only charged for the CPU time used while your function runs. Functions can be either stateless or stateful. When they're stateless, the default, they behave as if they're restarted every time they respond to an event. When they're stateful, called durable functions, a context is passed through the function to track prior activity. Functions are a key component of serverless computing. They're also a general compute platform for running any type of code. If the needs of the developer's app change, you can deploy the project in an environment that isn't serverless. This flexibility allows you to manage scaling, run on virtual networks, and even completely isolate the functions. In our case study, Tailwind Traders, you determined that some of your application logic is event-driven. To reduce your costs, you want to avoid having to pay for the time that your application is waiting for input. Azure Functions is ideal in this scenario. The serverless app runs only when it's triggered by an event. The provider charges only for compute time used by that execution, rather than a flat monthly fee for maintaining a physical or virtual server. Now you'll explore Azure Logic Apps. Logic apps are similar to functions. Both enable you to trigger logic based on an event. Where functions execute code, logic apps execute workflows that are designed to automate business scenarios and are built from predefined logic blocks. Every Azure Logic App workflow starts with a trigger, which fires when a specific event happens, or when newly available data meets specific criteria. Many triggers include basic scheduling capabilities, so developers can specify how regularly their workloads will run. Each time the trigger fires, the Logic Apps engine creates a Logic App instance that runs the actions in the workflow. These actions can also include data conversions and flow controls, such as conditional statements, switch statements, loops, and branching. You create Logic App workflows by using a visual designer on the Azure portal or in Visual Studio. The workflows are persisted as a JSON file with a known workflow schema. Azure provides more than 200 different connectors and processing blocks to interact with different services. These resources include the most popular enterprise apps. You can also build custom connectors and workflow steps if the service you need to interact with isn't covered. You then use the Visual Designer to link connectors and blocks together. You pass data through the workflow to do custom processing, often all without writing any code. As an example, let's say a ticket arrives in Zendesk. You could detect the intent of the message with cognitive services, create an item in SharePoint to track the issue, add the customer to your Dynamics 365 CRM system if they aren't already in your database, send a follow-up email to acknowledge their request. All of those actions could be designed in a Visual Designer, which makes it easy to see the logic flow. For this reason, it's ideal for a business analyst role. In addition to the challenges that Tailwind Traders has been facing with application scale, your manager has asked you to put together a new development team of remote workers. This task would normally require setting up several new computers with all of the requisite development tools for your new team. Then you would need to ship them to the respective developers across the country. The time to procure, set up, and ship each of these computers would be costly. Also, all of your new developers have their own computing devices that are running a mixture of Windows, Android, and Mac OS operating systems. You want to find a way to expedite the deployment process for your remote workers. You also want to keep your management costs to a minimum. With that in mind, you want to see how Windows Virtual Desktop can help your organization. Windows Virtual Desktop on Azure is a desktop and application virtualization service that runs on the cloud. It enables your users to use a cloud-hosted version of Windows from any location. Windows Virtual Desktop works across devices like Windows, Mac, iOS, Android, and Linux. It works with apps that you can use to access remote desktops and apps. You can also use most modern browsers to access Windows Virtual Desktop hosted experiences. Why should you use Windows Virtual Desktop? Windows Virtual Desktop provides the best user experience. Users have the freedom to connect to Windows Virtual Desktop with any device over the internet. They use a Windows Virtual Desktop client to connect to their published Windows desktop and applications. This client could either be a native application on the device or the Windows Virtual Desktop HTML5 web client. You can make sure your session host virtual machines run near apps and services that connect to your data center or the cloud. This way, your users stay productive and don't encounter long load times. User sign-in to Windows Virtual Desktop is fast because user profiles are containerized by using FSLogix. At sign-in, the user profile container is dynamically attached to the computing environment. The user profile is immediately available and appears in the system exactly like a native user profile. You can provide individual ownership through personal, persistent desktops. For example, you might want to provide personal remote desktops for members of an engineering team. Then they can add or remove programs without impacting other users on that remote desktop. Windows Virtual Desktop also provides enhanced security. Windows Virtual Desktop provides centralized security management for users' desktops with Azure Active Directory, Azure AD. You can enable multi-factor authentication to secure user sign-ins. You can also secure access to data by assigning granular role-based access controls, or RBACs, to users. With Windows Virtual Desktop, the data and apps are separated from the local hardware. Windows Virtual Desktop runs them instead on a remote server. The risk of confidential data being left on a personal device is reduced. User sessions are isolated in both single and multi-session environments. Windows Virtual Desktop also improves security by using reverse connect technology. This connection type is more secure than the remote desktop protocol. We don't open inbound ports to the session host virtual machines. Some of the key features of Windows Virtual Desktop include simplified management, performance management, and multi-session Windows 10 deployment. Let's dive right in to find out more. Let's start off with simplified management. Windows Virtual Desktop is an Azure service, so it will be familiar to Azure administrators. You use Azure AD and RBACs to manage access to resources. With Azure, you also get tools to automate VM deployments, manage VM updates, and provide disaster recovery. As with other Azure services, Windows Virtual Desktop uses Azure Monitor for monitoring and alerts. This standardization lets admins identify issues through a single interface. Now, let's take a look at the performance management feature of Windows Virtual Desktop. Windows Virtual Desktop gives you options to load balance users on your virtual machine host pools. Host pools are collections of virtual machines with the same configuration assigned to multiple users. For the best performance, you can configure load balancing to occur as users sign in, breath mode. With breath mode, users are sequentially allocated across the host pool for your workload. To save costs, you can configure your virtual machines for depth mode load balancing where users are fully allocated on one virtual machine before moving on to the next. Windows Virtual Desktop provides tools to automatically provision additional virtual machines when incoming demand exceeds a specified threshold. Another key feature is the ability to set up a multi-session Windows 10 deployment that delivers a full Windows 10 with scalability. Windows Virtual Desktop lets you use Windows 10 Enterprise Multi-Session, the only Windows client-based operating system that enables multiple concurrent users on a single virtual machine. Windows Virtual Desktop also provides a more consistent experience with broader application support compared to Windows server-based operating systems. You have investigated the features and benefits that are available using Windows Virtual Desktop. What about costs? Costs are always something you should consider before you make a decision on using any services. So how can you reduce costs with Windows Virtual Desktop? One way to reduce costs is that you can use your existing Microsoft licenses. Windows Virtual Desktop is available to you at no additional cost if you have an eligible Microsoft 365 license. You only pay for the Azure resources used by Windows Virtual Desktop. Further examples of cost savings include Windows 10 Enterprise and Windows 7 Enterprise desktops and apps are available at no additional costs when you present an eligible Windows or Microsoft 365 license. Windows Server Remote Desktop Services desktops and apps are also available at no additional cost if you are a Microsoft Remote Services Client Access license customer. Another way to reduce costs associated with Windows Virtual Desktop is to save on compute costs. If you buy a 1-year or 3-year Azure Reserved Virtual Machine instances, you can save up to 72% versus paying as you go pricing. You can pay for a reservation upfront or monthly. Reservations provide a billing discount and don't affect the runtime state of your resources. In our case study, you saw that Windows Virtual Desktop was a great way to expedite the deployment process for your remote workers while simultaneously managing the associated costs. Let's review some of the key benefits Windows Virtual Desktop can bring to your business. Windows Virtual Desktop works across devices like Windows, Mac, iOS, Android, and Linux. Provides virtualization on any personal device from any internet-connected location. Gives you access at no additional cost when you use eligible Windows or Microsoft 365 licenses. Pay only for what you use. Keeps your virtual desktop secure by leveraging reverse connections and security solutions. Congratulations! You have completed this module, Azure Database Analytics and Compute Services. In the first lesson, you learned how to help Tailwind traders migrate its database workloads to Microsoft Azure. You saw how Azure SQL Database, Azure Database for MySQL, and Azure Database for PostgreSQL will enable your company to migrate its existing SQL Server, MySQL, and PostgreSQL databases to the cloud. You can do this even while preserving your company's development and database administration strengths. In addition, you saw how Azure Cosmos DB works with a variety of popular APIs, including SQL, MongoDB, Cassandra, Tables, and Gremlin. You can use these to migrate your data to the cloud and retain or enhance your developers' skill sets. You also learned how you can use big data and analysis services like Azure Synapse Analytics, Azure HD Insight, Azure Databricks, and Azure Data Lake Analytics to analyze large volumes of data. You also learned how you can help Tailwind traders resolve its application demand challenges using Azure virtualization services like Azure Virtual Machines, Azure Container Instances, and Azure Kubernetes Service. You also learned how you can use Azure App Service to create your website front ends, Azure Functions to create event-driven application logic that only runs when you need it. Windows Virtual Desktop to quickly provide a customized operating system and software environment for your remote workers. Hello and welcome to Azure Storage and Networking Services. In this lesson, you'll learn about the different Azure storage options and the scenarios in which each is appropriate. More specifically, after completing this lesson, you'll be able to describe the benefits and usage of Azure Blob Storage, Azure Disk Storage, Azure File Storage, Azure Blob Access Tiers. We are going back to our case study so you can apply what you learn as we go along. Suppose your company, Tailwind Traders, has a number of product brochures, data sheets, product images, and other files that are related to marketing, sales, and support. In the past, your company has been hosting these files on standalone web servers in your data center. Tailwind is now in the process of migrating its applications to the cloud, and your development team is currently architecting new applications. Your Chief Technology Officer wants to migrate all of your marketing, sales, and support files to the cloud in order to take advantage of geographic distribution of your files. This move also reduces the number of physical servers that your company maintains in your data center. As part of your migration strategy, you need to determine the correct approach for your cloud-based storage infrastructure. The CTO of your company, Tailwind Traders, has tasked your team with migrating all of your files to the cloud. Your team has chosen Azure Storage, which is a service that you can use to store files, messages, tables, and other types of information. Clients such as websites, mobile apps, desktop applications, and many other types of custom solutions can read data from and write data to Azure Storage. Azure Storage is also used by infrastructure as a service virtual machines and platform as a service cloud services. To begin using Azure Storage, you first create an Azure Storage account to store your data objects. You can create an Azure Storage account by using the Azure Portal, PowerShell, or the Azure CLI. You should note that Azure Storage is not the same as Azure Database Services. Your storage account will contain all of your Azure Storage data objects, such as blobs, files, and disks. For example, by using storage accounts to store her files in the cloud, Sally will be able to access these files through a unique namespace using HTTP or HTTPS. These files will be highly available and securely stored within this Azure Storage account. Please note that Azure VMs use Azure Disk Storage to store virtual disks. However, you can't use Azure Disk Storage to store a disk outside of a virtual machine. A storage account provides a unique namespace for your Azure Storage data that's accessible from anywhere in the world over HTTP or HTTPS. Data in this account is secure, highly available, durable, and massively scalable. For more information, you can refer to the Microsoft Azure product documentation on how to create a storage account. Disk Storage provides disks for Azure virtual machines. Applications and other services can access and use these disks as needed, similar to how they would in on-premises scenarios. Disk storage allows data to be persistently stored and accessed from an attached virtual hard disk. Disks come in many different sizes and performance levels, from solid-state drives, SSDs, to traditional spinning hard disk drives, HDDs, with varying performance tiers. You can use standard SSD and HDD disks for less critical workloads, premium SSD disks for mission-critical production applications, and ultra disks for data-intensive workloads such as SAP HANA, top-tier databases, and transaction-heavy workloads. Azure has consistently delivered enterprise-grade durability for infrastructure as a service disks, with an industry-leading 0% annualized failure rate. An Azure virtual machine can use separate disks to store different data. Azure Blob Storage is an object storage solution for the cloud. It can store massive amounts of data, such as text or binary data. Azure Blob Storage is unstructured, meaning that there are no restrictions on the kinds of data it can hold. Blob Storage can manage thousands of simultaneous uploads, massive amounts of video data, constantly growing log files, and can be reached from anywhere with an internet connection. Blobs aren't limited to common file formats. A blob could contain gigabytes of binary data streamed from a scientific instrument, an encrypted message for another application, or data in a custom format for an app you're developing. One advantage of blob storage over disk storage is that it does not require developers to think about or manage disks. Data is uploaded as blobs, and Azure takes care of the physical storage needs. Blob storage is ideal for storing up to 8 terabytes of data for virtual machines, storing data for analysis by an on-premises or Azure-hosted service, storing data for backup and restore, disaster recovery, and archiving, streaming video and audio, storing files for distributed access, serving images or documents directly to a browser. This diagram illustrates how you might use Azure accounts, containers, and blobs. Azure Files offers fully managed file shares in the cloud that are accessible via the industry standard server message block and network file system preview protocols. Azure File shares can be mounted concurrently by cloud or on-premises deployments of Windows, Linux, and macOS. Applications running in Azure virtual machines or cloud services can mount a file storage share to access file data, just as a desktop application would mount a typical SMB share. Any number of Azure virtual machines or roles can mount and access the file storage share simultaneously. Typical usage scenarios would be to share files anywhere in the world, diagnostic data, or application data sharing. Use Azure Files for the following situations. Many on-premises applications use file shares. Azure Files makes it easier to migrate those applications that share data to Azure. If you mount the Azure file share to the same drive letter that the on-premises application uses, the part of your application that accesses the file share should work with minimal, if any, changes. Store configuration files on a file share and access them from multiple VMs. Tools and utilities used by multiple developers in a group can be stored on a file share, ensuring that everybody can find them and that they use the same version. Write data to a file share and process or analyze the data later. For example, you might want to do this with diagnostic logs, metrics, and crash dumps. This illustration shows Azure Files being used to share data between 2 geographical locations. Azure Files ensures the data is encrypted at rest, and the SMB protocol ensures the data is encrypted in transit. One thing that distinguishes Azure Files from files on a corporate file share is that you can access the files from anywhere in the world by using a URL that points to the file. You can also use Shared Access Signature or SAS tokens to allow access to a private asset for a specific amount of time. A service SAS URI will show the resource URI and the SAS token. Data stored in the cloud can grow at an exponential pace. To manage costs for your expanding storage needs, it's helpful to organize your data based on attributes like frequency of access and planned retention period. Data stored in the cloud can be different based on how it's generated, processed, and accessed over its lifetime. Some data is actively accessed and modified throughout its lifetime. Some data is accessed frequently early in its lifetime, with access dropping drastically as the data ages. Some data remains idle in the cloud and is rarely, if ever, accessed after it's stored. To accommodate these different access needs, Azure provides several access tiers, which you can use to balance your storage costs with your access needs. Azure Storage offers different access tiers for your blob storage, helping you store object data in the most cost-effective manner. The available access tiers include Hot Access Tier, optimized for storing data that is accessed frequently, for example, images for your website. Cool Access Tier, optimized for data that is infrequently accessed and stored for at least 30 days, for example, invoices for your customers. Archive Access Tier, appropriate for data that is rarely accessed and stored for at least 180 days, with flexible latency requirements, for example, long-term backups. Additionally, some considerations apply to the different access tiers. Only the hot and cool access tiers can be set at the account level. The archive access tier isn't available at the account level. Hot, cool, and archive tiers can be set up at the blob level during upload or after upload. Data in the cool access tier can tolerate slightly lower availability, but still requires high durability, retrieval latency, and throughput characteristics similar to hot data. For cool data, a slightly lower availability service level agreement and higher access costs compared to hot data are acceptable trade-offs for lower storage costs. Archive storage stores data offline and offers the lowest storage costs, but also the highest cost to rehydrate and access data. This illustration demonstrates choosing between the hot and cool access tiers on a general purpose storage account. Hello and welcome again to Azure Storage and Networking Services. In this lesson, you'll learn about the different Azure networking options and the scenarios in which each is appropriate. When you have completed this lesson, you'll be able to describe the core networking resources that are available in Azure, the benefits and usage of Azure Virtual Network, Azure VPN Gateway, and Azure ExpressRoute. We are going to use our case study to give you an opportunity to see how the concepts you'll learn about can be applied in the real world. Suppose your company, Tailwind Traders, has migrated some applications to the cloud and is architecting new ones. The servers that host Tailwind Traders' customer and product data are based in Silicon Valley. Your company also has several branch offices located in different geographic regions. As part of your migration strategy, your company needs to determine the correct approach to configure its network infrastructure. You've been tasked by the CTO to take the lead for this part of the project. To help save costs, you convince your team to move your website and several of your other networked resources to the cloud. With that in mind, you'll need to provide secure access to private company data for each of its branch locations. You want to know how Azure can help you manage your network more effectively. As it turns out, managing networks on Azure isn't entirely different from managing on-premises networks. Tailwind Traders has an on-premises data center that you plan to keep, but you want to use Azure to offload peak traffic by using virtual machines hosted in Azure. You want to keep your existing IP addressing scheme and network appliances while ensuring that any data transfer is secure. Using Azure Virtual Network for your virtual networking can help you reach your goals. Azure Virtual Networks enable Azure resources such as VMs, web apps, and databases to communicate with each other, with users on the internet, and with your on-premises client computers. You can think of an Azure network as a set of resources that links other Azure resources. Azure Virtual Networks provide the following key networking capabilities: isolation and segmentation, internet communications, communicate between Azure resources, communicate with on-premises resources, route network traffic, filter network traffic, and connect virtual networks. Now, let's explore the networking capabilities provided by Azure. Isolation and segmentation. Virtual Network allows you to create multiple isolated virtual networks. When you set up a virtual network, you define a private IP address space by using either public or private IP address ranges. You can divide that IP address space into subnets and allocate part of the defined address space to each named subnet. For name resolution, you can use the name resolution service that's built into Azure. You also can configure the virtual network to use either an internal or an external DNS server. Internet communications. A VM in Azure can connect to the internet by default. You can enable incoming connections from the internet by defining a public IP address or a public load balancer. For VM management, you can connect via the Azure CLI, Remote Desktop Protocol, or Secure Shell. Communicate between Azure resources. You'll want to enable Azure resources to communicate securely with each other. You can do that in one of two ways. Virtual networks. Virtual networks can connect not only VMs, but other Azure resources, such as the App Service environment for Power Apps, Azure Kubernetes Service, and Azure Virtual Machine Scale Sets. Service endpoints. You can use service endpoints to connect to other Azure resource types, such as Azure SQL databases and storage accounts. This approach enables you to link multiple Azure resources to virtual networks to improve security and provide optimal routing between resources. Azure Virtual Networks enable you to link resources together in your on-premises environment and within your Azure subscription. In effect, you can create a network that spans both your local and cloud environments. There are 3 mechanisms for you to achieve this connectivity. The point-to-site virtual private networks approach is like a virtual private network connection that a computer outside your organization makes back into your corporate network, except that it's working in the opposite direction. In this case, the client computer initiates an encrypted VPN connection to Azure to connect that computer to the Azure Virtual Network. A site-to-site virtual private network links your on-premises VPN device or gateway to the Azure VPN gateway in a virtual network. In effect, the devices in Azure can appear as being on the local network. The connection is encrypted and works over the internet. Azure ExpressRoute is the best approach for environments where you need greater bandwidth and even higher levels of security. ExpressRoute provides dedicated private connectivity to Azure that doesn't travel over the internet. You'll learn more about ExpressRoute later. Azure Virtual Networks enable you to filter traffic between subnets by using the following approaches. Network security groups. A network security group is an Azure resource that can contain multiple inbound and outbound security rules. You can define these rules to allow or block traffic based on factors such as source and destination IP address, port, and protocol. Network virtual appliances. A network virtual appliance is a specialized VM that can be compared to a hardened network appliance. A network virtual appliance carries out a particular network function, such as running a firewall or performing a wide area network or WAN optimization. You can link virtual networks together by using virtual network peering. Peering enables resources in each virtual network to communicate with each other. These virtual networks can be in separate regions, which allows you to create a global interconnected network through Azure. UDR is user-defined routing. UDR is a significant update to Azure's virtual networks, as this allows network admins to control the routing tables between subnets within a subnet as well as between VNets, thereby allowing for greater control over network traffic flow. You can create and configure Azure Virtual Network instances from the Azure portal, Azure PowerShell on your local computer, or Azure Cloud Shell. When you create an Azure Virtual Network, you configure a number of basic settings. You'll have the option to configure advanced settings, such as multiple subnets, distributed denial of service or DDoS protection, and service endpoints. You'll configure the following settings for a basic virtual network. Network name. The network name must be unique in your subscription, but it doesn't need to be globally unique. Make the name a descriptive one that's easy to remember and identified from other virtual networks. Address space. When you set up a virtual network, you define the internal address space in classless interdomain routing, or CIDR format. An address space in Azure is similar to an on-premises IP addressing scheme. This address space will be unique within your subscription, just as a subnet is within your on-premises environment. You can then assign these address spaces to your virtual networks, ensuring there is no overlap or conflicts. Subscription only applies if you have multiple subscriptions to choose from. Like any other Azure resource, a virtual network needs to exist in a resource group. You can either select an existing resource group or create a new one. You will have an opportunity to select the location where you want the virtual network to exist. Within each virtual network address range, you can create one or more subnets that partition the virtual network's address space. Routing between subnets will then depend on the default traffic routes. You also can define custom routes. Alternatively, you can define one subnet that encompasses all the virtual network's address ranges. Please note that subnet names must begin with a letter or number and end with a letter, number, or underscore. They may contain only letters, numbers, underscores, periods, or hyphens. There are two types of services available: basic or standard DDoS protection. Standard DDoS protection is a premium service. For more information on standard DDoS protection, see Azure DDoS Protection Standard Overview on the Azure product documentation. You can also enable service endpoints. You can select from a list of Azure Service endpoints which ones you want to enable. Options include Azure Cosmos DB, Azure Service Bus, Azure Key Vault, and so on. After you've completed the configuration of these settings, you are ready to create your Azure Virtual Network. Now you can define additional settings. After you create a virtual network, you can then define further settings. These include Network security groups have security rules that enable you to filter the type of network traffic that can flow in and out of virtual network subnets and network interfaces. You create the network security group separately. Then you associate it with the virtual network. Azure automatically creates a route table for each subnet within an Azure virtual network and adds system default routes to the table. You can add custom route tables to modify traffic between virtual networks. You can also amend the service endpoints. After you've created a virtual network, you can change any further settings on the virtual network pane in the Azure portal. Alternatively, you can use PowerShell commands or commands in Cloud Shell to make changes. You can then review and change settings in further subpanes. You can add additional address spaces to the initial definition. Under Connected Devices, use the virtual network to connect machines. You can also add additional subnets. And under Peerings, you can link virtual networks in peering arrangements. You can also monitor and troubleshoot virtual networks, or you can create an automation script to generate the current virtual network. Virtual networks are powerful and highly configurable mechanisms for connecting entities in Azure. You can connect Azure resources to one another or to resources you have on premises. You can isolate, filter, and route your network traffic. Azure allows you to increase security where you feel you need it. A virtual private network, or VPN, is a type of private interconnected network. VPNs use an encrypted tunnel within another network. They're typically deployed to connect two or more trusted private networks to one another over an untrusted network, typically the public internet. Traffic is encrypted while traveling over the untrusted network to prevent eavesdropping or other attacks. For our Tailwind Traders scenario, VPNs can enable branch offices to share sensitive information between locations. For example, let's say that your offices on the East Coast region of North America need to access your company's private customer data, which is stored on servers that are physically located in a West Coast region. A VPN that connects your East Coast offices to your West Coast servers allows your company to securely access your private customer data. A VPN gateway is a type of virtual network gateway. Azure VPN gateway instances are deployed in Azure Virtual Network instances and enable the following connectivity. Connect on-premises data centers to virtual networks through a site-to-site connection. Connect individual devices to virtual networks through a point-to-site connection. Connect virtual networks to other virtual networks through a network-to-network connection. All transferred data is encrypted in a private tunnel as it crosses the internet. You can deploy only one VPN gateway in each virtual network, but you can use one gateway to connect to multiple locations, which includes other virtual networks or on-premises data centers. When you deploy a VPN gateway, you specify the VPN type, either policy-based or route-based. The main difference between these two types of VPNs is how traffic to be encrypted is specified. In Azure, both types of VPN gateways use a pre-shared key as the only method of authentication. Policy-based VPN gateways specify statically the IP address of packets that should be encrypted through each tunnel. This type of device evaluates every data packet against those sets of IP addresses to choose the tunnel where that packet is going to be sent through. Key features of policy-based VPN gateways in Azure include support for IKE v1 only. IKE, or Internet Key Exchange, is a protocol used to set up a secure, authenticated communications channel between two parties. Use of static routing, where combinations of address prefixes from both networks control how traffic is encrypted and decrypted through the VPN tunnel. The source and destination of the tunneled networks are declared in the policy and don't need to be declared in routing tables. Policy-based VPNs must be used in specific scenarios that require them, such as for compatibility with legacy on-premises VPN devices. You can use route-based gateways if defining which IP addresses are behind each tunnel is too cumbersome. With route-based gateways, IPsec tunnels are modeled as a network interface or virtual tunnel interface. IP routing, either static routes or dynamic routing protocols, decides which one of these tunnel interfaces to use when sending each packet. Route-based VPNs are the preferred connection method for on-premises devices. They're more resilient to topology changes such as the creation of new subnets. Use a route-based VPN gateway if you need any of the following types of connectivity. Connections between virtual networks, point-to-site connections, multi-site connections, coexistence with an Azure ExpressRoute gateway. Key features of route-based VPN gateways in Azure include IKE-v2 support, use of any-to-any wildcard traffic selectors, use of dynamic routing protocols where routing forwarding tables direct traffic to different IPsec tunnels. In this case, the source and destination networks aren't statically defined as they are in policy-based VPNs or even in route-based VPNs with static routing. Instead, data packets are encrypted based on network routing tables that are created dynamically using routing protocols such as Border Gateway Protocol or BGP. The capabilities of your VPN gateway are determined by the SKU or size that you deploy. This table shows the main capabilities of each available SKU. Note that a basic VPN gateway should only be used for dev test workloads. In addition, it's unsupported to migrate from basic to the VPN GW123AZ SKUs at a later time without having to remove the gateway and redeploy. Before you can deploy a VPN gateway, you'll need some Azure and on-premises resources. You'll need one of these Azure resources before you can deploy an operational VPN gateway. Deploy a virtual network with enough address space for the additional subnet that you'll need for the VPN gateway. The address space for this virtual network must not overlap with the on-premises network that you'll be connecting to. You can deploy only one VPN gateway within a virtual network. Deploy a subnet called Gateway Subnet for the VPN gateway. Use at least a /27 address mask to make sure you have enough IP addresses in the subnet for future growth. You can't use this subnet for any other services. Create a basic SKU dynamic public IP address if you're using a non-zone aware gateway. This address provides a public routable IP address as the target for your on-premises VPN device. This IP address is dynamic, but it won't change unless you delete and recreate the VPN gateway. Create a local network gateway to define the on-premises network's configuration, such as where the VPN gateway will connect and what it will connect to. The configuration includes the on-premises VPN device's public IPv4 address and the on-premises routable networks. This information is used by the VPN gateway to route packets that are destined for on-premises networks through the IPsec tunnel. Create the virtual network gateway to route traffic between the virtual network and the on-premises data center or other virtual networks. The virtual network gateway can be either a VPN or ExpressRoute gateway, but this unit only deals with VPN virtual network gateways. You'll learn more about ExpressRoute in a separate unit later in this module. Create a connection resource to create a logical connection between the VPN gateway and the local network gateway. The connection is made to the on-premises VPN device's IPv4 address as defined by the local network gateway. The connection is made from the virtual network gateway and its associated public IP address. This diagram shows the combination of resources and their relationships to help you better understand what's required to deploy a VPN gateway. To connect your data center to a VPN gateway, there are some required on-premises resources. A VPN device that supports policy-based or route-based VPN gateways. A public-facing internet routable IP address. There are several ways to ensure you have a fault-tolerant configuration. By default, VPN gateways are deployed as 2 instances in an active standby configuration, even if you only see one VPN gateway resource in Azure. When planned maintenance or unplanned disruption affects the active instance, the standby instance automatically assumes responsibility for connections without any user intervention. Connections are interrupted during this failover, but they're typically restored within a few seconds for planned maintenance and within 90 seconds for unplanned disruptions. With the introduction of support for the BGP routing protocol, you can also deploy VPN gateways in an active-active configuration. In this configuration, you assign a unique public IP address to each instance. You then create separate tunnels from the on-premises device to each IP address. You can extend the high availability by deploying an additional VPN device on-premises. Another high availability option is to configure a VPN gateway as a secure failover path for ExpressRoute connections. ExpressRoute circuits have resiliency built in, but they aren't immune to physical problems that affect the cables delivering connectivity or outages that affect the complete ExpressRoute location. In high availability scenarios, where there's risk associated with an outage of an ExpressRoute circuit, you can also provision a VPN gateway that uses the internet as an alternative method of connectivity. In this way, you can ensure there's always a connection to the virtual networks. In regions that support availability zones, VPN gateways and ExpressRoute gateways can be deployed in a zone-redundant configuration. This configuration brings resiliency, scalability, and higher availability to virtual network gateways. Deploying gateways in Azure availability zones physically and logically separates gateways within a region while protecting your on-premises network connectivity to Azure from zone-level failures. These gateways require different gateway SKUs and use standard public IP addresses instead of basic public IP addresses. ExpressRoute lets you extend your on-premises networks into the Microsoft Cloud over a private connection with the help of a connectivity provider. With ExpressRoute, you can establish connections to Microsoft Cloud services, such as Microsoft Azure and Microsoft 365. Connectivity can be from an any-to-any IPVPN network, a point-to-point Ethernet network, or a virtual cross-connection through a connectivity provider at a co-location facility. ExpressRoute connections don't go over the public internet. This allows ExpressRoute connections to offer more reliability, faster speeds, consistent latencies, and higher security than typical connections over the internet. For information on how to connect your networks to Microsoft using ExpressRoute, see ExpressRoute connectivity models. As part of your work for Tailwind traders, you should understand what Azure ExpressRoute is and how it integrates with on-premises and Azure networks. Now we will cover the benefits that ExpressRoute provides compared to other site-to-site connectivity options. As a result, you'll learn whether ExpressRoute can provide your company with the best possible network performance. Throughout this unit, we'll focus on two different layers of the Open Systems Interconnection, or OSI model. Layer 2, or L2, is the data link layer, which provides node-to-node communication between two nodes on the same network. Layer 3, or L3, is the network layer, which provides addressing and routing between nodes on a multi-node network. There are several benefits to using ExpressRoute as the connection service between Azure and on-premises networks. Layer 3 connectivity between your on-premises network and the Microsoft Cloud through a connectivity provider. Connectivity can be from an any-to-any IPVPN network, a point-to-point Ethernet connection, or through a virtual cross-connection via an Ethernet exchange. Connectivity to Microsoft Cloud services across all regions in the geopolitical region. Global connectivity to Microsoft services across all regions with the ExpressRoute Premium add-on. Dynamic routing between your network and Microsoft via BGP. Built-in redundancy in every peering location for higher reliability. Connection uptime SLA. And QoS support for Skype for Business. ExpressRoute provides Layer 3 address-level connectivity between your on-premises network and the Microsoft Cloud through connectivity partners. These connections can be from a point-to-point or any-to-any network. They can also be virtual cross-connections through an exchange. Each connectivity provider uses redundant devices to ensure that connections established with Microsoft are highly available. You can configure multiple circuits to complement this feature. All redundant connections are configured with Layer 3 connectivity to meet service level agreements. ExpressRoute enables connectivity to Microsoft Cloud services. That includes direct access to the following services in all regions: Microsoft Office 365, Microsoft Dynamics 365, Azure Compute Services such as Azure Virtual Machines, Azure Cloud Services such as Azure Cosmos DB and Azure Storage. Office 365 was created to be accessed securely and reliably via the internet. For this reason, we recommend the use of ExpressRoute for specific scenarios. You can enable ExpressRoute Global Reach to exchange data across your on-premises sites by connecting your ExpressRoute circuits. For example, assume that you have a private data center in California connected to ExpressRoute in Silicon Valley. You have another private data center in Texas connected to ExpressRoute in Dallas. With ExpressRoute Global Reach, you can connect your private data centers through 2 ExpressRoute circuits. Your cross-data center traffic will travel through the Microsoft network. ExpressRoute uses the Border Gateway Protocol, or BGP routing protocol. BGP is used to exchange routes between on-premises networks and resources running in Azure. This protocol enables dynamic routing between your on-premises network and services running in the Microsoft cloud. ExpressRoute supports 3 models that you can use to connect your on-premises network to the Microsoft cloud: Cloud Exchange co-location, point-to-point Ethernet connection, any-to-any connection. Co-located providers can normally offer both Layer 2 and Layer 3 connections between your infrastructure, which might be located in the co-location facility and the Microsoft cloud. For example, if your data center is co-located at a cloud exchange, such as an ISP, you can request a virtual cross-connection to the Microsoft cloud. Point-to-point connections provide Layer 2 and Layer 3 connectivity between your on-premises site and Azure. You can connect your offices or data centers to Azure by using the point-to-point links. For example, if you have an on-premises data center, you can use a point-to-point Ethernet link to connect to Microsoft. With any-to-any connectivity, you can integrate your wide area network with Azure by providing connections to your offices and data centers. Azure integrates with your WAN connection to provide a connection like you would have between your data center and any branch offices. With any-to-any connections, all WAN providers offer Layer 3 connectivity. For example, if you already use multi-protocol label switching to connect to your branch offices or other sites in your organization, an ExpressRoute connection to Microsoft behaves like any other location on your private WAN. With ExpressRoute, your data doesn't travel over the public internet, so it's not exposed to the potential risks associated with internet communications. ExpressRoute is a private connection from your on-premises infrastructure to your Azure infrastructure. Even if you have an ExpressRoute connection, DNS queries, certificate revocation list checking, and Azure Content Delivery Network, requests are still sent over the public internet. In this module, you discovered how Azure Storage can provide your company with a variety of options for storing your data. For example, you learned that your first step when using Azure Storage is to create a storage account. After you've done so, Azure provides you with several options for storing your data: Azure Blob Storage, Azure Disk Storage, Azure File Storage. You also use the Tailwind Trader scenario to learn about the core networking resources that are available in Azure. You learn about the benefits and usage of Azure Virtual Network, Azure VPN Gateway, and Azure ExpressRoute. You can now apply this information to help your business use Azure's networking resources to configure its network infrastructure. Congratulations! You have completed this course on Introduction to Azure Core Concepts and Services. Throughout this course, you have learned about Azure fundamental concepts and architectural components, Azure Database, Analytics and Compute Services, and finally Azure Storage and Networking Services. These Azure core concepts are the first requirements in the AZ900 exam. The next course will cover Azure Management Tools and Security Solutions. It is the next step in further preparing for a career using Microsoft Azure. Please be reminded to check out more information about the exam AZ900 Microsoft Azure Fundamentals. Make sure to check the reading material that follows for more information on what's to come next. The cloud is enabling dramatic changes in the way we live our lives.
From the healthcare sector
To the entertainment industry.
The cloud allows small businesses to go global, developing countries to expand into new markets, and language barriers to fade.
Doctors can remotely monitor patients in their own home,
scientists can predict hurricanes.
and education can now be distributed to more people than ever before.
From universities to refugee camps.
We can use the cloud, AI, and machine learning to help us quickly search through large amounts of data, helping us make important decisions with the right kind of information. So instead of guessing and making decisions based on only part of the story, we are helping scientists, doctors, and many other people make better decisions. With the right knowledge and skills, you can be part of this change.
Cloud computing is rapidly expanding to all businesses, creating new career opportunities. Career opportunities in cloud computing cover a broad range of roles, from developers and architects to security professionals and data scientists. Given the constantly evolving nature of the cloud, working in the cloud requires continuously updating your knowledge and skills.
However, maybe you don't have that specific university degree, the right certifications, and hands-on experience, or maybe the cost is just too high.
For these reasons, Microsoft and Coursera have partnered to develop the first in a series of programs to prepare you for a career in the cloud. This program consists of 4 courses that will act as a bedrock of fundamental knowledge to prepare you for the AZ900 certification exam.
The AZ900 certification is designed to give you the fundamental knowledge, skills, and confidence to begin your Azure certification journey. We've assembled a great team of instructors to prepare you for this journey.
I'm Rachel. In Course 1, Introduction to Azure Core Concepts and Services, you'll learn the basics of cloud computing, its advantages, and how to determine whether Azure is the right solution for your business needs. You'll learn about several of the database and big data services that are available on Microsoft Azure. You'll also learn how to take advantage of several virtualization services in Azure Compute, which can help your applications scale out quickly and efficiently to meet increasing demands. Finally, you'll learn about the different storage and virtual network options available in Azure.
I'm Barry. In Course 2, Azure Management Tools and Security Solutions, you'll learn about AI and software development tools and services from Microsoft Azure. You'll learn about monitoring and management tools and services from Azure. You'll then look at the serverless computing technology and Azure IoT service that best addresses different business scenarios. Finally, you'll learn how Azure can help you protect the workloads that you run, both in the cloud and in your on-premises data center.
I'm Anita. In Course 3, Azure Services and Lifecycles, you'll learn how Azure Active Directory provides identity and access management. Then you'll learn how to make organizational decisions about your cloud environment by using the Cloud Adoption Framework for Azure. You'll learn how to control and audit how your resources are created by using Azure Policy, and enable governance at scale across multiple Azure subscriptions by using Azure Blueprints. You'll use the total cost of ownership calculator to compare your current data center costs to running the same workloads on Azure.
I'm Kalisha, and finally in Course 4, preparing for the AZ900 Azure Fundamentals exam. You'll get a more detailed overview of the Microsoft certification program and where you can go next in your career. You'll get tips and tricks, testing strategies, useful resources, and information on how to sign up for the AZ900 exam. You'll also get a recap of the key topics and concepts covered in each course, along with a practice exam. Finally, you'll get to take the practice exam that tests all the main topics covered in the AZ900 proctored exam, ensuring you're well prepared for certification success.
This course aims to help you learn more about Azure and prepares you for the Azure 900 exam. When you pass the AZ900 exam, you earn the Microsoft Certified Azure Fundamental Certification. Becoming AZ900 Microsoft Azure Fundamental Certified can be the launchpad for your learning journey into cloud computing and Azure technologies. This certification is a good fit if you are beginning to work with cloud-based solutions and services or are new to Azure. Acquiring the Azure Fundamental Certification is also an opportunity for you to prove your knowledge of cloud concepts and Azure's main features. These include Azure Services, Azure Workloads, Azure Security and Privacy, and finally, Azure Pricing and Support. This course will help you to develop these skills and prepare you to pass the official Azure AZ900 exam. To get the most out of this course, it helps if you are familiar with the general technology concepts, including concepts of networking, storage, compute, application support, and application development. Microsoft certifications provide globally recognized and industry-endorsed evidence of mastering technical skills. Microsoft certification provides you with the pathway to upgrade your skills, validate your abilities, enhance your professional performance, and develop your career. Microsoft certifications validate your skills and capabilities and leads you to success. Achieving certification shows employers that you have drive and initiative. If you get hired in a new role, or promoted, or change your career, Your certification speaks volumes about you and what you know. Perhaps you are already in an IT support role and your team needs your guidance or opinion. You'll definitely be able to respond with confidence once you have successfully completed this program. Stay ahead, get hired, and receive the recognition you deserve. In this course, you'll explore various modules relating to Azure Management tools and security solutions. You'll start off with AI services and solutions. Here you will explore artificial intelligence and software development tools and services from Microsoft Azure. You will be asked to help choose the best solutions for a given business scenario. To help you select the right tools and solutions, you'll also apply the criteria that experts use to make their choices. Next, you will work through monitoring and managing in Azure. You'll learn about monitoring and management tools and services from Microsoft Azure, and you'll analyze decision criteria that experts use to select the right service for a specific scenario. As you dive deeper, you'll explore serverless technology and Azure IoT solutions. You'll be introduced to these tools and services and use expert criteria to choose the best solutions for different kinds of business and technical needs and challenges. And as things become even more exciting, you will find out how Azure can help you protect the workloads that you run both in the cloud and in your on-premises data center. In this module, General Security and Network Security, you will explore the Azure services you can use to help ensure that your network is safe, secure, and trusted. Throughout this course, you will have an opportunity to get hands-on experience with Azure through interactive exercises, practice quizzes, and practice exams. The interactive exercises offer opportunities to practice and implement what you are learning. As an example, you'll need to configure network access to a virtual machine running on Azure. You'll work in a temporary Azure environment called the sandbox. The beauty about this is that you will be working with real technology, but in a controlled environment, which allows you to apply what you learn and at your own pace. As you explore the concepts and services that are available through Azure, you will be given a case study to apply what you are learning to real-world examples. In the case study, you'll assume the role of an IT specialist and address the technology challenges of tailwind traders so that you can help them conduct business more efficiently. Using real-world examples helps to reinforce concepts, prepare you for the exam, and gives you confidence in your approach. Now that you have a good idea of what you'll cover in this course, you can review what you'll learn throughout the modules in more detail. Good luck. Hello, and welcome to AI Services and Solutions. In this module, you'll learn about AI and software development tools and services from Microsoft Azure. You'll be introduced to these tools and services and will be asked to help choose the best one for a given business scenario. More specifically, after completing this module, you'll be able to choose the Azure AI services that best address your company's business challenges, and choose the software development process tools and services that best address specific business scenarios. So let's dive right into our case study. Tailwind Traders, a traditional brick-and-mortar retailer that has experienced explosive online sales growth, faces exciting challenges as it seeks to improve its e-commerce and service operations. Microsoft's AI services might be a good fit for one of the company's new initiatives, but Tailwind Traders needs to help to better understand which product option is best for each scenario. Artificial intelligence is a category of computing that adapts and improves its decision-making ability over time. Based on its successes and failures, Microsoft Azure provides several AI solutions to choose from, each one depending on the problem you're trying to solve. Let's take a look at our case study to see what exciting challenges Tailwind Traders face. As you navigate this lesson, you'll need to be familiar with the following concepts. Application Programming Interfaces, or APIs. Programmers use APIs to interact with the functionality that's contained in code libraries. Web API. An API that's accessible from servers that accept requests via HTTP. Web API Endpoint. the location of the code library, and REST API, the design of the URL style that's used to expose the API's functionality. After completing this lesson, you'll be able to choose the Azure AI services that best address your company's business challenges. Let's start off by exploring artificial intelligence. AI is a broad classification of computing that allows a software system to perceive its environment and take action that maximizes its chance of successfully achieving its goals. A goal of AI is to create a software system that's able to adapt or learn something on its own without being explicitly programmed to do it. There are two basic approaches to AI. The first is to employ a deep learning system that's modeled on the neural network of the human mind, enabling it to discover, learn, and grow through experience. The second approach is machine learning, a data science technique that uses existing data to train a model, test it, and then apply the model to new data to forecast future behaviors, outcomes, and trends. Forecasts or predictions from machine learning can make apps and devices smarter. For example, when you buy online, machine learning powers product recommendation systems that offer additional products. These recommendations are based on your past purchases or products that you might be interested in. Machine learning is also used to detect credit card fraud by analyzing each new transaction and using what it has learned from analyzing millions of fraudulent transactions. At a high level, there are three primary product offerings from Microsoft, each of which is designed for a specific audience and use case. Each option provides a diverse set of tools, services, and programmatic APIs. In this lesson, we'll merely scratch the surface of the options' capabilities. First, Azure Machine Learning is a platform for making predictions. It consists of tools and services that allow you to connect to data to train and test models to find one that will most accurately predict a future result. After you've run experiments to test the model, you can deploy and use it in real time via a web API endpoint. With Azure Machine Learning, you can build a process that defines how to obtain data, how to handle missing or bad data, how to split the data into either a training set or test set, and deliver the data to the training process. Train and evaluate predictive models by using tools and programming languages familiar to data scientists. Create pipelines that define where and when to run the compute-intensive experiments that are required to score algorithms based on the training and test data. And deploy the best-performing algorithm as an API to an endpoint, so it can be consumed in real time by other applications. Choose Azure Machine Learning when your data scientists need complete control over the design and training of an algorithm using your own data. Second, Azure Cognitive Services provide pre-built machine learning models that enable applications to see, hear, speak, understand, and even begin to reason. Use Azure Cognitive Services to solve general problems, such as analyzing text for emotional sentiment, or analyzing images to recognize objects or faces. You don't need special machine learning or data science knowledge to use these services. Developers access Azure Cognitive Services via APIs and can easily include these features in just a few lines of code. While Azure Machine Learning requires you to bring your own data and train models over that data, Azure Cognitive Services, for the most part, provides pre-trained models so that you can bring in your live data to get predictions on. Azure Cognitive Services can be divided into the following categories. Language services. Allow your apps to process natural language with pre-built scripts, evaluate sentiment, and learn how to recognize what users want. Speech services. Convert speech into text, and text into natural-sounding speech. Translate from one language to another, and enable speaker verification and recognition. Vision services. Add recognition and identification capabilities when you're analyzing pictures, videos, and other visual content. And decision services. Add personalized recommendations for each user that automatically improve each time they're used. Moderate content to monitor and remove offensive or risky content and detect abnormalities in your time series data. Lastly, Azure Bot Service and Bot Framework are platforms for creating virtual agents that understand and reply to questions just like a human. Azure Bot Service is a bit different from Azure Machine Learning and Azure Cognitive Services in that it has a specific use case. Namely, it creates a virtual agent that can intelligently communicate with humans. Behind the scenes, the bot you build uses other Azure services, such as Azure Cognitive Services, to understand what their human counterparts are asking for. Bots can be used to shift simple repetitive tasks such as taking dinner reservations or gathering profile information onto automated systems that might no longer require direct human intervention. Users converse with the bot by using text, interactive cards, and speech. A bot interaction can be a quick question and answer, or it can be a sophisticated conversation that intelligently provides access to services. In this session, you'll analyze the criteria that experts employ when they choose an AI service for a specific business need. Understanding the criteria can also help you better understand the nuanced differences among the products. The first criteria you should consider when building a virtual agent is, are you building one that interfaces with humans via natural language? If the answer is yes, you use an Azure Bot Service to create your virtual agent. Bot Service integrates knowledge services, natural language processing, and form factors to allow interactions across different channels. Bot Service solutions usually rely on other AI services for such things as natural language understanding, or even translation for localizing replies into a customer's preferred language. There are also pre-built no-code solutions that cover common scenarios and, depending on the requirements, may make more sense than starting off by building a custom chat experience with Bot Service. For example, you can use Q&A Maker, which is available from Azure Marketplace, to build, train, and publish a sophisticated bot that uses FAQ pages, support websites, product manuals, SharePoint documents, or editorial content through an easy-to-use UI or via REST APIs. Likewise, Power Virtual Agents integrates with Microsoft Power Platform so that you can use hundreds of pre-built connectors for data input. A connector is a proxy or a wrapper around an API that allows the underlying service to talk to Microsoft Power Automate, Microsoft Power Apps, and Azure Logic Apps. It provides a way for users to connect their accounts and leverage a set of pre-built actions and triggers to build their apps and workflows. You can extend Power Virtual Agents by building custom workflows with Power Automate. And if you feel that the out-of-the-box experience is too limiting, you can still build more complex interactions with Microsoft Bot Framework. Next, you need to consider if the service you are building needs to understand the content and meaning of images, video, or audio, or that can translate text into a different language. If it does, you should use Azure Cognitive Services. This is the best solution when it comes to general-purpose tasks, such as performing speech to text, integrating with search, or identifying the objects in an image. Azure Cognitive Services is general-purpose, meaning that many kinds of customers can benefit from the work that Microsoft has already done to train and test these models, and offer them inexpensively at scale. If you need to predict user behavior or provide users with personalized recommendations in your app, you should use Azure Cognitive Services Personalizer. Azure Cognitive Services Personalizer watches your users' actions within an application. You can use Personalizer to predict their behavior and provide relevant experiences as it identifies usage patterns. Here again, you could capture and store user behavior and create your own custom Azure machine learning solution to do these things. But this approach would require much effort and expense. If you are developing an app that needs to predict future outcomes based on private historical data, you use Azure Machine Learning. For example, suppose you need to analyze years' worth of financial transactions to discover new patterns that could help you create new products and services for your company's clients, and then offer those new services during routine customer service calls. When you're working with proprietary data, you likely need to build a more custom-tailored machine learning model. If you need to build a model by using your own data or perform a different task than those that have already been discussed, you can use Azure Machine Learning for maximum flexibility. Data scientists and AI engineers can use the tools they're familiar with and the data you provide to develop deep learning and machine learning models that are tuned for your particular requirements. The Tailwind Traders e-commerce website allows its customers to browse and purchase items that can be delivered or picked up from a retail store nearest to their location. The marketing team is convinced that it can increase sales dramatically by suggesting add-on products that complement the items in the shopper's cart at the point of checkout. The team could hard-code these suggestions, but it feels that a more organic approach would be to use its year's worth of sales data as well as new shopping trends to decide what products to display to the shopper. Additionally, the suggestions could be influenced by product availability, product profitability, and other factors. The marketing team's existing data science experts have already done some initial analysis of the problem domain and have determined that its plan might take months to prototype and possibly a year to roll out. Let's apply the decision criteria you learned about in the previous session to find the right option for Tailwind Traders. Is Tailwind Traders building a virtual agent that interfaces with humans via natural language? No, it is not. So Azure Bot Service is not a good candidate for this scenario. Does Tailwind Traders need a service that can understand the content and meaning of images, video, audio, or translate text into a different language? No, it doesn't. So the relevant cognitive services will not help the company. Does Tailwind Traders need to predict user behavior or provide users with personalized recommendations? Yes, it does. However, creating recommendations based on user behavior is only part of the requirement. Tailwind Traders needs to create a complex model that incorporates historical sales data, trending sales data, inventory, and more. It's possible that the Azure Cognitive Services Personalizer could play a role, but it couldn't handle the entire breadth of the project alone. Will the Tailwind Traders app predict future outcomes based on private historical data? Yes, and that is why, in this scenario, Azure Machine Learning is likely the best choice. The success of this effort would depend primarily on the ability of the model to precisely select the right upsale products to suggest to the shopper. Because the model would need to be tweaked and tuned over time, an off-the-shelf model would likely not suffice. In this case study, the marketing team already employs some data science experts, and the team is willing to make at least a year-long commitment to building, testing, and tweaking the models to be used. The first generation of the Tailwind Traders e-commerce website was available exclusively in English. However, when the marketing team sponsored a demographic study for the company's brick-and-mortar locations, it found that, on average, only 80% of the potential customers speak English. In some neighborhoods, that number falls to 50%. The team sees the addition of multiple languages as a wonderful opportunity to serve non-English speakers with the same online e-commerce experience as English speakers. As in the previous session, let's apply the decision criteria you learned about earlier to find the right option. Tailwind Traders will not be implementing a virtual agent at the moment. However, the team are excited about adding multiple languages to serve non-English speakers. Translator is part of Azure Cognitive Services. It is easy to integrate into your applications, websites, tools, and solutions. It allows you to add multi-language user experiences in more than 60 languages, and you can use it on any hardware platform with any operating system for text-to-text language translation. It is likely the best solution for Tailwind Traders, but let's continue applying the decision criteria to make sure. Based on the case study, Tailwind Traders do not need to predict user behavior or provide users with personalized recommendations, so Azure Cognitive Services Personalizer is not a good candidate for their current goals. Based on the case study, although it's possible to create a machine learning model for multi-language translation, It would be expensive and time-consuming for Tailwind traders to attempt to build translation models themselves. The team has neither the deep learning competency nor the linguistic data that's required to train the models. Now that you've examined all the expert criteria, you can confidently select Azure Cognitive Services as the best product option for this case study. The customer service team has long asked for a virtual agent to handle most questions it gets asked. No matter how prominent it makes the answers to the most frequently asked questions on the website, shoppers are impatient and perceive contact in a chat window as saving them time. The team wants shoppers to feel as though they're interacting with a real human. When it becomes clear that the virtual agent can't provide an answer, the chat session should be transferred to a human. Providing a virtual agent would decrease the amount of time it takes for all shoppers to receive answers. The virtual agent could answer most questions, which would free up human customer service agents to provide support for more difficult questions or thorny account-related issues. Once again, apply the decision criteria you're now familiar with to find the right product. Is Tailwind Traders building a virtual agent that interfaces with humans via natural language? Yes, it is. Azure Bot Service should be used in this scenario to implement a virtual agent chat experience. Bot Service could benefit from the information on the website's frequently asked questions page, along with thousands of chat sessions that have been stored between shoppers and customer service representatives. Customer service supervisors can test and tweak the answers to continue to refine the chat experience. Even though you've likely found the best option for this scenario, keep applying the decision criteria to see whether any additional options might work. Does Tailwind Traders need a service that can understand the content and meaning of images, video, audio, or translate text into a different language? Possibly yes. In this scenario, Azure Cognitive Services could be used along with Bot Service to build the solution. To expedite implementation, the developers could explore using pre-built solutions, such as Q&A Maker, part of Cognitive Services, or Power Virtual Agents. Also, any Azure Bot solution would likely implement several Azure Cognitive Services, such as Language Understanding, LUIS, and possibly Translator, to translate from the shopper's language to English and back again. Does Tailwind Traders need to predict user behavior or provide users with personalized recommendations? No, it doesn't. Azure Cognitive Services Personalizer is not a good candidate for this scenario. Will the Tailwind Traders app need to predict future outcomes based on private historical data? No. Although Tailwind Traders does have historical data to feed into a model, which would make it possible to use Azure Machine Learning to create a chat solution, another option is already tailored for the chatbot experience. Our goal in this lesson was to help Tailwind Traders explore several AI service offerings from Azure that it can apply to various business opportunities. Without AI services, Tailwind Traders would spend more time and effort on manual tasks, respond to customers less quickly, offer weak product recommendations, and be unable to fully support customers who speak languages other than English. AI is one focus that could transform every area of a business. Such transformation is limited only by the creativity and imagination of the organization. Welcome back. This week you'll explore software development process tools and services. Modern software development practices are supported by tools that encompass virtually every aspect of the software development lifecycle. In this lesson, you'll focus specifically on the comprehensive set of tools that Microsoft has created to help organizations implement DevOps practices, develop solutions, and save money while doing so. During this lesson, you'll notice that sometimes it seems as though these tools overlap in functionality. To help you select the right tools and solutions, you'll explore the criteria that experts use to make their choices. There are no formal prerequisites for this course. However, some familiarity with the concept of DevOps and its larger purpose in an organization is valuable. Microsoft offers tools to enable source code management, automating the creation of testing environments and continuous integration and continuous delivery. To help with understanding the value of the tools covered in this lesson, it is beneficial to have familiarity with the concepts such as software development lifecycle, source code management and version control, the various forms of testing, continuous integration and continuous delivery, continuous deployment, infrastructure as code. Software developers and operations professionals strive to create working software systems that satisfy the needs of the organization. However, sometimes their short-term objectives are at cross purposes which can result in technical issues, delays, and downtime. DevOps is a new approach that helps to align technical teams as they work towards common goals. To accomplish this alignment, organizations employ practices and processes that seek to automate the ongoing development, maintenance, and deployment of software systems. Their aim is to expedite the release of software changes, ensure the ongoing deployability of the system, and ensure that all changes meet a high-quality bar. When done correctly, DevOps practices and processes touch nearly every aspect of the company. This includes the software development lifecycle and the collaboration of software developers with each other and with operations and quality assurance teams. DevOps requires a fundamental mindset change from the top down. Organizations can't merely install software tools or adopt services and hope to get all of the benefits promised by DevOps. Now let's check in with Tailwind traders to see if the organization has any plans to adopt a DevOps mindset. Tailwind traders has experimented with various software development processes and tools. Until now, however, there has been no organizational commitment to shift to a DevOps mindset. Likewise, there has been no planned coordinated effort to standardize on a set of core tools and processes. Several new initiatives at the company accentuate the need for agile, repeatable, dependable management and deployment of software systems. Tailwind Traders believes that the adoption of DevOps tooling and practices is critical to the company's future success. By the end of this lesson, you'll be able to choose the software development process tools and services that best support those practices. In this session, you'll be introduced to three primary offerings: Azure DevOps Services, GitHub and GitHub Actions, and Azure DevTest Labs. Each offering is aimed at a specific audience and use case and provides a diverse set of tools, services, programmatic APIs, and more. So let's dive right in. Azure DevOps Services is a suite of services that address every stage of the software development lifecycle. Azure Boards is an agile project management suite that includes Kanban boards, reporting, and tracking ideas and work from high-level epics to work items and issues. Like Kanban boards, it visually displays work at various stages of a process. Azure Repos is a centralized source code repository where software development, DevOps engineering, and documentation professionals can publish their code for review and collaboration. Azure Pipelines is a continuous integration and continuous delivery pipeline automation tool. Azure Test Plans is an automated test tool that can be used in a CI/CD pipeline to ensure quality before a software release. Azure Artifacts is a repository for hosting artifacts such as compiled source code, which can be fed into testing or deployment pipeline steps. Azure DevOps is a mature tool with a large feature set that began as on-premises server software and evolved into a software as a service offering from Microsoft. Now on to GitHub and GitHub Actions. GitHub is arguably the world's most popular code repository for open source software. Git is a decentralized source code management tool, and GitHub is a hosted version of Git that serves as the primary remote. GitHub builds on top of Git to provide related services for coordinating work, reporting and discussing issues, providing documentation, and more. It offers the following functionality. It's a shared source code repository. including tools that enable developers to perform code reviews by adding comments and questions in web view of the source code before it can be merged into the main code base. It facilitates project management, including Kanban boards. It supports issue reporting, discussion, and tracking. It features CI/CD pipeline automation tooling. It includes a wiki for collaborative documentation. And it can be run from the cloud or on-premises. Most relevant for this module, GitHub Actions enables workflow automation with triggers for many lifecycle events. One such example would be automating a continuous integration or continuous delivery toolchain. A toolchain is a combination of software tools that aid in the delivery, development, and management of software applications throughout a system's development lifecycle. The output of one tool in the toolchain is the input of the next tool in the toolchain. Typical tool functions range from performing automated dependency updates to building and configuring the software, delivering the build artifacts to various locations, testing, and so on. With such similarity between many GitHub and Azure DevOps features, you might wonder which product to choose for your organization. Unfortunately, the answer might not be straightforward. Although both Azure DevOps and GitHub allow public and private code repositories, GitHub has a long history with public repositories and is trusted by tens of thousands of open source project owners. GitHub is a lighter weight tool than Azure DevOps, with a focus on individual developers contributing to the open source code. Azure DevOps, on the other hand, is more focused on enterprise development with heavier project management and planning tools, and finer-grained access control. It's important for you to note that your choices are not limited to Azure DevOps Services or GitHub and GitHub Actions. In practice, you can mix and match these services as needed. For example, you can use GitHub repos with Azure boards for work item tracking. Finally, let's take a brief look at Azure DevTest Labs and how it helps organizations to manage the VMs that developers and testers need to ensure a new app works across various operating systems. Azure DevTest Labs provides an automated means of managing the process of building, setting up, and tearing down virtual machines that contain builds of your software projects. This way, developers and testers can perform tests across a variety of environments and builds. And this capability isn't limited to VMs. Anything you can deploy in Azure via an Azure Resource Manager template can be provisioned through DevTest Labs. Provisioning pre-created lab environments with their required configurations and tools already installed is a huge time saver for quality assurance professionals and developers. So how does Azure DevTest Labs work? Suppose you need to test a new feature on an old version of an operating system. Azure DevTest Labs can set up everything automatically upon request. After the testing is complete, DevTest Labs can shut down and deprovision the VM, which saves money when it's not in use. To control costs, the management team can restrict how many labs can be created, how long they run, and so on. In this session, you'll analyze the criteria that experts employ when they choose DevOps tools or services to address specific business needs. Understanding the criteria can also help you better understand the nuanced differences between each product. If your aim is to automate the creation and management of a test lab environment, consider choosing Azure DevTest Labs. Among the 3 tools and services we've discussed, it's the only one that offers this functionality. However, you can automate the provisioning of new labs as part of a toolchain by using Azure Pipelines or GitHub Actions. You should also consider if you are building open source software. Although Azure DevOps can publish public code repositories, GitHub has long been the preferred host for open source software. If you're building open source software, you would likely choose GitHub, if for no other reasons than its visibility and general acceptance by the open source development community. Your choices aren't limited to Azure DevOps Services or GitHub and GitHub Actions. In practice, you can mix and match these services as needed. For example, you can use GitHub repos with Azure boards for work item tracking. However, the remaining decision criteria you will look at in this lesson are specific to choosing between either Azure DevOps or GitHub. Regarding source code management and DevOps tools, you need to think about what level of granularity you need for permissions. GitHub works on a simple model of read-write permissions to every feature. Meanwhile, Azure DevOps has a much more granular set of permissions that allow organizations to refine who is able to perform most operations across the entire toolset. When it comes to source code management and DevOps tools, you need to consider how sophisticated your project management and reporting needs to be. Although GitHub has work items, issues, and a Kanban board, project management and reporting is the area where Azure DevOps excels. Azure DevOps is highly customizable, which allows an administrator to add custom fields to capture metadata and other information alongside each work item. By contrast, the GitHub Issues feature uses tags as its primary means of helping a team categorize issues. When it comes to source code management and DevOps tools, you need to think about how tightly you need to integrate with third-party tools. Although we make no specific recommendations about third-party tools, it's important for you to understand your organization's existing investments in tools and services, and to evaluate how these dependencies might affect your choice. It's likely that most vendors that create DevOps tools create hooks, or APIs, that can be used by both Azure pipelines and GitHub Actions. Even so, it's probably worth the effort to validate that assumption. In this video, you'll apply the decision criteria that you have already examined to choose the most appropriate services. Let's check in with Tailwind Traders to see what the software development team are busy with. The software development team at Tailwind Traders works on many different projects, both for internal and external usage. The team needs to give project sponsors and managers executive-level reporting. This reporting includes burn-down charts, track progress against epics, and track custom information that's specific to Tailwind Traders in each work item and bug report. As Tailwind Traders grows and hires contractors and outside vendors for short-term work, the upper management team wants to ensure that these individuals have access only to the information they need to do their work. Let's apply the decision criteria to help Tailwind Traders choose the best DevOps solution for each scenario. Does Tailwind Traders need to automate and manage test lab creation? No. In this scenario, Azure Dev Test Labs is not a candidate because it isn't intended for this specific use case. Is Tailwind Traders building open source software? No. Although it's not stated specifically, Tailwind Traders is building internal and external systems, such as their e-commerce system, which isn't open source. So that isn't a consideration in this scenario. Given the level of granularity the Tailwind Traders team needs for assigning permissions, is Azure DevOps a good candidate for this scenario? Yes. Earlier we stated that Tailwind Traders will hire temporary employees and vendors for short-term work. This would make a granular permissions requirement an important consideration for upper management. Based on what we have covered earlier, this feature would make Azure DevOps a leading candidate. By using Azure DevOps, Tailwind Traders administrators would also have a more robust set of options for controlling permissions across the entire portfolio of work. Does Tailwind Traders require a sophisticated project management and reporting solution? Yes. In the Tailwind Traders case study, robust project management and reporting features are one of the primary considerations. Here again, because of the amount of work item customization and reporting the management team wants, Azure DevOps would likely be a good choice. Does Tailwind Traders require tight integration with any third-party DevOps tools? No. Tool integration was not listed as a primary consideration for this scenario. As you learned in the previous session, most third-party DevOps tools integrate both Azure DevOps and GitHub, which makes it likely that the team will find the tools it needs. Considering all the expert criteria in this case, there is no doubt that Azure DevOps is the service we should choose. Tailwind Traders hopes to publish an API that would allow third parties to integrate their own inventories of new and used items. This approach would allow Tailwind Traders to offer a wider variety of products directly from their e-commerce site. Although the internal implementation of the API is closed source, Tailwind Traders wants to create a set of examples that call the API to perform various actions. The team needs a platform to share example code, collect feedback on the API, allow contributors to report issues, and build a community around feature requests. Using our case study, let's continue to apply the decision criteria you learned about previously to help Tailwind Traders find the right option. Does Tailwind Traders need to automate and manage test lab creation? No. So, in this scenario, Azure DevTest Labs is not a candidate because it isn't intended for this specific use case. Is Tailwind Traders building open source software? Yes. As we noted in a previous session, developers are used to seeing this kind of content available on GitHub. With GitHub, Tailwind Traders developers can publish their code, accept community contributions to improve the code examples, accept feedback and bug reports, and more. Because this scenario involves open source code, GitHub is a leading candidate. Given the level of granularity the Tailwind Traders team needs for assigning permissions, is GitHub a good candidate for this scenario? Yes. Although it's not stated explicitly, the fact that Tailwind Traders will be accepting community contributions, issuing reports, and generally attempting to build a community of developers around their API examples, the company's permission needs are basic. Users can either view only or view and write. Does Tailwind Traders require a sophisticated project management and reporting solution? No. Because of the nature of this project, the team doesn't require a sophisticated project management and reporting solution. In this scenario, the strength of the Azure DevOps services isn't required. Does Tailwind Traders require tight integration with any third-party DevOps tools? No. Tool integration wasn't listed as a primary consideration for this scenario. However, this doesn't qualify or disqualify either tool. GitHub is the best choice for this scenario. Although you could use Azure DevOps to make the repository public, some of the other features that involve the development community, such as feedback or bug reports, would be less accessible. Tailwind Traders wants to be more methodical and careful when it pushes new versions of its e-commerce website to production. The company will expand its quality assurance team, and it will use the cloud to create and host virtual machines. Through this approach, it will create testing environments that match the production environment. The management team has concerns around the costs of a more automated test environment. For instance, it wants to make sure that the QA professionals are not wasting time configuring the testing environment to match the production environment. The team wants to ensure that the VMs are destroyed when they're no longer in use. It wants to limit the number of VMs that each QA professional is allowed to spin up. Also, the team wants to ensure that each environment is configured correctly and consistent with the production environment. Once again, start by applying the decision criteria you learned about in the previous session to help Tailwind Traders solve this final scenario. Does Tailwind Traders need to automate and manage test lab creation? Yes, this looks like a job for Azure DevTest Labs because it can do everything that the team needs to accomplish in this scenario. We could continue evaluating the decision criteria, but neither Azure DevOps nor GitHub is needed for this scenario. Remember that either Azure DevOps or GitHub could be used to create product releases that can automatically be included in any VMs that you create for testing purposes. Without software development services and tools from Microsoft, the Tailwind Traders team might have difficulty in realizing the benefits of such DevOps practices as continuous integration and continuous delivery, source code management, and work item management. Congratulations! You have completed AI Services and Solutions. You covered 2 lessons in this module. Let's look back on your journey. In the previous lesson, you helped Tailwind Traders explore several AI service offerings from Azure that it can apply to various business opportunities. You identified a few product options and their capabilities, including Azure Bot Service, Azure Cognitive Services, and Azure Machine Learning. You analyzed certain decision criteria to help yourself choose one option over another, depending on the scenario. Then you applied those decision criteria to 3 Tailwind Traders initiatives, helping the company find the best service option for each scenario. In this lesson, you helped Tailwind Traders choose the best DevOps solution for a set of requirements across various software development and testing needs. You identified various product options and capabilities, including Azure DevOps Services, GitHub, including GitHub Actions, and Azure DevTest Labs. You analyzed the criteria for choosing one option over another in each scenario. Then you applied those criteria to 3 separate challenges at Tailwind Traders, helping the team determine the best service option for the scenarios. DevOps practices and processes have changed the software development landscape, helping to accelerate software development and improve the deployability and quality of software systems. Microsoft offers a wealth of tools that can help organizations implement DevOps practices, experience better collaboration among technical teams, and achieve more consistent results from those teams. Modern software systems running in the cloud are complex. Gaining visibility into the health and performance of your application hosting environment across all of its layers of services is challenging. Fortunately, there are several solutions from Microsoft that can help you react quickly to outages, research intermittent issues, optimize your usage, and be proactive in handling future planned downtime. Tailwind Traders, a traditional brick-and-mortar retailer, is now experiencing explosive growth by selling products online. The company is seeking to tighten and operationalize control of its cloud environment. It faces several challenges, from needing to optimize its cloud spend and security posture to tracking intermittent issues and planning ahead for upcoming outages. However, the company needs help with choosing the right product option for each of these scenarios. In this lesson, you'll learn about the several Microsoft monitoring solutions, and you'll analyze decision criteria that experts use to select the right service for a specific scenario. When you have completed it, you'll be able to choose the cloud monitoring service that best addresses your company's business challenges. When identifying their product options, several basic questions or concerns face all companies that use the cloud. Are we using the cloud correctly? Can we squeeze more performance out of our cloud spend? Are we spending more than we need to? Do we have our systems properly secured? How resilient are our resources? If we experience a regional outage, could we fail over to another region? How can we diagnose and fix issues that occur intermittently? How can we quickly determine the cause of an outage? How can we learn about planned downtime? Fortunately, by using a combination of monitoring solutions on Azure, you can gain answers, insights, and alerts to help ensure that you've optimized your cloud usage. Ascertain the root cause of unplanned issues. Prepare ahead of time for planned outages. At a high level, there are 3 primary Azure monitoring offerings: Azure Advisor, Azure Monitor, Azure Health Service, each of which is aimed at a specific audience and use case and provides a diverse set of tools, services, programmatic APIs, and more. You will be introduced to each of these next. First, let's look at Azure Advisor. This offering evaluates your Azure resources and makes recommendations to help improve reliability, security, and performance, achieve operational excellence, and reduce costs. Advisor is designed to help you save time on cloud optimization. The recommendation service includes suggested actions you can take right away, postpone or dismiss. The recommendations are available via the Azure portal and the API, and you can set up notifications to alert you to new recommendations. When you're in the Azure portal, the Advisor dashboard displays personalized recommendations for all your subscriptions, and you can use filters to select recommendations for specific subscriptions, resource groups, or services. The recommendations are divided into 5 categories. Reliability, used to ensure and improve the continuity of your business-critical applications. Security, used to detect threats and vulnerabilities that might lead to security breaches. Performance, used to improve the speed of your applications. Cost, used to optimize and reduce your overall Azure spending. Operational excellence, used to help you achieve process and workflow efficiency, resource manageability, and deployment best practices. Azure Monitor is a platform for collecting, analyzing, visualizing, and potentially taking action based on the metric and logging data from your entire Azure and on-premises environment. This diagram illustrates just how comprehensive Azure Monitor is. On the left is a list of the sources of logging and metric data that can be collected at each layer in your architecture, from application to operating system and network. In the center, you can see how the logging and metric data is stored in central repositories. On the right, you can see how the data is used. You can view real-time and historical performance across each layer of your architecture, or aggregated and detailed information. The data is displayed at different levels for different audiences. You can view high-level reports on the Azure Monitor dashboard, or create custom views by using Power BI and custom queries. Additionally, you can use the data to help you react to critical events in real time through alerts delivered to teams via SMS, email, and so on. Or you can use thresholds to trigger auto-scaling functionality to scale up or down to meet the demand. Some popular products such as Azure Application Insights, a service for sending telemetry information from application source code to Azure, uses Azure Monitor under the hood. With Application Insights, your application developers can take advantage of the powerful data analysis platform in Azure Monitor to gain deep insights into an application's operations and diagnose errors without having to wait for users to report them. Azure Service Health notifies you about Azure Service incidents and planned maintenance, so you can take action to mitigate downtime. Azure Service Health provides a personalized view of the health of the Azure services, regions, and resources you rely on. The status.azure.com website, which displays only major issues that broadly affect Azure customers, doesn't provide the full picture. But Azure Service Health displays both major and smaller localized issues that affect you. Service issues are rare, but it's important to be prepared for the unexpected. You can set up alerts that help you triage outages and planned maintenance. After an outage, Service Health provides official incident reports called root cause analysis, or RCAs, which you can share with stakeholders. Service Health helps you keep an eye on several event types. Service issues are problems in Azure, such as outages that affect you right now. You can drill down to the affected services, regions, updates from your engineering teams, and find ways to share and track the latest information. Health advisories are issues that allow you to act in advance to avoid service interruption, including service retirements and upcoming changes. Health advisories are announced far in advance to allow you to plan. And finally, with Azure Service Health, you can keep track of planned maintenance events that can affect your availability. You can drill down to the affected services, regions, and details to show how an event will affect you and what you need to do. Most of these events occur without any impact to you and aren't shown here. In the rare case that a reboot is required, Service Health allows you to choose when to perform the maintenance to minimize the downtime. Now you'll analyze the criteria that experts employ when they choose an Azure monitoring service for a specified business need. By understanding the criteria, you can better assess the nuanced differences among the products. If cost reduction, improving resilience, or hardening your security are important considerations for your project, Azure Advisor can help you to achieve your goals. You can use Azure Advisor to analyze your deployed resources. It analyzes the configuration and usage of your resources and provides suggestions on how to optimize them for reliability, security, performance, costs, and operations, based on experts' best practices. You can use Azure Service Health to keep tabs on Azure itself, especially the services and regions you depend on. You can view the current status of the Azure services you rely on, upcoming planned outages, and services that will be sunset. You can set up alerts that help you stay on top of instance and upcoming downtime without having to visit the dashboard regularly. You can use Azure Monitor to keep track of the performance or issues related to your specific VM or container instances, databases, your applications, and so on. You can visit Azure Monitor and create reports and notifications to help you understand how your services are performing or diagnose issues related to your Azure usage. Azure Monitor is also the best option if you are choosing a service to measure custom events alongside other usage metrics. If you need to set up alerts for outages or when autoscaling is about to deploy new instances, again, you can use Azure Monitor to do this. It can set up alerts for key events that are related to your specific resources. You can use Azure Monitor when you want to measure custom events alongside other collected telemetry data. Custom events, such as those added in the source code of your software applications, could help identify and diagnose why your application is behaving a certain way. Tailwind traders want to optimize its cloud spend. Also, the organization is concerned about security breaches because it stores customer data and historical purchase data in cloud-based databases. As the organization ramps up its cloud expertise, it wants to better understand its use of the cloud, better understand best practices, and pinpoint easy wins, where it can tighten up its cloud spend and security practices. To determine which service you should choose, you can apply the decision criteria you learned about earlier to find the right option. Tailwind Traders understands that it might be spending too much, is concerned about its security practices, and wants to have its cloud usage analyzed against industry best practices. Therefore, Azure Advisor is the best option for this scenario. Although you might have found the right product option, let's continue evaluating the decision criteria for this scenario. Second, in this scenario, do you think Tailwind Traders needs to monitor the health of Azure services that affect all customers or the resources that are deployed in Azure? No, it doesn't. This scenario isn't concerned with operations. However, Azure Advisor does analyze and provide recommendations for achieving operational excellence. The third consideration in this scenario: does Tailwind Traders want to measure custom events alongside other usage metrics? No. Measuring custom events isn't mentioned as a requirement and isn't a consideration in this scenario. Fourth, in this scenario, does Tailwind Traders want to set up alerts for outages or when autoscaling is about to deploy new instances? Again, this scenario isn't concerned with operations. However, Azure Advisor does analyze and provide recommendations for achieving operational excellence. Azure Advisor is the right product option to help Tailwind Traders better understand and optimize both its cloud spend and its cloud security posture. This product might help the organization with other areas of cloud usage as well. The Tailwind Traders e-commerce website is experiencing intermittent errors, and the team is unsure of the cause. Because of the nature of the errors, the team suspects that it's either a database or a caching issue. What are the circumstances surrounding the errors? Does it happen only during peak usage times? What is the state of the team's Azure SQL instance? How can it trace the issues to a root cause? Just as before, you should apply the decision criteria that you learned about earlier to find the right option. First, in this scenario, does Tailwind Traders need an analysis of its Azure usage for the sake of optimization? No. Optimization isn't the team's objective in this scenario, so Azure Advisor isn't a candidate. Because this issue happens intermittently, it's unlikely to affect an entire Azure region or service. It's more likely that a logic issue exists somewhere in their e-commerce website code, or another issue is causing database failures or caching locks. In this scenario, the team could use Azure Monitor to pinpoint a specific user session and look at the performance of each service that's involved in the issue. The third decision in this scenario is, does Tailwind traders want to measure custom events alongside other usage metrics? Yes. Software developers can send additional information about the state of the web application via Application Insights to help locate the root cause of the issue. Application Insights relies on the Azure Monitor platform to store custom event information. Fourth, in this scenario, does Tailwind traders want to set up alerts for outages or when autoscaling is about to deploy new instances? No, alerting isn't their objective in this scenario. Azure Monitor is the best option for helping Tailwind traders track this intermittent issue. The team can use a wealth of tools to help it gain insight into the application's performance at a high level and deep dive into specific issues. Tailwind Traders wants to operationalize its cloud environment. Specifically, its cloud operations team wants to let stakeholders know about upcoming planned downtime in advance. The team also wants its solution architects to be forewarned about any Microsoft plans to sunset services so it can re-architect its software products accordingly. When outages do happen, the team wants to quickly ascertain whether the issue is specific to their services or a service interruption that affects many Azure customers. The team also wants to provide key stakeholders with reports that explain how and why the incident occurred, and so on. Again, apply the decision criteria you learned about earlier to find the right product. First, does Tailwind traders need to analyze its Azure usage for the sake of optimization? No, so Azure Advisor isn't a candidate for this scenario. Second, does Tailwind traders want to monitor the health of Azure services that affect all customers, or the resources deployed on Azure? The requirement is to stay abreast of upcoming planned downtime. Additionally, the team wants to capture official incident reports. For this reason, Azure Service Health is the strongest candidate to choose for this scenario. Although it's likely that you would choose Azure Service Health, let's continue evaluating the remaining decision criteria. Third, does Tailwind traders want to measure custom events alongside other usage metrics? No. Measuring custom events isn't mentioned as a requirement and isn't a consideration in this scenario. Setting up alerts for outages is a requirement, but creating alerts for other events such as auto-scaling are not in scope. You can use Azure Service Health to set up alerts that are specific to Azure outages that affect all Azure customers. Or you can use Azure Monitor to set up alerts for outages and other events that affect only your specific resources. In this scenario, Azure Service Health is the correct option to choose. Congratulations! You have completed this lesson. Our goal in this lesson was to help Tailwind traders explore several monitoring service offerings from Azure to apply to a variety of business scenarios. We identified 3 product options and their capabilities: Azure Advisor, Azure Monitor, and Azure Service Health. We analyzed decision criteria for choosing one option over another for certain scenarios. Then we applied those decision criteria to 3 different challenges faced by Tailwind traders, helping them find the best service option for the scenario. Without monitoring services, Tailwind traders would spend more money on its cloud environment, be unsure about its cloud security posture, have difficulty pinpointing issues in its application logic, and be unable to plan ahead for outages or supply formal outage reports to stakeholders. Azure monitoring services provide a comprehensive array of features to help improve your cloud operations. By using Azure Management tools, administrators, developers, and managers can interact with the cloud environment to perform such tasks as deploying dozens or hundreds of resources at a time, configuring individual services programmatically, viewing rich reports across usage, health, costs, and more. Microsoft Azure provides a collection of management tooling options to choose from, depending on the situation. Tailwind Traders, a traditional brick-and-mortar retailer, is now experiencing explosive growth by selling products online. The company owes much of its success to an ability to quickly and efficiently manage its cloud environment. As it began its cloud journey, Tailwind Traders initially had to choose the right management tools for its business needs. In this lesson, you'll explore the array of Azure management tools and the decision criteria that experts use to select the right ones for their specific scenarios. After completing this lesson, you'll be able to choose the Azure management tools that best address your organization's technical needs and challenges. At a high level, there are two broad categories of management tools: visual tools and code-based tools. Visual tools provide visually friendly access to all the functionality of Azure. However, visual tools might be less useful when you're trying to set up a large deployment of resources with interdependencies and configuration options. When you're attempting to quickly set up and configure Azure resources, a code-based tool is usually the better choice, although it might take time to understand the right commands and parameters at first. After they've been entered, they can be saved into files and used repeatedly as needed. Also, the code that performs setup and configuration can be stored, versioned, and maintained along with application source code in a source code management tool such as Git. This approach to managing hardware and cloud resources, which developers use when they write application code, is referred to as infrastructure as code. There are two approaches to infrastructure as code. Imperative code details each individual step that should be performed to achieve a desired outcome. By contrast, declarative code details only a desired outcome, and it allows an interpreter to decide how to best achieve that outcome. This distinction is important because tools that are based on declarative code can provide a more robust approach to deploying dozens or hundreds of resources simultaneously and reliably. Microsoft offers a variety of tools and services to manage your cloud environment, each aimed at different scenarios and users. By using the Azure portal, a web-based user interface, you can access virtually every feature of Azure. The Azure portal provides a friendly graphical UI to view all the services you're using, create new services, configure your services, and view reports. The Azure portal is how most users first experience Azure. But as your Azure usage grows, you'll likely choose a more repeatable, code-centric approach to managing your Azure resources. The Azure mobile app provides iOS and Android access to your Azure resources when you're away from your computer. With it, you can monitor the health and status of your Azure resources, check for alerts, quickly diagnose and fix issues and restart a web app or virtual machine, run the Azure CLI or Azure PowerShell commands to manage your Azure resources. Azure PowerShell is a shell with which developers and DevOps and IT professionals can execute commands called commandlets. These commands call the Azure REST API to perform every possible management task in Azure. Commandlets can be executed independently or combined into a script file and executed together to orchestrate the routine setup, teardown, and maintenance of a single resource or multiple connected resources, the deployment of an entire infrastructure, which might contain dozens or hundreds of resources from imperative code. Capturing the commands in a script makes the process repeatable and automatable. Azure PowerShell is available for Windows, Linux, and Mac, and you can access it in a web browser via Azure Cloud Shell. Windows PowerShell has helped Windows-centric IT organizations automate many of their on-premises operations for years, and these organizations have built up a large catalog of custom scripts and commandlets, as well as expertise. The Azure CLI is an executable program with which a developer, DevOps professional, or IT professional can execute commands in Bash. The commands call the Azure REST API to perform every possible management task in Azure. You can run the commands independently or combined into a script and execute it together for the routine setup, teardown, and maintenance of a single resource or an entire environment. In many respects, the Azure CLI is almost identical to Azure PowerShell in what you can do with it. Both run on Windows, Linux, and Mac, and can be accessed in a web browser via Cloud Shell. The primary difference is the syntax you use. If you're already proficient in PowerShell or Bash, you can use the tool you prefer. Although it's possible to write imperative code in Azure PowerShell or the Azure CLI to set up and tear down one Azure resource or orchestrate an infrastructure comprising hundreds of resources, there's a better way to implement this functionality. By using Azure Resource Manager templates, you can describe the resources you want to use in a declarative JSON format. The benefit is that the entire ARM template is verified before any code is executed to ensure that the resources will be created and connected correctly. The template then orchestrates the creation of those resources in parallel. That is, if you need 50 instances of the same resource, all 50 instances are created at the same time. Ultimately, the developer, DevOps professional, or IT professional needs only to define the desired state and configuration of each resource in the ARM template, and the template does the rest. Templates can even execute PowerShell and Bash scripts before or after the resource has been set up. Next, you'll get a chance to analyze the criteria that experts employ to help them decide which Azure management tools to use to address their business needs. Understanding the criteria can help you better understand the nuanced differences among the products. Do you need to perform one-off management, administrative, or reporting actions? Use either Azure PowerShell or the Azure CLI if you need to quickly obtain the IP address of a virtual machine you've deployed, reboot a VM, or scale an app. You might want to keep custom scripts handy on your local hard drive for certain operations that you perform occasionally. By contrast, Azure Resource Manager templates express the infrastructure requirements for your application for a repeatable deployment. ARM templates aren't intended for one-off scenarios, but depending on the scenario, it's possible to use them for this purpose. In these instances, you should prefer PowerShell, Azure CLI scripts, or the Azure portal. Also, ARM templates can include PowerShell or Azure CLI scripts, which can trigger the execution of ARM templates. This gives you flexibility in choosing the right tool for your particular needs. You could perform most, if not all, management and administrative actions via Azure portal. If you're just learning Azure, need to set up and manage resources infrequently, or prefer a visual interface for viewing reports, it makes sense to take advantage of the visual presentation that the Azure portal offers. However, if you're in a cloud management or administrative role, it's less efficient to rely solely on visual scanning and clicking. To find the settings and information you want to work with, it's often quicker and more repeatable to use the Azure CLI or PowerShell. The last option in this case is the Azure mobile app, which you can access via an iOS or Android phone or tablet. Because it's full-featured, it's likely the best choice when a laptop isn't readily available and you need to view and triage issues immediately. Now, if you need a way to repeatedly set up one or more resources and ensure that all the dependencies are created in the proper order, you can use ARM templates. In a way, they can express your application's infrastructure requirements for a repeatable deployment. A validation step ensures that all resources can be created, so that the resources are created in the proper order based on dependencies, in parallel, and idempotent. By contrast, it's entirely possible to use either PowerShell or the Azure CLI to set up all the resources for a deployment. However, there's no validation step in these tools. If a script encounters an error, the dependency resources can't be rolled back easily. Deployments happen serially, and only some operations are idempotent. When you're scripting, do you come from a Windows administration or Linux administration background? If you or your cloud administrators come from a Windows administration background, it's likely you'll prefer PowerShell. If you or your cloud administrators come from a Linux administration background, it's likely you'll prefer the Azure CLI. In practice, either tool can be used to perform most one-off administration tasks. Tailwind Traders uses Azure extensively throughout its entire organization. To make sure that both the technical and executive teams are aware of the company's cloud spend, the Director of Cloud Operations will begin to meet weekly with the Chief Financial Officer to talk about their cloud spend. Conversations might begin at a high level, but the two officers might want to deep dive during the meeting to gain more insight into how Azure resources are being used. Ideally, they would be able to see the data displayed visually, but also be able to run custom reports in real time. You will decide which tool they can use during their meeting. To determine which service you should choose, you can apply the decision criteria you learned about earlier to find the right option. First, in this scenario, do you think Tailwind traders need to perform one-off management, administrative, or reporting actions? Yes, and given the requirement to view data visually and create custom reports during the meeting, the Azure portal is the best choice. The meeting attendees can quickly find answers to their questions by using a wealth of reporting options. The next two decisions you need to make are: is there a way to repeatedly set up one or more resources? And is your scripting background in Windows or Linux? These questions don't apply to this scenario because the Director of Cloud Operations and the CFO won't be deploying or configuring any resources. Therefore, the Azure portal is the correct product option for this scenario. Tailwind Traders employs technologists with many different skills. A team of developers and administrators builds and maintains a collection of intranet applications that are vital to the business. The team members have strong backgrounds in Windows development and network administration. The team moves its applications to the cloud, and it now needs a way to perform one-off testing, management, and administrative tasks in its intranet environment. The team quickly realized that managing Azure from the portal takes too much time and is not repeatable. Which tool should the company use for one-off tasks? As you did before, apply the decision criteria you learned about to find the right option. First, in this scenario, does the Tailwind Traders team need to perform one-off management, administrative, or reporting tasks? Yes. However, the team already knows that it doesn't want to rely on the Azure portal for these one-off actions. Therefore, both Azure PowerShell and the Azure CLI are good options. We'll hone in on which tool the team should use in a moment. Second, in this scenario, does Tailwind Traders need a repeatable and reliable means of deploying its entire infrastructure? No, not in this scenario. Therefore, Azure Resource Manager templates are not the right choice. When the Tailwind Traders team is doing scripting, does it come from a Windows administration or Linux administration background? This team has a Windows administration background. It would likely be most comfortable using Azure PowerShell because this tool allows it to use the syntax it's most comfortable with to perform one-off administration tasks. Did you work it out? Azure PowerShell is the best choice for this scenario. As we noted before, Tailwind Traders employs technologists with many different skills. The DevOps team is primarily concerned with keeping external systems, such as the company's e-commerce site, up and running. This team has a Linux administration background. It frequently needs to perform administrative tasks related to the health of the cloud environment. The team quickly realized that managing Azure from the portal takes too much time and isn't repeatable. Which tool should it use for one-off tasks? Once again, apply the decision criteria you learned about earlier to find the right option. Because this scenario is almost identical to the one before, you can skip over the first two criteria. In other words, you can quickly eliminate the Azure Resource Manager templates and the Azure portal as viable options for this scenario. So, let's go to the third decision criterion. Choosing the right option in this scenario should be determined by the team's background. Because this team has a Linux administration background, it would likely be most comfortable using the Azure CLI. The Azure CLI allows the team to use the bash shell and its syntax to perform one-off administration tasks. The Azure CLI is the best choice for this scenario. Tailwind Traders experiences surges in e-commerce traffic that coincide with national holidays and weekends. In the company's first few years, managers of critical systems had to convene at the office of the Director of Cloud Operations during these important periods. However, now that Tailwind Traders has successfully operationalized most critical systems, the director wants to relax this requirement and allow employees to spend these dates with their families. Is there a product that can help support this scenario? The first question you need to ask in this scenario is, does Tailwind Traders need to remotely monitor and administer services? Yes, it does. But the real question is, how? A phone or tablet solution could help key employees keep an eye on the health of the cloud environment when they're out of the office. The Azure mobile app is likely a good compromise because it lets employees be away from work and still perform essential one-off management and administrative tasks. We can skip the rest of the decision criteria in this unique scenario. The Azure mobile app is the right choice. Tailwind Traders want to operationalize their cloud deployments. The company needs a repeatable, reliable way to scale its operations during peak sales periods. Because you'll be choosing a process for scaling your production environment, you need to ensure that your chosen service is efficient and can potentially create many resources in parallel, creates all dependencies in the correct order, can be used without worrying that it failed in the middle of provisioning the necessary infrastructure. Let's run through the decision criteria one more time. First, in this scenario, does Tailwind Traders need to perform one-off management, administrative, or reporting actions? This time, we're not looking to support one-time or one-off management or administration tasks. We're looking for a technology to automate the deployment of an entire infrastructure as needed. Second, does Tailwind Traders need a repeatable and reliable way to deploy its entire infrastructure? Yes, this is exactly what the company needs. Our decision criteria lead us to choose Azure Resource Manager templates for this scenario. Also, does Tailwind Traders need a repeatable and reliable way to deploy its entire infrastructure? Yes, this is exactly what the company needs. Our decision criteria leads us to choose Azure Resource Manager templates for this scenario. The third decision criterion assumes that you need to write a script by using imperative code. However, when you use ARM templates, you define your infrastructure declaratively by using JSON code. In some instances, you still might need imperative code for configuration or cleanup tasks. In these cases, you can trigger the execution of scripts by using either Azure PowerShell or the Azure CLI to perform these tasks. In this scenario, to scale production environment, ARM templates are the correct choice. Our goal in this module was to help Tailwind Traders choose the right cloud management tools from Microsoft for its various technical needs. We identified a variety of product options and their capabilities, including the Azure Portal, the Azure mobile app, Azure PowerShell, the Azure CLI, and Azure Resource Manager templates. We analyzed decision criteria for choosing one option over another in specific scenarios. We then applied those decision criteria to 3 different Tailwind Traders initiatives, helping the company find the best service option for each scenario. Without a full suite of management tools, the company would be severely limited in how it interacts with Azure. Fortunately, Azure provides a powerful mix of visual management tools, imperative scripting tools, and declarative infrastructure as code tools. Hello and welcome to Azure Serverless Technology and IoT. In the first lesson, you learn about 2 serverless computing solutions in Azure, Azure Functions and Azure Logic Apps. You'll examine what they are, how they differ, and when you should choose one over the other. You'll be introduced to these tools and services and will be asked to help choose the best one for a given business scenario. In the second lesson, you'll help Tailwind traders select the right Azure IoT service offering for its business scenarios. By evaluating the services in relation to a set of decision criteria, you'll learn about what the various services do, how they're different or complementary, and when to use one or the other. To get the most out of this module, you should have an understanding of the concept of orchestration and workflows, an understanding of the concept of APIs, and a high-level familiarity with relevant Microsoft products such as Dynamics 365 and Office 365. In this module, you will help Tailwind traders to choose which Azure Serverless technology and Azure IoT solutions are right for different business scenarios. Tailwind Traders, a traditional brick-and-mortar retailer, has found success selling online. The company sees several opportunities to improve its e-commerce website. For example, it wants to provide more accurate real-time inventory information online to customers who want to visit their local store to purchase an item. The company also wants to respond more proactively to customers who've had a negative experience by providing a new customer retention program. Tailwind Traders suspects that serverless computing can help it provide these services, but it needs help to understand which Azure solutions are right for its business scenarios. Serverless computing is a term used to describe an execution environment that's set up and managed for you. You merely specify what you want to happen by writing code or connecting and configuring components in a visual editor, and then specify the actions that trigger your functionality, such as a timer or an HTTP request. Best of all, you never have to worry about an outage. Your code can scale instantly to meet demand, and you pay based only on the actual usage of your code. By the end of this lesson, you'll be able to choose the serverless computing technology that best addresses Tailwind traders' business scenarios. There are two serverless computing solutions on Azure: Azure Functions and Azure Logic Apps. Before we start, let's take another look at the key principles of serverless computing. Serverless computing is a cloud-hosted execution environment that runs your code but abstracts the underlying hosting environment. The term serverless computing is a misnomer. After all, there is a server, or a group of servers, that executes your code or desired functionality. The key idea is that you're not responsible for setting up or maintaining the server. You don't have to worry about scaling it when there's increased demand, and you don't have to worry about outages. The cloud vendor takes care of all maintenance and scaling concerns for you. You create an instance of the service and you add your code. No infrastructure configuration or maintenance is required or even allowed. You configure your serverless apps to respond to events. An event could be a REST endpoint, a periodic timer, or even a message received from another Azure service. The serverless app runs only when it's triggered by an event. Scaling and performance are handled automatically, and you're billed only for the resources you use. You don't even need to reserve resources. Serverless computing is ordinarily used to handle back-end scenarios. In other words, serverless computing is responsible for sending messages from one system to another, or processing messages that were sent from other systems. It's not used for user-facing systems, but rather it works in the background. The core Azure services for serverless are Azure Functions and Azure Logic Apps. Both solutions help developers to build robust cloud apps with minimal code. Let's take a closer look at how each of these serverless automation platforms work within Azure. With the Azure Functions service, you can host a single method or function by using a popular programming language in the cloud that runs in response to an event. An example of an event might be an HTTP request, a new message on a queue, or a message on a timer. Because of its atomic nature, Azure Functions can serve many purposes in an application's design. Functions can be written in many common programming languages, such as C#, Python, JavaScript, TypeScript, Java, and PowerShell. Azure Functions scales automatically and changes accrue only when a function is triggered. These qualities make Azure Functions a solid choice when demand is variable. For example, You might be receiving messages from an IoT solution that monitors a fleet of delivery vehicles. You'll likely have more data arriving during business hours. Azure functions can scale out to accommodate these busier times. An Azure function is a stateless environment. A function behaves as if it's restarted every time it responds to an event. This feature is ideal for processing incoming data. And if state is required, the function can be connected to an Azure storage account. Azure functions can perform orchestration tasks by using an extension called durable functions, which allows developers to chain functions together while maintaining state. The Azure Function solution is ideal when you're concerned only with the code that's running your service and not the underlying platform or infrastructure. You use functions most commonly when you need to perform work in response to an event. You do this often via a REST request, timer, or message from another Azure service, and when that work can be completed quickly, within seconds or less. Now let's explore the key components of Logic Apps. Logic Apps is a low-code, no-code development platform hosted as a cloud service. This service helps you automate and orchestrate tasks, business processes, and workflows when you need to integrate apps, data, systems, and services across enterprises or organizations. Logic Apps simplifies how you design and build scalable solutions, whether in the cloud, on-premises, or both. This solution covers app integration, data integration, system integration, enterprise application integration, and business-to-business integration. Azure Logic Apps is designed in a web-based designer and can execute logic that's triggered by Azure services without your having to write any code. You build an app by linking triggers to actions with connectors. A trigger is an event, such as a timer, that causes an app to execute a new message to be sent to a queue, or an HTTP request. An action is a task or step that can execute. There are logic actions such as those you would find in most programming languages. Examples of actions include working with variables, decision statements and loops, and tasks that parse and modify data. To build enterprise integration solutions with Azure Logic Apps, you can choose from a growing gallery of over 200 connectors. The gallery includes services such as Salesforce, SAP, Oracle DB, and file shares. If you can't find the action or connector you need, you can build your own by using custom code. Both Azure Functions and Azure Logic Apps help enable business logic that automates your Azure workflow. The primary difference between the two services is their intent. Azure Functions is a serverless compute service, and Azure Logic Apps is intended to be a serverless orchestration service. Although you can use Azure Functions to orchestrate a long-running business process that involves various connections, this was not its primary use case when it was designed. Additionally, the two services are priced differently. Azure Functions pricing is based on the number of executions and the running time of each execution. Logic Apps pricing is based on the number of executions and the type of connectors that it utilizes. With two viable serverless options, it can be difficult to know which is the best one for the job. In this session, you'll analyze the criteria that experts employ when they're choosing a serverless service to use for a given business need. Understanding the criteria can also help you better understand the nuanced differences between the products. When choosing the most appropriate serverless solution, you should ask yourself if you need to perform an orchestration across well-known APIs. As we noted previously, Azure Logic Apps was designed with orchestration in mind, from the web-based visual configurator to the pricing model. Logic Apps excels at connecting a large array of disparate services via their APIs to pass and process data through many steps in a workflow. It's possible to create the same workflow by using Azure Functions, but it might take a considerable amount of time to research which APIs to call and how to call them. Azure Logic Apps has already componentized these API calls so that you supply only a few details and the details of calling the necessary APIs is abstracted away. Although Azure Logic Apps can perform logic, loops, decisions, and so on, if you have a logic-intensive orchestration that requires a complex algorithm, implementing that algorithm might be more long-winded and visually overwhelming. With Azure Functions, you can use the full expressiveness of a programming language in a compact form. This lets you concisely build complex algorithms or data lookup and parsing operations. You would be responsible for maintaining the code, handling exceptions resiliently, and so on. Next, you need to think about your existing code. If you already have your orchestration or business logic expressed in C#, Java, Python, or another popular programming language, it might be easier to port your code into the body of an Azure Functions function app than to recreate it by using Azure Logic Apps. Ultimately, your choice comes down to whether you prefer to work in a declarative environment or an imperative environment. Developers who have expertise in an imperative programming language might prefer to think about automation and orchestration from an imperative mindset. IT professionals and business analysts might prefer to work in a more visual low-code, no-code declarative environment. Azure Logic Apps is best suited for users who are more comfortable in a visual environment that allows them to automate their business processes. Azure Functions is best suited for software developers and those with expertise in an imperative programming language. Data about each product that's sold at Tailwind Traders is packaged as a JSON message and sent to an event hub. The event hub distributes the JSON message to subscribers, which allows various systems to be notified. Tailwind Traders wants to upgrade its e-commerce site to include real-time inventory tracking. Currently, the website updates product availability nightly at 2 a.m. A Windows service that's written in C# contains all of the necessary logic to retrieve the messages, parse the JSON, perform a lookup across multiple databases to find additional product information, and potentially send notifications to the purchasing department so that they can reorder quantities that fall below certain levels. The Windows service runs in a virtual machine that's hosted on Azure. Most of the time, this system works fine. However, some products are in high demand, and some products are kept in low quantities at each store. Several times a day, customers drive to a store to pick up an item only to find that it's no longer in stock. Instead of running the algorithm nightly, the company wants to run the inventory updater each time a product is purchased. Let's apply the decision criteria you learned about earlier to find the right option for Tailwind Traders. Because the Tailwind Traders developers team has already written the logic in C#, it would make sense to copy the relevant C# code from the Windows service and port it to an Azure function. The developers would bind the function to trigger each time a new message appears on a specific queue. It's possible to implement the same logic in Azure Logic Apps. However, because the team has already invested time in building the service in C#, it can use the same code in an Azure function. Tailwind Traders sends its customers an invitation to participate in a customer satisfaction survey randomly after a purchase. Currently, the customer satisfaction results are aggregated, averaged, and charted. However, its customer service department sees an opportunity to reach out proactively to customers who provide low scores and leave comments with a negative sentiment. Ideally, negative customer satisfaction scores would trigger a customer retention workflow. First, a sentiment analysis would be generated based on the free-form comments. An email would be sent to the customer with an apology and a coupon code, and the message would be routed to the Dynamics 365 customer service team so that it could schedule a follow-up email. Unfortunately, no Tailwind Traders developer resources are available to take on this project. But the customer service team works with several cloud and IT professionals who might be able to construct a solution. Once again, apply the decision criteria you learned about earlier to find the right option for Tailwind Traders. This is an ideal scenario for Azure Logic Apps. Connectors already exist for each of the steps outlined in the workflow. Because Azure Logic Apps is a low-code, no-code service, no developers are needed. A cloud or IT professional should be able to build and support this workflow. A cloud or IT professional could use existing connectors to perform a sentiment analysis by using the Azure Cognitive Services connector, send an email by using the Office 365 Outlook connector, and create a new record and follow-up email by using the Dynamics 365 Customer Service connector. Using Azure Functions as an alternative would take quite a bit of research, development, and testing for a developer to build a solution that utilizes all these disparate software systems. Welcome back. In this lesson, you'll help Tailwind traders select the right Azure IoT service offering for its business scenarios. By evaluating the services in relation to a set of decision criteria, you'll learn what the various services do, how they're different or complementary, and when to use one or the other. Tailwind Traders sees many opportunities to use Azure IoT services across many different facets of their operations, from new product development to logistics and point of sale. IoT bridges the physical and digital worlds by enabling devices with sensors and an internet connection to communicate with cloud-based systems via the internet. By the end of this lesson, you'll be able to choose the Azure IoT service that best addresses Tailwind Traders' business scenarios. IoT enables devices to gather and then relay information for data analysis. Smart devices are equipped with sensors that collect data. A few common sensors that measure attributes of the physical world include environmental sensors that capture temperature and humidity levels, barcode, QR, or optical character recognition scanners, geolocation and proximity sensors, light, color, and infrared sensors, sound and ultrasonic sensors, motion and touch sensors, accelerometer and tilt sensors, smoke, gas, and alcohol sensors, error sensors to detect when there's a problem with the device, mechanical sensors that detect anomalies or deformations, and flow, level, and pressure sensors for measuring gases and liquids. By using Azure IoT services, devices that are equipped with these kinds of sensors and that can connect to the internet could send their sensor readings to a specific endpoint in Azure via a message. The message's data is then collected and aggregated, and it can be converted into reports and alerts. Alternately, all devices could be updated with new firmware to fix issues or add new functionality by sending software updates from Azure IoT services to each device. Let's suppose your company manufactures and operates smart refrigerated vending machines. What kinds of information would you want to monitor? You might want to ensure that each machine is operating without any errors. The machines haven't been compromised. The machine's refrigeration systems are keeping their contents within a certain temperature range. And that you're notified when products reach a certain inventory level so you can restock the machines. If the hardware of your vending machines can collect and send this information in a standard message, the messages each machine sends can be received, stored, organized, and displayed by using Azure IoT services. The data that's collected from these devices could be combined with Azure AI services to help you predict when machines need proactive maintenance, when inventories will need to be replenished and new product ordered from vendors. Many services can assist and drive end-to-end solutions for IoT on Azure. In this lesson, you'll explore Azure IoT Hub, Azure IoT Central, and Azure Sphere. Azure IoT Hub is a managed service that's hosted in the cloud and that acts as a central message hub for bidirectional communication between your IoT application and the devices it manages. You can use Azure IoT Hub to build IoT solutions with reliable and secure communications between millions of IoT devices and a cloud-hosted solution backend. You can connect virtually any device to your IoT Hub. The IoT Hub service supports communications both from the device to the cloud and from the cloud to the device. It also supports multiple messaging patterns, such as device-to-cloud telemetry, file upload from devices, and request-reply methods to control your devices from the cloud. After an IoT Hub receives messages from a device, it can route that message to other Azure services. From a cloud-to-device perspective, IoT Hub allows for command and control. That is, you can have either manual or automated remote control of connected devices, so you can instruct the device to open valves, set target temperatures, restart stuck devices, and so on. IoT Hub monitoring helps you maintain the health of your solution by tracking events such as device creation, device failures, and device connections. Azure IoT Central builds on top of IoT Hub by adding a dashboard that allows you to connect, monitor, and manage your IoT devices. The visual user interface makes it easy to quickly connect new devices and watch as they begin sending telemetry or error messages. You can watch the overall performance across all devices in aggregate, and you can set up alerts that send notifications when a specific device needs maintenance. Finally, you can push hardware updates to the device. To help you get up and running quickly, IoT Central provides starter templates for common scenarios across various industries, such as retail, energy, healthcare, and government. You then customize the design starter templates directly in the UI by choosing from existing themes or creating your own custom theme, setting the logo, and so on. With IoT Central, you can tailor the starter templates for the specific data that's sent from your devices, the reports you want to see, and the alerts you want to send. You can use the UI to control your devices remotely. This feature allows you to push a software update or modify a property of the device. You can adjust the desired temperature for one or all of your refrigerated vending machines from directly inside of IoT Central. A key part of IoT Central is the use of device templates. By using a device template, you can connect a device without any service-side coding. IoT Central uses the templates to construct the dashboards, alerts, and so on. Device developers still need to create code to run on the devices, and that code must match the device template specification. Azure Sphere creates an end-to-end, highly secure IoT solution for customers that encompasses everything from the hardware and operating system on the device to the secure method of sending messages from the device to the message hub. Azure Sphere has built-in communication and security features for internet-connected devices. Azure Sphere comes in 3 parts. The first part is the Azure Sphere Microcontroller Unit, or MCU, which is responsible for processing the operating system and signals from attached sensors. This image displays the Seed Azure Sphere MT3620 Development Kit MCU, one of several different starter kits that are available for prototyping and developing Azure Sphere applications. The second part is a customized Linux operating system that handles communication with the security service and can run the vendor's software. And the third part is Azure Sphere Security Service, also known as AS3. Its job is to make sure that the device has not been maliciously compromised. AS3 is Microsoft's cloud-based service that communicates with Azure Sphere chips to enable maintenance, update, and control. When the device attempts to connect to Azure, it first must authenticate itself per device, which it does by using certificate-based authentication. If it authenticates successfully, AS3 checks to ensure that the device hasn't been tampered with. After it has established a secure channel of communication, AS3 pushes any OS or approved customer-developed software updates to the device. After the Azure Sphere system has validated the authenticity of the device and authenticated it, the device can interact with other Azure IoT services by sending telemetry and error information. Now that you have looked at how Azure IoT Hub, Azure IoT Central, and Azure Sphere can assist and drive end-to-end solutions for IoT on Azure, next you will choose the appropriate service to use in different business scenarios. In this video, you'll analyze the criteria that experts employ when they decide which IoT service to use for a given business need. Understanding the criteria can also help you better understand the nuanced differences between each product. Let's start off by looking at security. Whether you are a manufacturer or customer, you don't want your devices to be maliciously compromised and used for criminal purposes. It's obviously more critical to ensure the integrity of an ATM than, say, a washing machine. So when choosing the correct option, you always look at what is most critical for your needs before making a decision. When security is a critical consideration in your product's design, the best product option is Azure Sphere, which provides a comprehensive end-to-end solution for IoT devices. As we mentioned previously, Azure Sphere ensures a secure channel of communication between the device and Azure by controlling everything from the hardware to the operating system and the authentication process. This ensures that the integrity of the device is uncompromised. After a secure channel is established, messages can be received from the device securely and messages or software updates can be sent to the device remotely. Your next decision will be the level of services you require from your IoT solution. If you merely want to connect to your remote devices to receive telemetry and occasionally push updates, and you don't need any reporting capabilities, you might prefer to implement Azure IoT Hub by itself. Your programmers can still create a customized set of management tools and reports by using the IoT Hub RESTful API. IoT Central integrates with many different Azure products, including IoT Hub, to create a dashboard with reports and management features. The dashboard is based on starter templates for common industry and usage scenarios. You can use the dashboard that's generated by the starter template as is or customize it to suit your needs. You can have multiple dashboards and target them at a variety of users. The Tailwind Traders senior leadership team has decided to partner with a leading appliance manufacturer to create an exclusive, high-end brand that promises a preemptive maintenance service agreement. This unique feature would differentiate Tailwind Traders appliances in a crowded, competitive market. The feature also makes the brand lucrative because a yearly subscription would be required. To build a strong brand reputation, the appliances will send telemetry information to a centralized location where it can be analyzed and maintenance can be scheduled. The devices will not require remote control. They will merely be sending their telemetry data for analysis and proactive maintenance. Because Tailwind Traders already has software in place for managing appliance maintenance requests, the company wants to integrate all functionality into this existing system. Let's apply the decision criteria you learned about earlier to find the right option for Tailwind Traders. Do you think it is critical to ensure that the device, or in this case, each appliance, isn't compromised? No, it's preferable, but not critical, that the devices aren't compromised. The worst that could happen is a hacker reads the current temperature of the customer's refrigerator, or the number of loads of laundry the washing machine has completed. Even if the customer calls and reports strange behavior with their appliance, a technician could reset or replace the microcontroller. It might not warrant the extra expense or engineering resources that would be required to employ Azure Sphere. But why not? Azure Sphere provides a complete solution for scenarios where security is critical. In this scenario, security is preferred, but not critical. The appliances can't be updated with new software remotely. The sensors merely report usage data. As a result, Azure Sphere isn't necessary. In this case, do you think you need a dashboard for reporting and management? No. Tailwind Traders wants to integrate the telemetry data and all other functionality into an existing maintenance request system. Given the responses to the decision criteria, Azure IoT Hub is the best choice in this scenario. Azure IoT Central provides a dashboard that allows companies to manage IoT devices individually and in aggregate, view reports and set up error notifications via a GUI. But in this scenario, Tailwind Traders wants to integrate the telemetry it collects and other analysis functionality into an existing software application. Furthermore, the company's appliances will be collecting data via sensors only and don't need the ability to update settings or software remotely. Therefore, the company doesn't need Azure IoT Central. Azure Sphere provides a complete solution for scenarios where security is critical. In this scenario, security is preferred but not critical. The appliances can't be updated with new software remotely. The sensors merely report usage data. As a result, Azure Sphere isn't necessary. Tailwind Traders owns a fleet of delivery vehicles that transport products from warehouses to distribution centers, and from distribution centers to stores and homes. The company is looking for a complete logistics solution that takes data sent from an onboard vehicle computer and turns it into actionable information. Furthermore, shipments can be outfitted with sensors from a third-party vendor to collect and monitor ambient conditions. These sensors can collect information such as temperature, humidity, tilt, shock, light, and the location of a shipment. The goals for this logistics system are shipment monitoring with real-time tracing and tracking, shipment integrity with real-time ambient condition monitoring, security from theft, loss, or damage of shipments, geofencing, route optimization, fleet management and vehicle analytics, and forecasting for predictable departure and arrival of shipments. The company would prefer a pre-built solution to collect the sensor and vehicle computer data and provide a graphical user interface that displays reports about shipments and vehicles. Let's find the right solution. In this case, is it critical to ensure that the device isn't compromised? Ideally, each sensor and vehicle computer would be impervious to interference. However, security was not mentioned as a critical concern at this point. The vehicle computers and sensors are built by a third-party vendor and, unless Tailwind Traders wants to manufacture its own devices, which they don't, the company will be forced to use hardware that's already available. Does Tailwind Traders need a dashboard for reporting and management? Yes, a reporting and management dashboard is a requirement. If Tailwind Traders uses IoT Central, the company would actually be using an IoT hub that's pre-configured for its specific needs by the Connected Logistics Starter template. Otherwise, the company would need to do a lot of custom development to build its own cloud-based dashboards and management systems on top of Azure IoT Hub. On the other hand, Azure Sphere provides a complete solution for scenarios where security is critical. In this scenario, security is ideal, but not a critical priority. Although Azure Sphere provides an end-to-end solution that includes hardware, Tailwind Traders will use hardware from a third-party vendor. So, in this scenario, Azure Sphere is not necessary. In this scenario, you can see that IoT Central is the best choice. Tailwind Traders wants to implement a touchless point-of-sale solution for self-checkout. The self-checkout terminals should be, above all else, secure. Each terminal must be impervious to malicious code that could create fraudulent transactions, force the company to take systems offline during a heavy shopping period, or send transactional data to a spying organization. The terminals should also report back vital information on the company's health and allow secure updates to its software remotely. After reviewing many possible solutions during a request for proposal process, Tailwind Traders decides that it needs features that vendors have yet to implement. Instead of using an existing solution, the company decides to work with a leading engineering firm that specializes in IoT solutions. This approach allows the company to build a uniquely secure terminal that gives it a retail platform to build on going forward. Although most of the company's focus is on the terminal itself, Tailwind Traders realizes that it wants a solution that can help it make sense of all the data that will be generated by these terminals across all of its retail stores. And it wants an easy way to push software updates to its terminals. Let's see whether you can decide on the perfect solution. Do you think it is critical to ensure that the device, or in this case, each point-of-sale terminal, is not compromised? Absolutely. Device security is the primary requirement. Does Tailwind Traders need a dashboard for reporting and management? Yes, the company requires a reporting and management dashboard. So given the responses to the decision criteria, the IoT engineering firm will build a platform on top of both Azure IoT Central and Azure Sphere. Even though no specific starter template is available in Azure IoT Central for this scenario, one can easily be adapted to accommodate the kinds of reports the company wants to see and the management operations it wants to perform. By using IoT Central, Tailwind Traders would actually be using IoT Hub behind the scenes as well. Congratulations! You have completed Azure Serverless Technology and IoT. You covered 2 lessons in this module. Let's look back on your journey. You helped Tailwind Traders choose the right serverless computing technology for its business scenarios. When the company needed to build a solution that pulls code logic from an existing C# Windows service, you chose Azure Functions. When the company needed to orchestrate a workflow to improve customer retention after a negative shopping experience, you chose Azure Logic Apps. In both cases, you noted how choosing the other serverless computing service would be possible. However, you tried to help the company consider the decision criteria we outlined and choose the right service for the scenario. Without serverless computing, Tailwind Traders would be forced to set up and manage its own computing infrastructure for these business scenarios. The team would have needed to closely monitor the services to determine whether it needed to scale the service. And it likely would have wasted money in the process, with either too many or too few computing resources dedicated to the solution. Additionally, it might have had to design, write, test, and maintain custom code to get similar results. By helping Tailwind traders select the right serverless computing solutions, you are able to deploy new functionality to help the company improve customer satisfaction with its e-commerce platform. Our goal in this lesson was to help Tailwind traders explore various IoT services from Azure and choose the best service for the company's business scenarios. Tailwind traders was able to capture telemetry data from appliances, combine it with some machine learning to predict future maintenance, and create a significant value-added service for customers by using Azure IoT Hub. The company was able to implement a complete real-time logistics system to track deliveries and vehicles by using Azure IoT Central and the Connected Logistics Starter template. And finally, it was able to design and build a secure, modern, point-of-sale self-checkout terminal by using Azure Sphere. Without Azure IoT services, receiving messages from devices might still be possible, but it would likely be less secure and require custom development to implement a dashboard for reporting and management. It would also be more difficult to push software or firmware updates to each device. IoT is an exciting evolution in computing that bridges the physical and digital worlds. Azure IoT services provide a significant amount of functionality for organizations that want to build device-driven and sensor-driven solutions. Hi, and welcome to this module on general security and network security in Azure. In this module, you'll learn about how Azure can help you protect the workloads that you run in both the cloud and in your on-premises data center. You will also learn about the Azure services you can use to help ensure that your network is safe, secure, and trusted. More specifically, after completing this module, you will know the concepts of how to strengthen your security posture and protect against threats by using Azure Security Center, collect and act on security data from many different sources by using Azure Sentinel, store and access sensitive information such as passwords and encryption keys securely in Azure Key Vault, manage dedicated physical servers to host your Azure VMs for Windows and Linux by using Azure Dedicated Host, identify the layers that make up a defense-in-depth strategy, explain how Azure Firewall enables you to control what traffic is allowed on the network, configure network security groups to filter network traffic to and from Azure resources within a Microsoft Azure virtual network, and explain how Azure DDoS protection helps protect your Azure resources from DDoS attacks. So let's dive right into our case study. To demonstrate this, we are going to use our case study to give you an opportunity to apply the concepts you learn. Tailwind Traders operates retail hardware stores across the globe and online. It specializes in competitive pricing, fast shipping, and a large range of items. It's looking at cloud technologies to improve business operations and support growth into new markets. By moving to the cloud, the company plans to enhance its shopping experience to further differentiate itself from competitors. Tailwind Traders runs a mix of workloads on Azure and in its data center. The company needs to ensure that all of its systems meets a minimum level of security and that its information is protected from attacks. The company also needs a way to collect and act on security events from across its digital estate. Let's explore how Tailwind Traders can use some of the tools and features in Azure as part of its overall security strategy. In this lesson, you'll learn about some of the security tools that can help keep your infrastructure and data safe when you work in the cloud. Security is a small word for a significant concept. There are so many factors to consider in order to protect your applications and your data. How does Azure help you protect workloads that you run in the cloud and in your on-premises data center? After completing this lesson, you'll be able to know the concepts of how to strengthen your security posture and protect against threats by using Azure Security Center, collect and act on security data from many different sources by using Azure Sentinel, store and access sensitive information such as passwords and encryption keys securely in Azure Key Vault, manage dedicated physical servers to host your Azure VMs for Windows and Linux by using Azure Dedicated Host. Tailwind Traders is broadening its use of Azure services. It still has on-premises workloads with current security-related configuration, best practices, and business procedures. How does the company ensure that all of its systems meet a minimum level of security and that its information is protected from attacks. Many Azure services include built-in security features. Tools on Azure can also help Tailwind traders with this requirement. Let's start by looking at Azure Security Center. Azure Security Center is a monitoring service that provides visibility of your security posture across all of your services, both on Azure and on-premises. The term security posture refers to cybersecurity policies and controls, as well as how well you can predict, prevent, and respond to security threats. Security Center can monitor security settings across on-premises and cloud workloads, automatically apply required security settings to new resources as they come online, provide security recommendations that are based on your current configurations, resources, and networks, continuously monitor your resources and perform automatic security assessments to identify potential vulnerabilities before those vulnerabilities can be exploited. Use machine learning to detect and block malware from being installed on your virtual machines and other resources. You can also use adaptive application controls to define rules that list allowed applications to ensure that only applications you allow can run. Detect and analyze potential inbound attacks and investigate threats and any post-breach activity that might have occurred. And provide just-in-time access control for network ports. Doing so reduces your attack surface by ensuring that the network only allows traffic that you require at the time that you need it to. Tailwind traders can use Security Center to get a detailed analysis of different components in its environment. Because the company's resources are analyzed against the security controls of any governance policies it has assigned, it can view its overall regulatory compliance from a security perspective all from one place. Here's an example of what you might see in Azure Security Center. Let's say that Tailwind traders must comply with the Payment Card Industry's Data Security Standard. This report shows that the company has the resources that it needs to remediate. In the Resource Security Hygiene section, Tailwind traders can see the health of its resources from a security perspective. To help prioritize remediation actions, recommendations are categorized as low, medium, and high. Let's now take a look at how SecureScore is implemented. SecureScore is a measurement of an organization's security posture. SecureScore is based on security controls, or groups of related security recommendations. Your score is based on the percentage of security controls that you satisfy. The more security controls you satisfy, the higher the score you receive. Your score improves when you remediate all of the recommendations for a single resource within a control. In this example from the Azure portal, we can see the portal showing a score of 57%, or 34 out of 60 points. Following the SecureScore recommendations can help protect your organization from threats. From a centralized dashboard in Azure Security Center, organizations can monitor and work on the security of their Azure resources like identities, data, apps, devices, and infrastructure. SecureScore helps you report on the current state of your organization's security posture. Improve your security posture by providing discoverability, visibility, guidance, and control. And compare benchmarks and establish key performance indicators. Security Center also includes advanced cloud defense capabilities for virtual machines, network security, and file integrity. Let's take a look at how some of these capabilities apply to Tailwind traders. Just-in-time VM access. Tailwind traders will configure just-in-time access to VMs. This access blocks traffic by default to specific network ports of virtual machines, but allows traffic for a specified time when an administrator requests and approves it. Adaptive application controls. Tailwind traders can control which applications are allowed to run on its virtual machines. In the background, Security Center uses machine learning to look at the processes running on a virtual machine. It creates exception rules for each resource group that holds the virtual machines and provides recommendations. This process provides alerts that inform the company about unauthorized applications that are running on its VMs. Adaptive network hardening. Security Center can monitor the internet traffic patterns of the VMs and compare those patterns with the company's current Network Security Group settings, or NSG settings. From there, Security Center can make recommendations on whether the NSGs should be locked down further and provide remediation steps. File integrity monitoring. Tailwind traders can also configure the monitoring of changes to important files on both Windows and Linux, registry settings, applications, and other aspects that might indicate a security attack. So as you can see, Tailwind traders can use Security Center to get a centralized view of all of its security alerts. From there, the company can dismiss false alerts, investigate them further, remediate alerts manually, or use an automated response with a workflow automation. This workflow automation uses Azure Logic Apps and Security Center connectors. The Logic app can be triggered by a threat detection alert or by a Security Center recommendation, filtered by name or by severity. You can then configure the Logic app to run an action, such as sending an email or posting a message to a Microsoft Teams channel. Security management on a large scale can benefit from a dedicated Security Information and Event Management, or SIEM system. A SIEM system aggregates security data from many different sources, as long as those sources support an open standard logging format. It also provides capabilities for threat detection and response. Azure Sentinel is Microsoft's cloud-based SIEM system. It uses intelligent security analytics and threat analysis. Azure Sentinel enables you to collect cloud data at scale across all users, devices, applications, and infrastructure, both on-premises and from multiple clouds. Detect previously undetected threats while minimizing false positives by using Microsoft's comprehensive analytics and threat intelligence. Investigate threats with artificial intelligence and examine suspicious activities at scale, tapping into years of cybersecurity experience from Microsoft. Respond to incidents rapidly by utilizing built-in orchestration and automation of common tasks. Let's go back to the Tailwind Traders case study. In this instance, Tailwind decides to explore the capabilities of Azure Sentinel. First, the company identifies and connects its data sources. Azure Sentinel supports a number of data sources, which it can analyze for security events. These connections are handled by built-in connectors, or industry-standard log formats and APIs. Connectors provide real-time integration for services like Microsoft Threat Protection Solutions, Microsoft 365 sources including Office 365, Azure Active Directory, and Windows Defender Firewall. Connectors are available for common non-Microsoft services and solutions, including AWS CloudTrail, Citrix Analytics, Sophos XG Firewall, VMware Carbon Black Cloud, and Okta SSO. Azure Sentinel supports data from other sources that use the Common Event Format Messaging Standard, syslog, or REST API. Tailwind Traders needs to be notified when something suspicious occurs. It decides to use both built-in analytics and custom rules to detect threats. Built-in analytics use templates designed by Microsoft's team of security experts and analysts. They are based on known threats, common attack vectors, and escalation chains for suspicious activity. These templates can be customized and search across the environment for any activity that looks suspicious. Some templates use machine learning behavioral analytics that are based on Microsoft proprietary algorithms. Custom analytics are rules that you create to search for specific criteria within your environment. You can preview the number of results that the query would generate based on past log events and set a schedule for the query to run. You can also set an alert threshold. When Azure Sentinel detects suspicious events, Tailwind Traders can investigate specific alerts or incidents. Incidents are a group of related alerts. This is what an investigation graph looks like in Azure Sentinel. With the investigation graph, the company can review information from entities directly connected to the alert and see common exploration queries to help guide the investigation. You can also use Azure Monitor workbooks to automate responses to threats. Workbooks can run manually or automatically when a rule triggers an alert. For example, it can set an alert that looks for malicious IP addresses that access the network and create a workbook that does the following steps. When the alert is triggered, it opens a ticket in the IT ticketing system. Then it sends a message to the Security Operations channel in Microsoft Teams or Slack to make sure the security analysts are aware of the incident. Next, it sends all of the information in the alert to the senior network admin and to the security admin. The email message includes two user option buttons, block or ignore. When an admin chooses block, the IP address is blocked in the firewall and the user is disabled in Azure Active Directory. When an admin chooses Ignore, the alert is closed in Azure Sentinel, and the incident is closed in the IT ticketing system. The workbook continues to run after it receives a response from the admins. Let's take a look at how Azure Key Vault is used to store and manage secrets. Once again, we will use an example from our Tailwind Traders case study. As Tailwind Traders builds its workloads in the cloud, it needs to carefully handle sensitive information such as passwords, encryption keys, and certificates. This information needs to be available for an application to function, but it might allow an unauthorized person access to application data. Azure Key Vault is a centralized cloud service for storing an application's secrets in a single central location. It provides secure access to sensitive information by providing access control and logging capabilities. Now that we know what Azure Key Vault is, let's take a look at what Azure Key Vault can do. Azure Key Vault can help you manage secrets. You can use Key Vault to securely store and tightly control access to tokens, passwords, certificates, API keys, and other secrets. Manage encryption keys. You can use Key Vault as a key management solution. Key Vault makes it easier to create and control the encryption keys that are used to encrypt your data. Manage SSL TLS certificates. Key Vault enables you to provision, manage, and deploy your public and private secure sockets layer, transport layer security, or SSL TLS certificates for both your Azure resources and your internal resources. Store secrets backed by hardware security modules, or HSMs. These secrets and keys can be protected either by software or by FIPS 140-2 Level 2 validated HSMs. Here's an example that shows a certificate used for testing in Key Vault. You'll add a secret to Key Vault later in this module. The benefits of using Key Vault include centralized application secrets. Centralizing the storage for your application secrets enables you to control their distribution and reduces the chances that secrets are accidentally leaked. Securely stored secrets and keys. Azure uses industry-standard algorithms, key lengths, and HSMs. Access to Key Vault requires proper authentication and authorization. Access monitoring and access control. By using Key Vault, you can monitor and control access to your application secrets. Simplified administration of application secrets. Key Vault makes it easier to enroll and renew certificates from Public Certificate Authorities, or CAs. You can also scale up and replicate content within regions and use standard certificate management tools. Integration with other Azure services. You can integrate Key Vault with storage accounts, container registries, event hubs, and many more Azure services. These services can then securely reference the secrets stored in Key Vault. On Azure, VMs run on shared hardware that Microsoft manages. Although the underlying hardware is shared, your VM workloads are isolated from workloads that other Azure customers run. However, some organizations must follow regulatory compliance that requires them to be the only customer using the physical machine that hosts their virtual machines. To facilitate this requirement, Azure Dedicated Host provides dedicated physical servers that will host your Azure VMs for Windows and Linux. Here's a diagram that shows how virtual machines relate to dedicated hosts and host groups. A dedicated host is mapped to a physical server in an Azure data center, and a host group is a collection of dedicated hosts. Now that we know that a dedicated host is mapped to a physical server in an Azure data center, let's take a look at some of the benefits of using Azure Dedicated Host. Azure Dedicated Host gives you visibility into and control over the server infrastructure that's running your Azure VMs. Helps address compliance requirements by deploying your workloads on an isolated server. Lets you choose the number of processors, server capabilities, VM series, and VM sizes within the same host. After a dedicated host is provisioned, Azure assigns it to the physical server in Microsoft's Cloud Data Center. For high availability, you can provision multiple hosts in a host group and deploy your virtual machines across this group. VMs on dedicated hosts can also take advantage of maintenance control. This feature enables you to control when regular maintenance updates occur, within a 35-day rolling window. You're charged per dedicated host, independent of how many virtual machines you deploy to it. The host price is based on the VM family, type or hardware size, and region. Software licensing, storage, and network usage are billed separately from the host and VMs. Congratulations, you have completed this lesson on how to protect against security threats on Azure. You learned how to use Azure Security Center to strengthen your security posture and protect against threats. You learned how to collect and act on security data from many different sources by using Azure Sentinel. We looked at how to store and access sensitive information such as passwords and encryption keys securely in Azure Key Vault. We also covered how you can manage dedicated physical servers to host your Azure VMs for Windows and Linux by using Azure Dedicated Host. Welcome to this lesson on secure network connectivity on Azure. This is an important topic. Every application and service, whether on-premises or in the cloud, needs to be designed with security in mind. There's too much at risk. For example, a denial of service attack might prevent customers from reaching your website or services and block you from doing business. Or your website might be defaced, causing damage to your reputation. A data breach would be even worse, because it can ruin hard-earned trust while causing significant personal and financial harm. Let's go back to our case study on Tailwind Traders, a fictitious home improvement retailer that operates retail hardware stores across the globe and online. Tailwind Traders specializes in competitive pricing, fast shipping, and a large range of items. It's looking at cloud technologies to improve business operations and support growth into new markets. By moving to the cloud, the company plans to enhance its shopping experience to further differentiate itself from competitors. As Tailwind Traders moves to the cloud, it needs to evaluate its security needs before it can deploy a single line of code to production. Although security must be considered at every layer in the company's applications, all the way from the physical servers to the application data, some factors relate specifically to the network configuration and network traffic of cloud-based workloads. In this lesson, you'll focus on the network security capabilities in Azure and review how they help you secure your solutions in the cloud, based on your business needs. After completing this lesson, you'll be able to identify the layers that make up a defense-in-depth strategy, explain how Azure Firewall enables you to control what traffic is allowed on the network, configure network security groups to filter network traffic to and from Azure resources within a Microsoft Azure virtual network, and explain how Azure DDoS protection helps protect your Azure resources from DDoS attacks. Tailwind Traders currently runs its workloads on-premises in its data center. Running on-premises means that the company is responsible for all aspects of security, from physical access to buildings all the way down to how data travels in and out of the network. The company wants to know how its current defense-in-depth strategy compares to running in the cloud. The objective of defense-in-depth is to protect information and prevent it from being stolen by those who aren't authorized to access it. A defense-in-depth strategy uses a series of mechanisms to slow the advance of an attack that aims at acquiring unauthorized access to data. Each layer provides protection so that if one layer is breached, a subsequent layer is already in place to prevent further exposure. This approach removes reliance on any single layer of protection. It slows down an attack and provides alert telemetry that security teams can act upon either automatically or manually. The physical security layer is the first line of defense to protect computing hardware in the data center. The identity and access layer controls access to infrastructure and change control. The perimeter layer uses distributed denial of service protection to filter large-scale attacks before they can cause a denial of service for users. The network layer limits communication between resources through segmentation and access controls. The compute layer secures access to virtual machines. The application layer helps ensure that applications are secure and free of security vulnerabilities. And the data layer controls access to business and customer data that you need to protect. These layers provide a guideline for you to help make security configuration decisions in all of the layers of your applications. Azure provides security tools and features at every level of the defense-in-depth concept. Let's take a closer look at each layer. Physically securing access to buildings and controlling access to computing hardware within the data center are the first line of defense. With physical security, the intent is to provide physical safeguards against access to assets. These safeguards ensure that other layers can't be bypassed and loss or theft is handled appropriately. Microsoft uses various physical security mechanisms in its cloud data centers. At the identity and access layer, it's important to control access to infrastructure and change control. Use single sign-on and multi-factor authentication, and audit events and changes. The identity and access layer is all about ensuring that identities are secure. Access is granted only to what's needed, and sign-in events and changes are logged. We will cover identity and access in detail in another module. At the perimeter layer, it's important to use DDoS protection to filter large-scale attacks before they can affect the availability of a system for users. Use perimeter firewalls to identify and alert on malicious attacks against your network. At the network perimeter, it's about protecting from network-based attacks against your resources. Identifying these attacks, eliminating their impact, and alerting you when they happen are important ways to keep your network secure. At the network layer, it's important to limit communication between resources, deny by default, restrict inbound internet access and limit outbound access where appropriate, and implement secure connectivity to on-premises networks. At this layer, the focus is on limiting the network connectivity across all your resources to allow only what's required. By limiting this communication, you reduce the risk of an attack spreading to other systems in your network. At the compute layer, it's important to secure access to virtual machines and implement endpoint protection on devices and keep systems patched and current. Malware, unpatched systems, and improperly secured systems open your environment to attacks. The focus in this layer is on making sure that your compute resources are secure and that you have the proper controls in place to minimize security issues. At application layer, it's important to ensure that applications are secure and free of vulnerabilities. Store sensitive application secrets in a secure storage medium. Make security a design requirement for all application development. Integrating security into the application development lifecycle helps reduce the number of vulnerabilities introduced in code. Every development team should ensure that its applications are secure by default. In almost all cases, attackers are after data, stored in a database, stored on disk inside virtual machines, stored in software as a service applications such as Office 365, and managed through cloud storage. Those who store and control access to data are responsible for ensuring that it's properly secured. Often, regulatory requirements dictate the controls and processes that must be in place to ensure the confidentiality, integrity, and availability of the data. We will cover privacy, compliance, and data protection standards on Azure in detail in another module. Your security posture is your organization's ability to protect from and respond to security threats. The common principles used to define a security posture are confidentiality, integrity, and availability, known collectively as CIA. Confidentiality uses the principle of least privilege, which means restricting access to information only to individuals explicitly granted access, at only the level that they need to perform their work. This information includes protection of user passwords, email content, and access levels to applications and underlying infrastructure. Integrity prevents unauthorized changes to information, at rest when it's stored, and in transit when it's being transferred from one place to another, including from a local computer to the cloud. A common approach used in data transmission is for the sender to create a unique fingerprint of the data by using a one-way hashing algorithm. The hash is sent to the receiver along with the data. The receiver recalculates the data's hash and compares it to the original to ensure that the data wasn't lost or modified in transit. And availability ensures that services are functioning and can be accessed only by authorized users. Denial of service attacks are designed to degrade the availability of a system, affecting its users. A firewall is a network security device that monitors incoming and outgoing network traffic and decides whether to allow or block specific traffic based on a defined set of security rules. You can create firewall rules that specify ranges of IP addresses. Only clients granted IP addresses from within those ranges are allowed to access the destination server. Firewall rules can also include specific network protocol and port information. Tailwind Traders currently runs firewall appliances, which combine hardware and software to protect its on-premises network. These firewall appliances require a monthly licensing fee to operate, and they require IT staff to perform routine maintenance. As Tailwind Traders moves to the cloud, the IT manager wants to know what Azure services can protect both the company's cloud networks and its on-premises networks. Azure Firewall is a managed cloud-based network security service that helps protect resources in your Azure virtual networks. A virtual network is similar to a traditional network that you'd operate in your own data center. It's a fundamental building block for your private network that enables virtual machines and other compute resources to securely communicate with each other, the internet and on-premises networks. This diagram shows a basic Azure Firewall implementation. Azure Firewall is a stateful firewall. A stateful firewall analyzes the complete context of a network connection, not just an individual packet of network traffic. Azure Firewall features high availability and unrestricted cloud scalability. Azure Firewall provides a central location to create, enforce, and log application and network connectivity policies across subscriptions and virtual networks. It uses a static, unchanging public IP address for your virtual network resources, which enables outside firewalls to identify traffic coming from your virtual network. The service is integrated with Azure Monitor to enable logging and analytics. Azure Firewall provides many features, including built-in high availability, unrestricted cloud scalability, inbound and outbound filtering rules, inbound destination network address translation, or DNAT, support, and Azure Monitor logging. You typically deploy Azure Firewall on a central virtual network to control general network access. With Azure Firewall, you can configure application rules that define fully qualified domain names, or FQDNs, that can be accessed from a subnet. Network rules that define source address, protocol, destination port, and destination address. Network address translation, also known as NAT, rules that define destination IP addresses and ports to translate inbound requests. Azure Application Gateway also provides a firewall that's called the Web Application Firewall, or WAF. WAF provides centralized inbound protection for your web applications against common exploits and vulnerabilities. Azure Front Door and Azure Content Delivery Network, or CDN, also provides WAF services. Any large company can be the target of a large-scale network attack. Attackers might flood your network to make a statement or simply for the challenge. Tailwind Traders is no exception. As Tailwind Traders moves to the cloud, it wants to understand how Azure can prevent DDoS and other attacks. Now you'll learn how Azure DDoS Protection Standard Service Tier helps protect your Azure resources from DDoS attacks. First, let's define what a DDoS attack is. A DDoS attack attempts to overwhelm and exhaust an application's resources, making the application slow or unresponsive to legitimate users. DDoS attacks can target any resource that's publicly reachable through the internet, including websites. Azure DDoS Protection Standard helps protect your Azure resources from DDoS attacks. When you combine DDoS protection with recommended application design practices, you help provide a defense against DDoS attacks. DDoS protection uses the scale and elasticity of Microsoft's global network to bring DDoS mitigation capacity to every Azure region. The DDoS Protection Service helps protect your Azure applications by analyzing and discarding DDoS traffic at the Azure network edge before it can affect your service's availability. This diagram shows network traffic flowing into Azure from both customers and an attacker. DDoS protection identifies the attacker's attempt to overwhelm the network and blocks further traffic from them, ensuring that traffic never reaches Azure resources. Legitimate traffic from customers still flows into Azure without any interruption of service. DDoS protection can also help you manage your cloud consumption. When you run on-premises, you have a fixed number of compute resources. But in the cloud, elastic computing means that you can automatically scale out your deployment to meet demand. A cleverly designed DDoS attack can cause you to increase your resource allocation, which incurs unneeded expense. DDoS Protection Standard helps ensure that the network load you process reflects customer usage. You can also receive credit for any costs accrued for scaled-out resources during a DDoS attack. There are several service tiers available to DDoS protection. The basic service tier is automatically enabled for free as part of your Azure subscription. It ensures that Azure infrastructure itself is not affected during a large-scale DDoS attack. The standard service tier provides additional mitigation capabilities that are tuned specifically to Azure Virtual Network resources. DDoS Protection Standard is relatively easy to enable and requires no changes to your applications. Protection policies are tuned through dedicated traffic monitoring and machine learning algorithms. Policies are applied to public IP addresses, which are associated with resources deployed in virtual networks such as Azure Load Balancer and Application Gateway. Both the basic and standard tiers provide always-on traffic monitoring and real-time mitigation of common network-level attacks. They provide the same defenses that Microsoft's online services use. The Azure Global Network is used to distribute and mitigate attack traffic across Azure regions. The standard service tier can help prevent volumetric attacks where the goal of this attack is to flood the network layer with a substantial amount of seemingly legitimate traffic. Protocol attacks, which render a target inaccessible by exploiting a weakness in the Layer 3 and Layer 4 protocol stack. And resource layer or application layer attacks, which is provided only with Web Application Firewall. These attacks target web application packets to disrupt the transmission of data between the hosts. You need a WAF to protect against Layer 7 attacks. DDoS Protection Standard protects the WAF from volumetric and protocol attacks. Although Azure Firewall and Azure DDoS Protection can help control what traffic can come from outside sources, Tailwind Traders also wants to understand how to protect its internal networks on Azure. Doing so will give the company an extra layer of defense against attacks. Now, you will examine network security groups or NSGs. A network security group enables you to filter network traffic to and from Azure resources within an Azure virtual network. You can think of NSGs like an internal firewall. An NSG can contain multiple inbound and outbound security rules that enable you to filter traffic to and from resources by source and destination IP address, port and protocol. A network security group can contain as many rules as you need within Azure subscription limits. When you create a network security group, Azure creates a series of default rules to provide a baseline level of security. You can't remove the default rules, but you can override them by creating new rules with higher priorities. Each rule specifies the properties you can see in the table on screen. When you're considering an Azure security solution, consider all the elements of defense in depth. Next, we will present some recommendations on how to combine Azure services to create a complete network security solution. The perimeter layer is about protecting your organization's resources from network-based attacks. Identifying these attacks, alerting the appropriate security teams, and eliminating their impact are important to keeping your network secure. To do this, you can use Azure DDoS Protection to filter large-scale attacks before they can cause a denial of service for users, and use perimeter firewalls with Azure Firewall to identify and alert on malicious attacks against your network. At this layer, the focus is on limiting network connectivity across all of your resources to allow only what's required. Segment your resources and use network-level controls to restrict communications to only what's needed. By restricting connectivity, you reduce the risk of lateral movement throughout your network from an attack. Use network security groups to create rules that define allowed inbound and outbound communication at this layer. The recommended practices for securing the network layer are to limit communication between resources by segmenting your network and configuring access controls. Deny by default, restrict inbound internet access and limit outbound where appropriate, and implement secure connectivity to on-premises networks. You can combine Azure networking and security services to manage your network security and provide increased layered protection. Here are two ways you can combine services. Azure Firewall complements the functionality of network security groups. Together, they provide better defense-in-depth network security. Network security groups provide distributed network layer traffic filtering to limit traffic to resources within virtual networks in each subscription. Azure Firewall is a fully stateful, centralized network firewall as a service. It provides network-level and application-level protection across different subscriptions and virtual networks. You can also combine Azure Application Gateway Web Application Firewall and Azure Firewall. WAF is a feature of Azure Application Gateway that provides your web applications with centralized inbound protection against common exploits and vulnerabilities. Azure Firewall provides inbound protection for non-HTTPS protocols, for example, RDP, SSH, and FTP. Outbound network-level protection for all ports and protocols. And application-level protection for outbound HTTPS. Combining them provides more layers of protection. Tailwind Traders faces a number of security challenges. In today's digital world, its needs aren't unique. Azure provides tools and services that can help you detect and act on important security events. It also provides ways to help keep your data safe, which can prevent security incidents from happening to begin with. In the first lesson, you learned about Azure services that relate to security. Azure Security Center provides visibility of your security posture across all of your services, both on Azure and on-premises. Azure Sentinel aggregates security data from many different sources and provides additional capabilities for threat detection and response. Azure Key Vault stores your application secrets, such as passwords, encryption keys, and certificates, in a single central location. And Azure Dedicated Host provides dedicated physical servers to host your Azure VMs for Windows and Linux. In the second lesson, you learned about some of the ways you can secure network traffic both on Azure and in your on-premises data center. We covered an important topic, defense in depth. Defense in depth helps us think about security as a multiple layer, multiple vector concern. Threats come from places we don't expect, and they can come with surprising strength. Tailwind Traders now has a few tools and services that it can use to secure its networks. Azure Firewall is a managed cloud-based network security service that helps protect resources in Azure virtual networks. An Azure virtual network is similar to a traditional network that you'd operate in your own data center. It enables virtual machines and other compute resources to securely communicate with each other, the internet, and on-premises networks. A network security group enables you to filter network traffic to and from Azure resources within a virtual network. And Azure DDoS protection helps protect Azure resources from DDoS attacks. Congratulations! You have completed the Azure Management Tools and Security Solutions course. Management tools encompass a wide array of tools and services from Microsoft Azure. In this course, you have looked at many of these tools and services and chose the best one for a given business scenario. You have also examined the various Azure services you can use to help ensure that your cloud resources are safe, secure, and trusted. At this point, you should be able to choose the correct Azure Artificial Intelligence service to address different kinds of business challenges, the best software development process tools and services for a given business scenario, the correct cloud monitoring service and management tool to address different kinds of technical needs and challenges, the right serverless computing technology for your business scenario, and the best Azure IoT service for a given business scenario. You should also be able to strengthen your security posture and protect against threats by using Azure Security Center. Collect and act on security data from many different sources by using Azure Sentinel. Store and access sensitive information such as passwords and encryption keys securely in Azure Key Vault. Manage dedicated physical servers to host your Azure VMs for Windows and Linux by using Azure Dedicated Host. And secure network connectivity on Azure. Demonstrating knowledge of these topics is a requirement in the AZ900 Microsoft Azure Fundamentals exam. You are one step further down the road to certification. The next course will cover identity, governance, privacy, and compliance features on Azure. It will be the next step in further preparing for the AZ900 so you can pursue a career using Microsoft Azure. Make sure to check the reading material that follows for more information on what's to come in the next course.
Hello, and welcome to Azure Services and Lifecycles. This course aims to help you learn more about Azure and prepares you for the Azure 900 exam. Understanding who is using your systems and what they have permission to do is critical to keeping your data safe from attackers. To stay organized, manage costs, and meet your compliance goals, you need a good cloud governance strategy. In this course, you will learn how Azure can help you secure access to cloud resources, what it means to build a cloud governance strategy, and how Azure adheres to common regulatory and compliance standards. This course will also guide you further down the path of becoming AZ900 Microsoft Azure Fundamentals certified. Acquiring the Azure Fundamental certification is also an opportunity for you to prove your knowledge of cloud concepts and Azure's main features. For this course, it will include Azure Identity Services, Cloud Governance Strategy, Privacy, Compliance, and Data Protection Standards, and finally, Costs and SLA Service Cycles. To get the most out of this course, it helps if you are familiar with the general technology concepts, including concepts of networking, storage, compute, application support, and application development. In terms of your Azure Fundamentals exam, up to 40% of your exam content will be covered in this course. 20 to 25% of the exam will focus on identity, governance, privacy, and compliance features, while the remaining 10 to 15% will focus on cost management and service level agreements. A successful completion of this course will set you well on the way to obtaining the AZ900 Azure Fundamentals certification. Microsoft certifications provide globally recognized and industry-endorsed evidence of mastering technical skills. Microsoft certification provides you with a pathway to upgrade your skills, validate your abilities, enhance your professional performance, and develop your career. Microsoft certifications validate your skills and capabilities and leads you to success. Achieving certification shows employers that you have drive and initiative. If you get hired in a new role or promoted or change your career, your certification speaks volumes about you and what you know. Perhaps you are already in an IT support role and your team needs your guidance or opinion. You will definitely be able to respond with confidence once you have successfully completed this program. Stay ahead, get hired, and receive the recognition you deserve. In this course, you will explore various modules relating to Azure management tools and security solutions. You'll start off with Azure Identity Services. Next, you will work through the process of how to build a cloud governance strategy on Azure. As you dive deeper, you'll explore privacy, compliance, and data protection standards on Azure. Finally, you will look at how Azure can help you by managing costs and SLA service cycles. Throughout this course, you will have an opportunity to get hands-on experience with Azure through interactive exercises, practice quizzes, and practice exams. The interactive exercises offer opportunities to practice and implement what you're learning. As an example, you will protect a storage account from accidental deletion by using a resource lock from the Azure portal. The beauty about this is that you will be working with real technology, but in a controlled environment, which allows you to apply what you learn and at your own pace. Bear in mind that you will need to have a Microsoft account in order to access the Azure portal. As you explore the concepts and services that are available through Azure, you'll be given a case study to apply what you're learning to real-world examples. In the case study, you'll assume the role of an IT specialist and address the technology challenges of tailwind traders so that you can help them conduct business more efficiently. Using real-world examples helps to reinforce concepts, prepare you for the exam, and gives you confidence in your approach. Now that you have a good idea of what you'll cover in this course, in the following reading, you can review what you'll learn throughout the modules in more detail. Good luck. Hello, and welcome to this lesson on Azure Identity Services. In this lesson, you'll learn about Azure Identity and Services with focus on identity and access management. With people increasingly able to work from anywhere, plus the rise of bring your own device strategies, mobile applications, and cloud applications, many of those access points are now outside the company's physical networks. Identity has become the new primary security boundary, accurately proving that someone is a valid user of your system with an appropriate level of access is critical to maintaining control of your data. This identity layer is now more often the target of attack than the network is. To demonstrate this, we are going to use our case study to give you an opportunity to apply the concepts that you'll learn. The mobile workforce of tailwind traders is increasing, as are the number of applications that the company runs in the cloud. As a result, retail employees located around the world are issued tablet devices from which they can create orders for customers, track delivery schedules, and plan their work schedules. Delivery drivers can use their own mobile devices to access scheduling and logistics applications. Some delivery drivers are permanent employees of Tailwind Traders, and others work on short-term contracts. Currently, Tailwind Traders uses Active Directory to secure its on-premises environment. It needs to ensure that only employees can sign in and access the company's business applications. It also needs to ensure that short-term staff can access these applications only when they're under active contract. In this module, you will learn how Azure Active Directory, or Azure AD, can also help Tailwind Traders consistently secure all of its applications accessed from the intranet and from public networks. Be mindful not to confuse Active Directory with Azure Active Directory. The first is primarily associated with securing on-premises applications, while the latter is associated with securing them in the cloud. Later in this module, you will look at how Tailwind Traders can use Azure Active Directory to consistently secure all of their applications accessed from the intranet and from public networks. After completing this module, you'll be able to explain the difference between authentication and authorization, describe Azure Active Directory and how it provides identity and access management, explain the role that single sign-on, commonly known as SSO, multi-factor authentication, and conditional access play in managing user identity. Let's take a look at Tailwind Traders again. Recall that they must ensure that only employees can sign in and access its business applications. Tailwind Traders also needs to ensure that employees can access only authorized applications. For example, all employees can access inventory and pricing software, but only store managers can access payroll and certain accounting software. In order to achieve this, let's examine two fundamental concepts that you need to understand when talking about identity and access. These are authentication, which is sometimes referred to as auth-n, and authorization, which is sometimes referred to as auth-z. Authentication and authorization both support everything else that happens, and they occur sequentially in the identity and access process. Let's now take a brief look at each. Authentication is the process of establishing the identity of a person or service that wants to access a resource. It involves a process of call and response where the end user or service is challenged for a set of credentials. These credentials are then used as the basis to create a security principle, and this security principle is used to establish the user's identity and access control. You can think of this as the digital version of a person showing an identity card to a doorman prior to being granted access to an office building. By using authentication, you can establish whether the user is who they say they are. While authentication establishes the user's identity, authorization is the process of establishing what level of access an authenticated person or service has. It specifies what data they're allowed to access and what they can do with it. Once again, let's look at our doorman example. Once you show your identity card to the doorman and you have been successfully identified, the doorman may only allow you to access one room in the building based on the information on your identity card. This process of access based on identity credentials is authorization. Therefore, in summary, authentication is the process of proving who you are, while authorization defines what you are allowed to do. Let's look at a practical example now. Here, the identification card represents credentials that the user has to prove their identity. You'll learn more about the types of credentials later in this module. Once authenticated, authorization defines what kinds of applications, resources, and data the user can access. Let's take a look at what is Azure Active Directory, or Azure AD, and how it provides identity services that enable your users to sign in and access both Microsoft Cloud applications and cloud applications that you develop. We will also explore the functionality and usage of Azure Active Directory. Azure Active Directory is Microsoft's cloud-based identity and access management service. Azure AD enables an organization's employees to sign in and access both internal and external resources while also keeping them secure. In doing so, users can sign in and access external resources such as Microsoft 365, the Azure portal, and thousands of other software as a service or SaaS applications. internal resources, such as apps on the organization's corporate network and intranet, along with any cloud apps developed by the organization. Tailwind Traders already uses Active Directory to secure its on-premises environment, but they don't want users to have a different username and password to remember for accessing applications and data in the cloud. They also need to ensure that only employees can sign in and access the company's business applications. Additionally, application access must be available for any short-term staff, but only when they're under an active contract. Let's explore how Azure Active Directory can help Tailwind Traders consistently secure all of its applications accessed from the intranet and from public networks. Active Directory is related to Azure AD, but they have some key differences. Microsoft introduced Active Directory in Windows 2000 to give organizations the ability to manage multiple on-premises infrastructure components and systems by using a single identity per user. For on-premises environments, Active Directory running on Windows Server provides an identity and access management service that's managed by your own organization. Azure AD is Microsoft's cloud-based identity and access management service. With Azure AD, you control the identity accounts, but Microsoft ensures that the service is available globally. If you've worked with Active Directory, Azure AD would be familiar to you. When you secure identities on premises with Active Directory, Microsoft doesn't monitor sign-in attempts. When you connect Active Directory with Azure AD, Microsoft can help protect you by detecting suspicious sign-in attempts at no extra cost. For example, Azure AD can detect sign-in attempts from unexpected locations or unknown devices. Azure Active Directory is used by a variety of end users. Let's take a look at some of them now. IT administrators can use Azure AD to control access to applications and resources based on their business requirements. App developers can use Azure AD to provide a standards-based approach for adding functionality to applications that they build, such as adding single sign-on functionality to an app or enabling an app to work with a user's existing credentials. End users can manage their identities. For example, self-service password reset enables users to change or reset their password with no involvement from an IT administrator or help desk. If you are a Microsoft 365, Microsoft Office 365, Azure, or Microsoft Dynamics CRM online subscriber, then you are already using Azure AD. Here's an example of what an IT administrator might see in the Azure portal when working with Active Directory. Sometimes you may hear the term tenant. A tenant represents an organization in Azure Active Directory. It's a dedicated Azure AD instance that an organization receives and owns when it signs up for a Microsoft cloud service such as Azure, Microsoft Intune, or Microsoft 365. You can think of a tenant as an instance of your organization with isolated data which is separated from other tenants or organizations. Each Microsoft 365, Office 365, Azure, and Dynamics CRM Online tenant is automatically an Azure AD tenant. Now, let's explore the main services provided by Azure AD. Azure AD provides services such as authentication, which includes verifying identity to access applications and resources. It also includes providing functionality such as self-service password reset, multi-factor authentication, a custom list of banned passwords, and smart lockout services. Single sign-on, or SSO, which enables you to remember only one username and one password to access multiple applications. A single identity is tied to a user, which simplifies the security model. As users change roles or leave an organization, access modifications are tied to that identity, which greatly reduces the effort needed to change or disable accounts. You can manage your cloud and on-premises apps by using Azure AD. Features like Application Proxy, SaaS apps, the My Apps portal, also called the Access Panel, and Single Sign-On provide a better user experience. Along with accounts for individual people, Azure AD supports the registration of devices. Registration enables devices to be managed through tools like Microsoft Intune. It also allows for device-based conditional access policies to restrict access attempts to only those coming from known devices, regardless of the requesting user account. Connecting Active Directory with Azure AD enables you to provide a consistent identity experience to your users. There are a few ways to connect your existing Active Directory installation with Azure AD. Perhaps the most popular method is to use Azure AD Connect. Azure AD Connect synchronizes user identities between on-premises Active Directory and Azure AD. Azure AD Connect also synchronizes changes between both identity systems, so you can use features like SSO, multi-factor authentication, and self-service password reset under both systems. The self-service password reset is important as it prevents users from using known compromised passwords. Here's a diagram that shows how Azure AD Connect fits between on-premises Active Directory and Azure AD. As Tailwind Traders integrates its existing Active Directory instance with Azure AD, it creates a consistent access model across its organization. Doing so greatly simplifies its ability to sign in to different applications, manage changes to user identities and control, and monitor and block unusual access attempts. This connection is made possible by using Azure AD Connect. Let's take a closer look at single sign-on now. Single sign-on enables a user to sign in one time and use that credential to access multiple resources and applications from different providers. This is important as organizations need a robust identity and access management strategy that can handle the challenges of securing user and data access from the cloud. More identities mean more passwords to remember and change. Password policies can vary among applications. As complexity requirements increase, it becomes increasingly difficult for users to remember them. The more passwords a user has to manage, the greater the risk of a credential-related security incident. Consider the process of managing all those identities. Additional strain is placed on help desks as they deal with account lockouts and password reset requests. If a user leaves an organization, tracking down all those identities and ensuring they are disabled can be challenging. If an identity is overlooked, this might allow access when it should have been eliminated. With SSO, you need to remember only one ID and one password. Access across applications is granted to a single identity that's tied to the user, which simplifies the security model. As users change roles or leave an organization, access is tied to a single identity. This change greatly reduces the effort needed to change or disable accounts. Using SSO for accounts makes it easier for users to manage their identities and increases your security capabilities. You'll find resources at the end of this module about how to enable SSO through Azure AD. Let's take a look at the features of multi-factor authentication and conditional access now. But before we do, let's give it some context in relation to our case study on Tailwind Traders. Tailwind Traders allows delivery drivers to use their own mobile devices to access scheduling and logistics applications. Some delivery drivers are permanent employees of Tailwind Traders. Others work on short-term contract. How can the IT department ensure that an access attempt is really from a valid Tailwind Traders worker? In this part, you'll learn about two processes that enable secure authentication: Azure AD multi-factor authentication and conditional access. Let's start with a brief look at what multi-factor authentication is in general. Multi-factor authentication is a process where a user is prompted during the sign-in process for an additional form of identification. Examples include a code on their mobile phone or a fingerprint scan. Think about how you sign into websites, email, or online gaming services. In addition to your username and password, have you ever needed to enter a code that was sent to your phone? If so, you've used multi-factor authentication to sign in. Multi-factor authentication is important as it provides an additional level of security for your identities by requiring two or more elements to fully authenticate. These elements fall into three categories. Something the user knows. This might be an email address and password. Something the user has. This might be a code that's sent to the user's mobile phone. Something the user is. This is typically some sort of biometric property, such as a fingerprint or face scan that's used on many mobile devices. Azure AD Multi-Factor Authentication, or MFA, is a Microsoft service that provides multi-factor authentication capabilities. Azure AD MFA enables users to choose an additional form of authentication during sign-in, such as a phone call or mobile app notification. The following services provide Azure AD multi-factor authentication capabilities: The Azure Active Directory Free Edition enables Azure AD multi-factor authentication for administrators with a global admin level of access via the Microsoft Authenticator app, phone call, or SMS code. You can also enforce Azure AD multi-factor authentication for all users via the Microsoft Authenticator app only by enabling security defaults in your Azure AD tenant. Azure Active Directory Premium, P1 or P2 licenses allows for comprehensive and granular configuration of Azure AD multi-factor authentication through conditional access policies, explained shortly. A subset of Azure AD multi-factor authentication capabilities is part of your Office 365 subscription. For more information on licenses and Azure AD multi-factor authentication capabilities, see available versions of Azure AD multi-factor authentication. Conditional access is a tool that Azure Active Directory uses to allow or deny access to resources based on identity signals. These signals include who the user is, where the user is, and what device the user is requesting access from. Conditional access helps IT administrators empower users to be productive wherever and whenever and protect the organization's assets. Conditional access also provides a more granular multi-factor authentication experience for users. For example, a user might not be challenged for a second authentication factor if they're at a known location. However, they might be challenged for a second authentication factor if their sign-in signals are unusual or they're at an unexpected location. During sign-in, conditional access collects signals from the user, makes decisions based on those signals, and then enforces that decision by allowing or denying the access request or challenging for a multi-factor authentication response. Here, the signal might be the user's location, the user's device, or the application that the user is trying to access. Based on these signals, the decision might be to allow full access if the user is signing in from their usual location. If the user is signing in from an unusual location or a location that's marked as high risk, then access might be blocked entirely or possibly granted after the user provides a second form of authentication. Enforcement is the action that carries out the decision. For example, the action is to allow access or require the user to provide a second form of authentication. Conditional access is useful when you require multi-factor authentication to access an application. You can configure whether all users require multi-factor authentication or only certain users, such as administrators. You can also configure whether multi-factor authentication applies to access from all networks or only untrusted networks. Require access to services only through approved client applications. For example, you might want to allow users to access Office 365 services from a mobile device as long as they use approved client apps, like the Outlook mobile app. Require users to access your application only from managed devices. A managed device is a device that meets your standards for security and compliance. Block access from untrusted sources, such as access from unknown or unexpected locations. As we've learned, conditional access is a capability of Azure Active Directory that enables you to control how authorized users access your cloud apps. How do you know what to expect from the conditional access policies in your environment? To answer this question, you can use the Conditional Access What If tool. The Conditional Access What If policy tool allows you to understand the impact of your conditional access policies on your environment. You can use this tool to model your proposed conditional access policies across recent sign-in attempts from your users to see what the impact would have been if those policies had been enabled. The What If tool enables you to test your proposed conditional access policies before you implement them. To use conditional access, you need an Azure AD Premium P1 or P2 license. If you have a Microsoft 365 Business Premium license, you also have access to conditional access features. Congratulations! You have completed this lesson on Azure Identity Services. You now should be able to explain the difference between authentication and authorization and how Azure Active Directory provides identity and access management to cloud-based applications. We explored how this is achieved using concepts such as single sign-on, or SSO, multi-factor authentication, and conditional access. Hello, and welcome to Cloud Governance Strategy. In this module, you'll learn about access policies, resource locks, and tags. You will be introduced to Azure services such as Azure Policy and Azure Blueprints. Then you will look at how they can help you build a comprehensive cloud governance strategy. The term governance describes the general process of establishing rules and policies and ensuring that those rules and policies are enforced. When running in the cloud, a good governance strategy helps you maintain control over the applications and resources that you manage in the cloud. Maintaining control over your environment ensures that you stay compliant with industry standards, like the Payment Card Industry Data Security Standard, PCI DSS, and corporate or organizational standards, such as ensuring that network data is encrypted. Governance can be beneficial to organizations in a wide range of areas, such as multiple engineering teams working in Azure, multiple subscriptions to manage, regulatory requirements that must be enforced, and standards that must be followed for all cloud resources. In this module, you'll help Tailwind traders explore ways they can enforce standards while still enabling teams to create and manage the cloud resources they need. Tailwind Traders is continuing its migration to the cloud. Its existing data center, development, and test teams must submit support tickets to request access to virtual machines, storage, and networking components. It can take IT staff anywhere from 2 weeks to 2 months to purchase, provision, and configure these components. By working in the cloud, you essentially have immediate access to compute, storage, and networking components. Many kinds of groups and users, including people from development, test, operations, and security teams, can potentially have direct access to cloud resources. Going forward, Tailwind traders could enforce similar processes that prevent teams from directly creating or configuring resources on Azure, similar to its existing approach where central IT provisions infrastructure. But the company knows that these restrictions reduce team agility and the ability to innovate. The question is, how can they enable innovation while still maintaining control? After completing this module, you will be able to make organizational decisions about your cloud environment by using the Cloud Adoption Framework for Azure. Define who can access cloud resources by using Azure role-based access control. Apply a resource lock to prevent accidental deletion of your Azure resources. Apply tags to your Azure resources to help describe their purpose. Control and audit how your resources are created by using Azure Policy, and enable governance at scale across multiple Azure subscriptions by using Azure Blueprints. Tailwind Traders needs to control its cloud environment so that it complies with several industry standards, but it's not sure where to start. It has existing business requirements, and it understands how these requirements relate to its on-premises workloads. These requirements also must be met by any workloads it runs in the cloud. You've been tasked with investigating what's available on Azure and to define and implement the governance strategy for Tailwind traders. You decide to start with the Cloud Adoption Framework. The Cloud Adoption Framework for Azure provides you with proven guidance to help with your cloud adoption journey. It helps you create and implement the business and technology strategies needed to succeed in the cloud. The Cloud Adoption Framework consists of tools, documentation, and proven practices which can help you create and implement the business and technology strategies needed to succeed in the cloud. The Cloud Adoption Framework includes these stages: define your strategy, make a plan, ready your organization, adopt the cloud, and govern and manage your cloud environments. To help build your adoption strategy, the Cloud Adoption Framework breaks out each stage into further exercises and steps. Let's take a brief look at each stage. In the first stage, you define your strategy. Using the Cloud Adoption Framework, which includes tools, documentation, and proven practices, you answer questions such as why you're moving to the cloud and what you want to get out of cloud migration. Do you need to scale to meet demand or reach new markets? Will it reduce costs or increase business agility? Let's take a look at the steps in this stage. Define and document your motivations. Meeting with stakeholders and leadership can help you answer why you're moving to the cloud. Document business outcomes. Meet with leadership from your finance, marketing, sales, and human resource groups to help you document your goals. Develop a business case. Validate that moving to the cloud gives you the right return on investment, ROI, for your efforts. And choose the right first project. Choose a project that's achievable, but also shows progress toward your cloud migration goals. In the second stage, you build a plan that maps your aspirational goals to specific actions. A good plan helps ensure that your efforts map to the desired business outcomes. Let's walk through the steps in this stage. First, digital estate. This is when you create an inventory of the existing digital assets and workloads that you plan to migrate to the cloud. Second, initial organizational alignment. In this step, you ensure that the right people are involved in your migration efforts, both from a technical standpoint as well as from a cloud governance standpoint. Third, skills readiness plan. Here, you build a plan that helps individuals build the skills they need to operate in the cloud. Last, cloud adoption plan. In this final step, you build a comprehensive plan that brings together the development, operations, and business teams toward a shared cloud adoption goal. In the third stage, you get your organization ready by creating a landing zone. A landing zone is an environment in the cloud that helps you begin hosting your workloads. Review the Azure Setup Guide to become familiar with the tools and approaches you need to use to create a landing zone. Begin to build out the Azure subscriptions that support each of the major areas of your business. A landing zone includes cloud infrastructure, as well as governance, accounting, and security capabilities. Refine your landing zone to ensure that it meets your operations, governance, and security needs. And start with recommended and proven practices to help ensure that your cloud migration efforts are scalable and maintainable. In the fourth stage, you begin to migrate your applications to the cloud. Along the way, you might find ways to modernize your applications and build innovative solutions that use cloud services. Let's take a look at the steps in the migrate phase of the adopt stage. Use the Azure Migration Guide to deploy your first project to the cloud. Use additional in-depth guides to explore more complex migration scenarios. Check in with the Azure Cloud Migration Best Practices Checklist to verify that you're following recommended practices, and identify ways to make the migration process scale while requiring less effort. Now for the steps in the innovate phase of this stage. Establish business value consensus by verifying that investments in new innovations add value to the business and meet customer needs. Use Azure Innovation Guide to accelerate development and build a minimum viable product, MVP, for your idea. Verify that your progress maps to recommended best practices before you move forward. And create feedback loops by checking in frequently with your customers to verify that you're building what they need. In the final stages, you begin to form your cloud governance and cloud management strategies. As the cloud estate changes over time, so too will your cloud governance processes and policies. You need to create resilient solutions that are constantly optimized. Let's look at the steps in the govern phase of this stage. Consider your end state solution. Then define a methodology that incrementally takes you from your first steps all the way to full cloud governance. Use the governance benchmark tool to assess your current state and future state to establish a vision for applying the framework. Create a minimally viable product that captures the first steps of your governance plan. And iteratively add governance controls that address tangible risks as you progress towards your end state solution. Now for the steps in the manage phase of this stage. It is here that you define your minimum commitment to operations management. A management baseline is the minimum set of tools and processes that should be applied to every asset in an environment. Document supported workloads to establish operational commitments with the business and agree on cloud management investments for each workload. Apply recommended best practices to iterate on your initial management baseline. And for workloads that require a higher level of business commitment, perform a deeper architecture review to deliver on your resiliency and reliability commitments. There's no single cloud adoption path that works for every organization, but the main implementation stages are similar for all organizations and industries. Define your strategy, make a plan, ready your organization, adopt the cloud, and govern and manage your digital estate. In the first course in this series, you learned that the hierarchical structure for an organization's resources in Azure has 4 levels: resources, resource groups, subscriptions, and management groups. Let's take a brief look at each of these levels. Resources are instances of services that you create, like virtual machines, storage, or SQL databases. Resources are combined into resource groups, which act as a logical container into which Azure resources like web apps, databases, and storage accounts are deployed and managed. A subscription groups together user accounts and the resources that have been created by those user accounts. For each subscription, there are limits or quotas on the amount of resources that you can create and use. Organizations can use subscriptions to manage costs and the resources that are created by users, teams, or projects. And management groups help you manage access, policy, and compliance for multiple subscriptions. All subscriptions in a management group automatically inherit the conditions applied to that management group. At the beginning of any cloud governance implementation, you identify a cloud organization structure that meets your business needs. This step often involves forming a Cloud Center of Excellence team, also called a Cloud Enablement team or a Cloud Custodian team. This team is empowered to implement governance practices from a centralized location for the entire organization. Teams often start their Azure governance strategy at the subscription level. So let's dive right in and see what's involved at this level. There are three main aspects to consider when you create and manage subscriptions: billing, access control, and subscription limits. Let's look at each of these aspects in more detail. You can create one billing report per subscription. If you have multiple departments and need to do a chargeback of cloud costs, one possible solution is to organize subscriptions by department or by project. Resource tags can also help. You'll explore tags later in this module. When you are defining how many subscriptions you need and what to name them, you should take into account your internal billing requirements. A subscription is a deployment boundary for Azure resources. Every subscription is associated with an Azure Active Directory tenant. Each tenant provides administrators the ability to set granular access through defined roles by using Azure role-based access control. When you design your subscription architecture, consider the deployment boundary factor. For example, do you need separate subscriptions for development and for production environments? With separate subscriptions, you can control access to each one separately and isolate their resources from one another. Subscriptions also have some resource limitations. For example, the maximum number of Azure Express route circuits per subscription is 10. Those limits should be considered during your design phase. If you'll need to exceed those limits, you might need to add more subscriptions. If you hit a hard limit maximum, there's no flexibility to increase it. Management groups are also available to assist with managing subscriptions. A management group manages access, policies, and compliance across multiple Azure subscriptions. You'll learn more about management groups later in this module. Organizations need to control who has access to their resources. This also applies in your cloud environment. When you have multiple IT and engineering teams, how can you control what access they have to the resources in your cloud environment? It is good security practice to grant users only the rights they need to perform their job and only to the relevant resources. Ordinarily, when new resources are created, you would have to define the detailed access requirements for each individual and then update their access rights. Using Azure Role-Based Access Control, RBAC, this process becomes much simpler. Azure Role-Based Access Control, Azure RBAC, is the system that allows control over who has access to which Azure resources and what those people can do with those resources. You achieve control by assigning roles to users, groups, or applications at a particular scope. A role might be described as a collection of permissions, while the scope is the set of resources that the access applies to. This diagram shows the relationship between roles and scopes. You can apply Azure roles at 4 levels of scope: management group, a collection of multiple subscriptions; subscription; resource group; and resource. Scopes are structured in a parent-child relationship. Each level of hierarchy makes the scope more specific. You can assign roles at any of these levels of scope. These are some of the built-in roles in Azure that you can assign to users. The reader can view resources, but is not allowed to make any changes. The contributor has full access to manage all resources, but is not allowed to assign roles. The owner role has full access to manage all resources, including the ability to assign roles in Azure RBAC. If the built-in roles don't meet the specific needs of your organization, you can create your own custom roles. When you assign the owner role to a user at the management group scope, that user can manage everything and all subscriptions within the management group. When you assign the reader role to a group at the subscription scope, the members of that group can view any resource group and resource within the subscription. When you assign the contributor role to an application at the resource group scope, the application can manage resources of all types within that resource group, but not other resource groups within the subscription. Observers, users managing resources, admins, and automated processes illustrate the kinds of users or accounts that would typically be assigned each of the various roles. How is Azure role-based access control enforced? Azure RBAC is enforced on any action that's initiated against an Azure resource that passes through Azure Resource Manager. Resource Manager is a management service that provides a way to organize and secure your cloud resources. Azure RBAC doesn't enforce access permissions at the application or data level. Application security must be handled by your application. You typically access Resource Manager from the Azure Portal, Azure Cloud Shell, Azure PowerShell, and the Azure CLI. Azure RBAC uses an allow model. When you're assigned a role, RBAC allows you to perform certain actions, such as read, write, or delete. The allow model is cumulative. That means if one role assignment grants you read permissions to a resource group and a different role assignment grants you write permissions to the same resource group, you have both read and write permissions on that resource group. By combining an Azure role and a scope, you can set finely tailored permissions for your Azure resources. Azure RBAC allows you to grant access to Azure resources that you control. Suppose you need to manage access to resources in Azure for Tailwind Traders' development, engineering, and marketing teams. You've started to receive access requests, and you need to quickly learn how access management works for Azure resources. Here are some scenarios you can implement with Azure role-based access control. Allow one user to manage virtual machines in a subscription and another user to manage the virtual network. Allow a database administrator group to manage SQL databases in a subscription, and allow a user to manage all resources in a resource group, such as virtual machines, websites, and subnets. You can also allow an application to access all resources in a resource group. You'll find the complete list of built-in roles at the end of this module. The way you control access to resources is to create role assignments which control how permissions are enforced. A role assignment is the process of attaching a role to a security principal at a particular scope for the purpose of granting access. User permissions are based on built-in or custom roles, while scope is the set of resources to which the permissions apply. A security principal is an object that represents a user, group, service principal, or managed identity that is requesting access to Azure resources. You can assign a role to an individual person known as a user or to a group, which is a set of users. When you assign a role to a group, all users within that group are granted that role. You can also assign a role to other identity types, such as service principals and managed identities. These identity types are used by applications and services to automate access to Azure resources. Tailwind traders have multiple teams with an interest in some part of their overall IT environment. It is important to the company to control access to different resources based on the functions and requirements of the individual teams. As you have discovered, one of the benefits for Tailwind traders is that they can use role-based access control to assign roles to either individuals or groups. Let's review the group setup for Tailwind traders. IT administrators. This team has ultimate ownership of technology assets, both on-premises and in the cloud. The team requires full control of all resources. Backup and disaster recovery. This team is responsible for managing the health of regular backups and invoking any data or system recoveries. Cost and billing. This team track and report on technology-related spend. They also manage the organization's internal budgets. And security operations. This team monitors and responds to any technology-related security incidents. The team requires ongoing access to log files and security alerts. Using Azure RBAC, you can segregate duties within your team and grant only the amount of access to users that they need to perform their jobs. Instead of giving everybody unrestricted permissions in your Azure subscriptions or resources, you can allow only certain actions at a particular scope. Now let's take a look at an example of how to manage Azure RBAC permissions. You manage access permissions on the Access Control IAM pane in the Azure portal. The example in this image is of the Access Control pane for a resource group. In this example, Alain Charon has been assigned the backup operator role for this resource group. This pane shows who has access to what scope and what roles apply. You can also grant or remove access from this pane. As an additional layer of access control, we can use Azure Resource Locking. A resource lock prevents resources from being accidentally deleted or changed. Even with Azure RBAC policies in place, there's still a risk that people with the right level of access could delete critical cloud resources. Think of a resource lock as a warning system that reminds you that a resource should not be deleted or changed. For example, at Tailwind Traders, an IT administrator was performing routine cleanup of unused resources in Azure. The admin accidentally deleted resources that appeared to be unused, but these resources were critical to an application that's used for seasonal promotions. How can resource locks help prevent this kind of incident from happening in the future? As an administrator, you can lock a subscription, resource group, or resource to prevent other users in your organization from accidentally deleting or modifying critical resources. This is an example that shows how to add a resource lock from the Azure portal. To view, add, or delete locks in the Azure portal, go to the Settings section of any Resources Settings pane in the Azure portal. You can also manage resource locks from the Azure portal, PowerShell, the Azure CLI, or from an Azure Resource Manager template. Later, you'll be given an opportunity to apply a similar resource lock. You can set the lock level to Cannot Delete or Read Only. In the portal, the locks are called Delete and Read Only, respectively. Cannot delete means authorized people can still read and modify a resource, but they can't delete the resource without first removing the lock. And read only means authorized people can read a resource, but they can't delete or change the resource. Applying this lock is like restricting all authorized users to the permissions granted by the reader role in Azure RBAC. Although locking helps prevent accidental changes, you can still make changes by following a two-step process. To modify a locked resource, you must first remove the lock. After you remove the lock, you can apply any action you have permissions to perform. This additional step allows the action to be taken, but it helps protect your administrators from doing something they might not have intended to do. Resource locks apply regardless of RBAC permissions. Even if you're an owner of the resource, you must still remove the lock before you can perform the blocked activity. What if a cloud administrator accidentally deletes a resource lock? If the resource lock is removed, its associated resources can be changed or deleted. To make the protection process more robust, you can combine resource locks with Azure Blueprints. Azure Blueprints enables you to define the set of standard Azure resources that your organization requires. For example, you can define a blueprint that specifies that a certain resource lock must exist. Azure Blueprints can automatically replace the resource lock if the lock is removed. You'll learn more about Azure Blueprints later in this module. As your cloud usage grows, it's increasingly important to stay organized. A good organization strategy helps you understand your cloud usage and can help you manage costs. For example, as Tailwind Traders prototypes new ways to deploy its applications on Azure, it needs a way to mark its test environments so that it can easily identify and delete resources in these environments when they're no longer needed. Earlier, you learned that you can organize related resources by placing them in their own subscriptions. You can also use resource groups to manage related resources. Resource tags are another way to organize resources. Tags provide extra information or metadata about your resources. Metadata is useful for a variety of purposes, including resource management. Tags enable you to locate and act on resources that are associated with specific workloads, environments, business units, and owners. Cost management and optimization. Tags enable you to group resources so that you can report on costs, allocate internal cost centers, track budgets, and forecast estimated cost. Operations management. Tags enable you to group resources according to how critical their availability is to your business. This grouping helps you formulate service level agreements, SLAs. An SLA is an uptime or performance guarantee between you and your users. Security. Tags enable you to classify data by its security level, such as public or confidential. Governance and regulatory compliance. Tags enable you to identify resources that align with governance or regulatory compliance requirements, such as ISO 27001. Tags can also be part of your standards enforcement efforts. For example, you might require that all resources be tagged with an owner or department name. And workload optimization and automation. Tags can help you visualize all of the resources that participate in complex deployments. For example, you might tag a resource with its associated workload or application name and use software such as Azure DevOps to perform automated tasks on those resources. You can add, modify, or delete resource tags through Azure Portal, PowerShell, the Azure CLI, Azure, the REST API, or Resource Manager templates. You can also manage tags by using Azure Policy. For example, you can apply tags to a resource group, but those tags aren't automatically applied to the resources within that resource group. You can use Azure Policy to ensure that a resource inherits the same tags as its parent resource group. You can also use Azure Policy to enforce tagging rules and conventions. For example, you can require that certain tags be added to new resources as they are provisioned. You can also define rules that reapply tags that have been removed. You'll learn more about Azure Policy later in this module. A resource tag consists of a name and a value. You can assign one or more tags to each Azure resource. After reviewing its business requirements, Tailwind Traders decides on a selection of tags. Let's take a look. A tag name reflects the exact term you would use for the Azure resource tag. For example, app name, cost center, owner, environment, and impact. Value is a list of all potential values applicable to the resource tag. In this example, the value refers to the following: the name of the application that the resource is part of, the internal cost center code, the name of the business owner who's responsible for the resource, an environment name, such as prod, dev, or test, and the importance of the resource to the business operations, such as mission critical, high impact, or low impact. This image shows these tags as they're applied to a virtual machine during provisioning. The Tailwind Traders team can run queries, for example, from PowerShell or the Azure CLI, to list all resources that contain these tags. Keep in mind that you don't need to enforce that a specific tag is present on all of your resources. For example, you might decide that only mission-critical resources have the impact tag. All non-tagged resources would then not be considered as mission-critical. Now that you've identified your governance and business requirements, how do you ensure that your resources stay compliant? How can you be alerted if a resource's configuration has changed? Azure Policy is a service in Azure that enables you to create, assign, and manage policies that control or audit your resources. These policies enforce different rules and effects over your resource configurations so that those configurations stay compliant with corporate standards. Azure Policy enables you to define both individual policies and groups of related policies, known as initiatives. Azure Policy evaluates your resources and highlights resources that aren't compliant with the policies you've created. Azure Policy can also prevent non-compliant resources from being created. Azure Policy comes with a number of built-in policy and initiative definitions that you can use under categories such as storage, networking, compute, security center, and monitoring. For example, say you define a policy that allows only a certain stock-keeping unit, SKU, size of virtual machines to be used in your environment. After you enable this policy, that policy is created when you create new VMs or resize existing VMs. Azure Policy also evaluates any current VMs in your environment. In some cases, Azure Policy can automatically remediate non-compliant resources and configurations to ensure the integrity of the state of the resources. For example, if all resources in a certain resource group should be tagged with the app name tag and a value of special orders, Azure Policy can automatically reapply that tag if it has been removed. Azure Policy also integrates with Azure DevOps by applying any continuous integration and delivery pipeline policies that apply to the pre-deployment and post-deployment phases of your applications. Now, let's take a look at Azure Policy in action. Implementing a policy in Azure Policy involves these 3 steps: Create a policy definition. Assign the definition to resources and review the evaluation results. Let's examine each step in more detail. A policy definition expresses what to evaluate and what action to take. For example, you could prevent virtual machines from being deployed in certain Azure regions. You also could audit your storage accounts to verify that they only accept connections from allowed networks. Every policy definition has conditions under which it's enforced. A policy definition also has an accompanying effect that takes place when the conditions are met. Azure Policy offers some built-in policies that are available by default. Let's go through a few examples. This policy enables you to specify a set of VM SKUs that your organization can deploy. This policy enables you to restrict the locations that your organization can specify when it deploys resources. Its effect is used to enforce your geographic compliance requirements. This policy requires that multi-factor authentication be enabled for all subscription accounts with write privileges to prevent a breach of accounts or resources. Cross-origin resource sharing is an HTTP feature that enables a web application running under one domain to access resources in another domain. For security reasons, modern web browsers restrict cross-site scripting by default. This policy allows only required domains to interact with your web app. And this policy enables Azure Security Center to recommend missing security system updates on your servers. To implement your policy definitions, you assign definitions to resources. A policy assignment is a policy definition that takes place within a specific scope. This scope could be a management group, a collection of multiple subscriptions, a single subscription, or a resource group. Policy assignments are inherited by all child resources within that scope. If a policy is applied to a resource group, that policy is applied to all resources within that resource group. You can exclude a subscope from the policy assignment if there are specific child resources you need to be exempt from the policy assignment. When a condition is evaluated against your existing resources, each resource is marked as compliant or non-compliant. You can review the non-compliant policy results and take any action that's needed. Policy evaluation happens about once per hour. If you make changes to your policy definition and create a policy assignment, that policy is evaluated over your resources within the hour. An Azure Policy Initiative is a way of grouping related policies into one set. The initiative definition contains all of the policy definitions to help track your compliance state for a larger goal. For example, Azure Policy includes an initiative named Enabled Monitoring in Azure Security Center. Its goal is to monitor all of the available security recommendations for all Azure resource types in Azure Security Center. Under this initiative, the following policy definitions are included. This policy monitors for unencrypted SQL databases and servers. This policy monitors servers that don't satisfy the configured OS vulnerability baseline. And this policy monitors for servers that don't have an installed endpoint protection agent. In fact, the Enable Monitoring and Azure Security Center initiative contains over 100 separate policy definitions. Azure Policy also includes initiatives that support regulatory compliance standards such as HIPAA and ISO 27001. This image shows a few example Azure Policy initiatives. You define initiatives by using the Azure portal or by using command line tools. From the Azure portal, you can search the list of built-in initiatives that are already provided by Azure. You also can create your own custom policy definition. Like a policy assignment, an initiative assignment is an initiative definition that's assigned to a specific scope of a management group, a subscription, or a resource group. Even if you have only a single policy, an initiative enables you to increase the number of policies over time. Because the associated initiative remains assigned, it's easier to add and remove policies without the need to change the policy assignment for your resources. So far, you've explored a number of Azure features that can help you implement your governance decisions, monitor the compliance of your cloud resources, and control access and protect critical resources from accidental deletion. What happens when your cloud environment starts to grow beyond just one subscription? How can you scale the configuration of these features, knowing they need to be enforced for resources in new subscriptions? Instead of having to configure features like Azure Policy for each new subscription, with Azure Blueprints, you can define a repeatable set of governance tools and standard Azure resources that your organization requires. In this way, development teams can rapidly build and deploy environments in compliance with organizational standards by using a set of built-in components that speed the development and deployment phases. Azure Blueprints orchestrates the deployment of various resource templates and other artifacts, such as role assignments, policy assignments, Azure Resource Manager templates, and resource groups. When you form a Cloud Center of Excellence team or a Cloud Custodian team, that team can use Azure Blueprints to scale their governance practices throughout the organization. Implementing a blueprint in Azure Blueprints involves these 3 steps: create a blueprint, assign the blueprint, and track the blueprint assignments. With Azure Blueprints, the relationship between the blueprint definition, what should be deployed, and the blueprint assignment, what was deployed, is preserved. In other words, Azure creates a record that associates a resource with a blueprint that defines it. This connection helps you track and audit your deployments. Blueprints are also versioned. Versioning enables you to track and comment on changes to your blueprint. Each component in the blueprint definition is known as an artifact. Artifacts can have no parameters. An example is the deploy threat detection on SQL servers policy, which requires no further configuration. Artifacts can also contain 1 or more parameters that you can configure. This image shows the allowed locations policy. This policy includes a parameter that specifies the allowed locations. You can specify a parameter's value when you create the blueprint definition or when you assign the blueprint definition to a scope. In this way, you can maintain one standard blueprint, but have the flexibility to specify the relevant configuration parameters at each scope where the definition is assigned. How will Tailwind traders use Azure Blueprints for ISO 27001 compliance? ISO 27001 is a standard that applies to the security of IT systems published by the International Organization for Standardization. As part of its quality process, Tailwind Traders wants to certify that it complies with this standard. Azure Blueprints has several built-in blueprint definitions that relate to ISO 27001. As an IT administrator, you decide to investigate the ISO 27001 Shared Services Blueprint definition. Let's take a look at the outline of your plan. First, define a management group that's named ProdMG. Second, recall that a management group manages access, policies, and compliance across multiple Azure subscriptions. Every new Azure subscription is added to this management group when the subscription is created. Third, create a blueprint definition that's based on the ISO 27001 Shared Services Blueprint template. Then publish the blueprint. Last, assign the blueprint to your ProdMG management group. The following image shows artifacts that are created when you run an ISO 27001 blueprint from a template. You see that the blueprint template contains policy assignments, resource manager templates, and resource groups. The blueprint deploys these artifacts to any existing subscriptions within the ProdMG management group. The blueprint also deploys these artifacts to any new subscriptions as they're created and added to the management group. Congratulations! You have completed Cloud Governance Strategy. Let's look back on your journey. You've been tasked with defining and implementing the governance strategy for Tailwind traders. Cloud governance requires good analysis and requirement gathering. Luckily, the Cloud Adoption Framework for Azure can help you define and implement your governance strategy. There are several services and features at Azure to support these efforts. These services and features include Azure Role-Based Access Control, Azure RBAC, a feature that enables you to create roles that define access permissions, Resource Locks, a feature that prevents resources from being accidentally deleted or changed, Resource Tags, a feature that provides extra information or metadata about your resources, Azure Policy, a service in Azure that enables you to create, assign, and manage policies that control or audit your resources, and Azure Blueprints, a service that enables you to define a repeatable set of governance tools and standard Azure resources that your organization requires. With these points in mind, you're ready to take the next step towards building a good cloud governance strategy. Hello, and welcome to this lesson on privacy, compliance, and data protection standards. As Tailwind Traders moves to running its applications in the cloud, it wants to know how Azure adheres to applicable regulatory compliance frameworks. The company asks, how compliant is Azure when it comes to handling personal data? How compliant are each of Azure's individual services? Up until now, Tailwind traders are used to having full control of all of their application data, which is stored on servers that it manages in its data center. Tailwind traders knows that moving an application to the cloud means the data is now outside of its own walls. The company also understands that the cloud provider has access to the server hardware and infrastructure. How is the privacy of its application data protected? Tailwind traders must also adhere to multiple regulatory and compliance frameworks. For example, it must follow certain rules to ensure that it properly handles credit card data. It will still need to ensure that its applications comply with applicable regulations and standards. How does infrastructure on Azure already adhere to these same standards? To answer these questions, let's start by learning about the types of compliance offerings that are available on Azure. After completing this module, you'll be able to describe the types of compliance offerings that are available on Azure. You will look at how to access the Microsoft Privacy Statement, the Online Services Terms, and the Data Protection Addendum to learn what personal data Microsoft collects, how Microsoft uses it, and for what purposes. You will also gain insight into regulatory standards and compliance on Azure from the Trust Center and from the Azure Compliance documentation. Finally, you will explore the Azure capabilities that are specific to government agencies. In this video, you will look at how the Microsoft Privacy Statement, the Online Services Terms, and the Data Protection Addendum explain what personal data Microsoft collects, how Microsoft uses it, and for what purposes. For Tailwind traders, understanding Microsoft's commitment to privacy helps ensure that their customer and application data will be protected. Let's begin with a brief look at the Microsoft Privacy Statement. The Microsoft Privacy Statement explains what personal data Microsoft collects, how Microsoft uses it, and for what purposes. The Privacy Statement covers all of Microsoft's services, websites, apps, software, servers, and devices. This list ranges from enterprise and server products to devices that you use in your home to software that students use at school. Microsoft's Privacy Statement also provides information that's relevant to specific products, such as Windows and Xbox. The Online Services Terms, or OST, is a legal agreement between Microsoft and the customer. The OST details the obligations by both parties with respect to the processing and security of customer data and personal data. The OST applies specifically to Microsoft's online services that you license through a subscription, including Azure, Dynamics 365, Office 365, and Bing Maps. The Data Protection Addendum, or DPA, further defines the data processing and security terms for online services. These terms include compliance with laws, disclosure of processed data, data security, which includes security practices and policies, data encryption, data access, customer responsibilities, and compliance with auditing, data transfer, retention, and deletion. To access the DPA, you can do the following. Go to the Licensing Terms and Documentation page. In the search bar, enter DPA. From the search results, locate the link to the DPA in your preferred language. Alternatively, in the search bar that appears, enter your preferred language to filter the results. Here's an example that retrieves the English version of the DPA. Transparency is also very important when it comes to how a cloud provider communicates its privacy policies and how it treats your data. The Microsoft Privacy Statement, the OST, and the DPA detail Microsoft's commitment to protecting data and privacy in the cloud. Here, you learn how to access detailed documentation about legal and regulatory standards and compliance on Azure. E-commerce is an important part of Tailwind Traders' sales strategy. Its online retail stores enables customers to easily browse and order products. Customers typically pay by credit card, so Tailwind Traders has a responsibility under the Payment Card Industry Data Security Standard, or PCI DSS. This global information security standard, known as PCI DSS, seeks to prevent fraud through increased control of credit card data. The standard applies to any organization that stores, processes, or transmits payment and cardholder data. You've been tasked with investigating whether hosting the company's e-commerce application on Azure would be compliant with PCI DSS. To do this, you start with the Azure Compliance documentation. The Azure Compliance documentation provides you with detailed documentation about legal and regulatory standards and compliance on Azure. Here you find compliance offerings across the following categories: global, U.S. government, financial services, health, media and manufacturing, regional. There are also additional compliance resources such as audit reports, privacy information, compliance implementations and mappings, and white papers and analyst reports. Country and region privacy and compliance guidelines are also included. It's important to note that some resources might require you to be signed in to your cloud service in order to access them. Azure Government is a separate instance of the Microsoft Azure Service. It addresses the security and compliance needs of U.S. federal agencies, state and local governments, and their solution providers. Azure Government offers physical isolation from non-U.S. government deployments and provides screened U.S. personnel. Azure Government Services handle data that is subject to certain government regulations and requirements, for example, the National Institute of Standards and the Department of Defense. To provide the highest level of security and compliance, Azure Government uses physically isolated data centers and networks located only in the U.S. Azure Government customers, such as the U.S. federal, state, and local government or their partners, are subject to validation of eligibility. Azure Government provides the broadest compliance and Level 5 Department of Defense approval. Azure Government is available in 8 geographies and offers the most compliance certifications of any cloud provider. Let's explore Microsoft Azure China 21 ViaNet. In order to comply with government regulation, Azure services in China are operated by 21 ViaNet, which is based on the technologies licensed from Microsoft. Azure China 21 ViaNet is a physically separated instance of cloud services located in China. Azure China 21 ViaNet is independently operated and transacted by Shanghai Blue Cloud Technology Company, or 21 ViaNet. This is a wholly owned subsidiary of Beijing 21 ViaNet Broadband Data Center Company. The reason for this? Compliance. According to the China Telecommunication Regulation, providers of cloud services, infrastructure as a service, or IaaS, and platform as a service, or PaaS, must have value-added telecom permits. And only locally registered companies with less than 50% foreign investment qualify for these permits. To comply with this regulation, the Azure service in China is operated by 21 ViaNet, based on the technologies licensed from Microsoft. The Azure services are based on the same Azure, Office 365, and Power BI technologies that make up the Microsoft Global Cloud Service with comparable service levels. Azure agreements and contracts in China, where applicable, are signed between customers and 21 ViaNet. This results in 2 major differences between the Azure Global Service and Azure China Service. These are operation model and service availability. Microsoft Azure services operated by 21 ViaNet are a standalone instance, separating from Azure Global Services. Therefore, the service availability is not identical to Global Azure. However, this does not change the quality of available services. As the first foreign public cloud service provider offered in China in compliance with government regulations, Azure China 21 ViaNet provides world-class security as required by Chinese regulations for all systems and applications built on its architecture. Congratulations! You have completed this lesson on privacy, compliance, and data protection standards. In this lesson, you learned about the types of compliance offerings that are available on Azure. You learned how to access the Microsoft Privacy Statement, the Online Services Terms, and the Data Protection Addendum to learn what personal data Microsoft collects, how Microsoft uses it, and for what purposes. You gained insight into Azure regulatory standards and compliance by accessing the Trust Center and from the Azure Compliance documentation. Finally, you explored Azure's capabilities that are specific to government agencies. Hello and welcome. In this module, you will learn about managing costs and service level agreements, or SLA, service cycles. Lesson 1 will focus on the cost of running in the cloud, and Lesson 2 will cover service level agreements in Azure. Let's get started by exploring the major factors that influence the cost of running in the cloud. Along the way, you'll get hands-on experience with some of the tools you can use to estimate the costs of running your workloads on Azure to help ensure that you stay within budget and use only the services that you need. Let's turn to our case study so you can apply what you learn. Tailwind Traders is planning its migration to the cloud. The company has run a few successful proof-of-concept projects and wants to better understand how to manage its costs before it moves its workloads to Azure. Running in the data center requires you to maintain a facility and purchase, power, cool, and maintain your servers. Running in the cloud presents new ways to think about your IT expenses. To answer the question of how much it will cost, you need to understand the factors that influence cost. You also need to understand what tools are available to you to help estimate and manage your cloud spend. Using this scenario, after you complete this lesson, you'll be able to use the total cost of ownership calculator to compare your current data center costs to running the same workloads on Azure. Describe the different ways you can purchase Azure products and services. Use the pricing calculator to estimate the monthly cost of running your cloud workloads. Define some of the major factors that affect total cost and apply recommended practices to minimize cost. Before Tailwind Traders takes its next steps toward migrating to the cloud, it wants to better understand what it spends today in its data center. Having a firm understanding of where the company is today will give it a greater sense of what cloud migration means in terms of cost. Now you'll see how the total cost of ownership calculator can help you compare the cost of running in the data center versus running on Azure. The total cost of ownership, or TCO calculator, helps you estimate the cost savings of operating your solution on Azure over time instead of in your on-premises data center. The term total cost of ownership is commonly used in finance. It can be hard to see all the hidden costs related to operating a technology capability on-premises. Software licenses and hardware are additional costs. With the TCO calculator, you enter the details of your on-premises workloads for servers, storage costs, IT labor costs, and other assumptions that may apply to your business. Then you review the suggested industry average cost, which you can adjust for related operational costs. These costs include hardware and software, electricity, data center, networking and storage, and IT labor. You're then presented with a side-by-side report. Using the report, you can compare those costs with the same workloads running on Azure. You don't need an Azure subscription to work with the TCO calculator. Working with the TCO calculator involves 3 steps: define your workloads, adjust assumptions, view the report. Let's take a closer look at each step. The first step, define your workloads, is where you enter the specifications of your on-premises infrastructure into the TCO calculator based on these 4 categories. The servers category includes operating systems, virtualization methods, CPU cores, and memory, RAM. The databases category includes database types, server hardware, and the Azure service you want to use, which includes the expected maximum concurrent user sign-ins. The storage category includes storage type and capacity, which includes any backup or archive storage. And the networking category includes the amount of network bandwidth you currently consume in your on-premises environment. In step 2, you adjust your assumptions about your operating costs. Here, you specify whether your current on-premises licenses are enrolled for software assurance. If they are, you can save money by reusing those licenses on Azure. You can also specify whether you need to replicate your storage to another Azure region for greater redundancy. Then, you can also see the key operating cost assumptions across several different areas. You might need to adjust these to more accurately reflect your situation. These costs have been certified by Nucleus Research, an independent research company. For example, these costs include electricity price per kilowatt hour, network maintenance cost as a percentage of network hardware and software costs, hourly pay rate for IT administration. To improve the accuracy of the TCO calculator results, you adjust the values so that they match the costs of your current on-premises infrastructure. In step 3, you generate a report based on your answers in steps 1 and 2. You start by choosing a time frame between 1 and 5 years. The TCO calculator generates a report that's based on the information you've entered. For each category, compute, data center, networking, storage, and IT labor, you can also view a side-by-side comparison of the cost breakdown of operating those workloads on-premises versus operating them on Azure. You can download, share, or save this report to review later. Next, we will go back to our case study and use the TCO calculator to help the Tailwind Traders team understand their total costs. Now you'll learn how to purchase Azure services and get a sense for other factors that affect cost. You meet with your chief financial officer and some of the team leads. You learn about some assumptions you've missed. You were able to quickly update your total estimated spend through the TCO calculator. During the meeting, some new questions arose as the discussion moved toward cloud migration. What types of Azure subscriptions are available? How do we purchase Azure services? Does location or network traffic affect cost? What other factors affect the final cost? How can we get a more detailed estimate of the cost to run on Azure? It's important to learn how costs are generated in Azure so that you can understand how your purchasing and solution design decisions can impact your final cost. You agreed to research these questions, so let's review each one in greater detail. You probably know that an Azure subscription provides you with access to Azure resources such as virtual machines, storage, and databases. The types of resources you use impact your monthly bill. Azure offers both free and paid subscription options to fit your needs and requirements. They are free trial, pay-as-you-go, and member offers. Let's examine these subscription models. A free trial subscription provides you with 12 months of popular free services, a credit to explore any Azure service for 30 days, and over 25 services that are always free. Your Azure services are disabled when the trial ends or when your credit expires for paid products, unless you upgrade to a paid subscription. A pay-as-you-go subscription enables you to pay for what you use by attaching a credit or debit card to your account. Organizations can apply for volume discounts and prepaid invoicing. Your existing membership to certain Microsoft products and services might provide you with credits for your Azure account and reduced rates on Azure services. For example, member offers are available to Visual Studio subscribers, Microsoft Partner Network members, Microsoft for Startups members, and Microsoft Imagine members. There are 3 main ways to purchase services on Azure: through an enterprise agreement, directly from the web, and through a cloud solution provider. Let's look at each of these now. Large customers, known as enterprise customers, can sign an enterprise agreement with Microsoft. This agreement commits them to spending a predetermined amount on Azure services over a period of 3 years. The service fee is typically paid annually. As an enterprise agreement customer, you'll receive the best customized pricing based on the kinds and amounts of services you plan on using. Here, you purchase Azure services directly from the Azure portal website and pay standard prices. You're billed monthly as a credit card payment or through an invoice. This purchasing method is known as Web Direct. A cloud solution provider, or CSP, is a Microsoft partner who helps you build solutions on top of Azure. Your CSP bills you for your Azure usage at a price they determine. They also answer your support questions and escalate them to Microsoft as needed. You can bring up or provision Azure resources from the Azure portal or from the command line. The Azure portal arranges products and services by category. You select the services that fit your needs. Your account is billed according to Azure's pay-for-what-you-use model. At the end of each month, you're billed for what you've used. At any time, you can check the cost management and billing page in the Azure portal to get a summary of your current usage and review invoices from prior months. The way you use resources, your subscription type, and pricing from third-party vendors have an impact on the cost of your Azure implementation. Among these factors that affect your costs are resource type, usage meters, resource usage, Azure subscription types, and Azure Marketplace. Let's take a quick look at each of these. A number of factors influence the cost of Azure resources. They depend on the type of resource or how you customize it. For example, with a storage account, you specify a type, such as a block blob storage or table storage, a performance tier, standard or premium, and an access tier, hot, cool, or archive. These selections present different costs. When you provision a resource, Azure creates meters to track usage of that resource. Azure uses these meters to generate a usage record that's later used to help calculate your bill. Think of usage meters similar to how you use electricity or water in your home. You might pay a base price each month for electricity or water service, but your final bill is based on the total amount that you consumed. Let's look at a single VM as an example. The following kinds of meters are relevant to tracking its usage: overall CPU time, time spent with a public IP address, incoming ingress or outgoing egress network traffic in and out of the VM, disk size and amount of disk read and disk write operations. Each meter tracks a specific type of usage. For example, a meter might track bandwidth usage, ingress or egress network traffic in bits per second, number of operations, or its size, storage capacity in bytes. The usage that a meter tracks correlates to a quantity of billable units. Those units are charged to your account for each billing period. The rate per billable unit depends on the resource type you're using. In Azure, you're always charged based on what you use. As an example, let's look at how this billing applies to deallocating a VM. To reduce costs, you can delete or deallocate a VM. Deleting a VM means that you no longer need it. The VM is removed from your subscription and is no longer available. Deallocating a VM means that the VM is no longer running, but the associated hard disks and data are still kept in Azure. The VM isn't assigned to a CPU or network in Azure's data center, so it doesn't generate the costs associated with compute time or the VM's IP address. Because the disks and data are still stored and the resource is present in your Azure subscription, you're still billed for disk storage. Deallocating a VM when you don't plan on using it for some time is just one way to minimize costs. For example, you might deallocate the VMs you use for testing purposes on weekends when your testing team isn't using them. You'll learn more about ways to minimize cost later in this module. Some Azure subscription types also include usage allowances, which affect costs. For example, an Azure free trial subscription provides access to a number of Azure products that are free for 12 months. It also includes credit to spend within your first 30 days of sign-up. And you get access to more than 25 products that are always free based on resource and region availability. You can also purchase Azure-based solutions and services from third-party vendors through Azure Marketplace. Examples include managed network firewall appliances or connectors to third-party backup services. Billing structures are set by the vendor. When you provision a resource in Azure, you need to define the location, known as the Azure region, where it will be deployed. Let's see why this decision can have cost consequences. Azure infrastructure is distributed globally, which enables you to deploy your services centrally or provision your services closest to where your customers use them. Different regions can have different associated prices. Because geographic regions can impact where your network traffic flows, network traffic is a cost influence to consider as well. For example, say Tailwind Traders decides to provision its Azure resources in the Azure regions that offer the lowest prices. That decision would save the company some money. But if they need to transfer data between those regions, or if their users are located in different parts of the world, any potential savings could be offset by the additional network usage costs of transferring data between those resources. Billing zones are a factor in determining the cost of some Azure services. Bandwidth refers to data moving in and out of Azure data centers. Some inbound data transfers, data going into Azure data centers, are free. For outbound data transfers, data leaving Azure data centers, data transfer pricing is based on zones. A zone is a geographical grouping of Azure regions for billing purposes. The following zones include some of the regions as shown here. Zone 1, Australia Central, West US, East US, Canada West, West Europe, French Central, and others. Zone 2, Australia East, Japan West, Central India, Korea South, and others. Zone 3, Brazil South, South Africa North, South Africa West, UAE Central, UAE North. DE Zone 1, Germany Central, Germany Northeast. As you've learned, an accurate cost estimate takes all of the preceding factors into account. Fortunately, the Azure Pricing Calculator helps you with that process. The Pricing Calculator displays Azure products in categories. You add these categories to your estimate and configure according to your specific requirements. You then receive a consolidated estimated price with a detailed breakdown of the costs associated with each resource you added to your solution. You can export or share that estimate or save it for later. You can load a saved estimate and modify it to match updated requirements. You also can access pricing details, product details, and documentation for each product from within the pricing calculator. A region is the geographical location in which you can provision a service. Southeast Asia, Western United States, and Northern Europe are a few examples. Tiers, such as the free tier or basic tier, have different levels of availability or performance and different associated costs. Billing options highlight the different ways you can pay for a service. Options can vary based on your customer type and subscription type and can include options to save costs. Support options enable you to select additional support pricing options for certain services. In programs and offers, your customer or subscription type might enable you to choose from specific licensing programs or other offers. Azure Dev Test Pricing lists the available prices for development and test workloads. Dev Test Pricing applies when you run resources within an Azure subscription that's based on a Dev Test offer. Keep in mind that the pricing calculator provides estimates and not actual price quotes. Actual prices can vary depending upon the date of purchase, the payment currency you're using, and the type of Azure customer you are. As a home improvement retailer, the proverb "measure twice, cut once" is fitting for the team at Tailwind Traders. Here are some recommended practices that can help you minimize your costs. First, it's important to understand estimated costs before you deploy. To help you plan your solution on Azure, carefully consider the products, services, and resources you need. Read the relevant documentation to understand how each of your choices is metered and billed. Calculate your projected costs by using the pricing calculator and the TCO calculator. Only add the products, services, and resources that you need for your solution. Ideally, you want your provisioned resources to match your actual usage. Azure Advisor identifies unused or underutilized resources and recommends unused resources that you can remove. This information helps you configure your resources to match your actual workload. Azure Advisor recommendations are sorted by impact: high, medium, or low. In some cases, Azure Advisor can automatically remediate or fix the underlying problem. Other issues, such as the two that are listed as high impact, require human intervention. If you have a free trial or a credit-based Azure subscription, you can use spending limits to prevent accidental overrun. For example, when you spend all the credit included with your Azure free account, Azure resources that you deployed are removed from production and your Azure virtual machines are stopped and deallocated. The data in your storage accounts is available as read-only. At this point, you can upgrade your free trial subscription to a pay-as-you-go subscription. If you have a credit-based subscription and you reach your configured spending limit, Azure suspends your subscription until a new billing period begins. A related concept is quotas, or limits on the number of similar resources that you can provision within your subscription. For example, you can allocate up to 25,000 VMs per region. These limits mainly help Microsoft plan its data center capacity. Azure Reservations offer discounted prices on certain Azure services. Azure Reservations can save you up to 72% as compared to pay-as-you-go prices. To receive a discount, you reserve services and resources by paying in advance. For example, you can prepay for 1 year or 3 years of use of VMs, database compute capacity, database throughput, and other Azure resources. This example shows estimated savings on VMs. In this example, you save an estimated 72% by committing to a 3-year term. Azure Reservations are available to customers with an enterprise agreement, cloud solution providers, and pay-as-you-go subscriptions. The cost of Azure products, services, and resources can vary across locations and regions. If possible, you should use them in those locations and regions where they cost less. But remember, some resources are metered and billed according to how much outgoing egress network bandwidth they consume. You should provision connected resources that are metered by bandwidth in the same Azure region to reduce egress traffic between them. Keep up to date with the latest Azure customer and subscription offers, and switch to offers that provide the greatest cost-saving benefit. Azure Cost Management and Billing is a free service that helps you understand your Azure bill, manage your account and subscriptions, monitor and control Azure spending, and optimize resource use. This image shows current usage broken down by service. In this example, Azure App Service, a web application hosting service, generates the greatest cost. Azure Cost Management and Billing provides a number of features. With reporting, you can use historical data to generate reports and forecast future usage and expenditure. Data enrichment allows you to improve accountability by categorizing resources with tags that correspond to real-world business and organizational units. You can create and manage cost and usage budgets by monitoring resource demand trends, consumption rates, and cost patterns. With alerts, you can set alerts based on your cost and usage budgets. You can receive recommendations to eliminate idle resources and to optimize the Azure resources you provision. Tags help you manage costs associated with the different groups of Azure products and resources. You can apply tags to groups of Azure resources to organize billing data. For example, if you run several VMs for different teams, you can use tags to categorize costs by department, such as human resources, marketing, or finance, or by environment, such as test or production. Tags make it easier to identify groups that generate the biggest Azure costs, which can help you adjust your spending accordingly. This image shows a year's worth of usage broken down by tags on the Azure Cost Management plus Billing page. A common recommendation that you'll find from Azure Cost Management and Billing and Azure Advisor is to resize or shut down VMs that are underutilized or idle. As an example, say you have a VM whose size is standard D4v4, a general-purpose VM type with 4 vCPUs and 16 gigabytes of memory. You might discover that this VM is idle 90% of the time. Virtual machine costs are linear and double for each size larger in the same series. So in this case, if you reduce the VM size from standard D4v4 to standard D2v4, which is the next size lower, you reduce your compute cost by 50%. Keep in mind that resizing a VM requires it to be stopped, resized, and then restarted. This process might take a few minutes depending on how significant the size change is. Be sure to properly plan for an outage or shift your traffic to another instance while you perform resize operations. Recall that to deallocate a VM means to no longer run the VM, but preserve the associated hard disks and data in Azure. If you have VM workloads that are only used during certain periods, but you're running them every hour of every day, you're wasting money. These VMs are great candidates to shut down when not in use and start back when you need them, saving you compute costs while the VM is deallocated. This approach is an excellent strategy for development and testing environments, where the VMs are needed only during business hours. Azure even provides a way to automatically start and stop your VMs on a schedule. This recommendation might sound obvious, but if you aren't using a resource, you should shut it down. It's not uncommon to find non-production or proof-of-concept systems that are no longer needed following the completion of a project. Regularly review your environment and work to identify these systems. Shutting down these systems can have a dual benefit by saving you on infrastructure costs and potential savings on licensing and operating costs. As you move your workloads to the cloud, a natural evolution is to start with infrastructure as a service, or IaaS services, because they map more directly to concepts and operations you're already familiar with. Over time, one way to reduce costs is to gradually move IaaS workloads to run on platform as a service, or PaaS services. While you can think of IaaS as direct access to compute infrastructure, PaaS provides ready-made development and deployment environments that are managed for you. As an example, say you run SQL Server on a VM running on Azure. This configuration requires you to manage the underlying operating system, set up a SQL Server license, manage software and security updates, and so on. You also pay for the VM whether or not the database is processing queries. One way to potentially save costs is to move your database from SQL Server on a VM to Azure SQL Database. Azure SQL Database is based on SQL Server. Not only are PaaS services, such as Azure SQL Database, often less expensive to run, but because they're managed for you, you don't need to worry about software updates, security patches, or optimizing physical storage for read and write operations. Licensing is another area that can dramatically impact your cloud spending. Let's look at some ways you can reduce your licensing costs. You should also choose a cost-effective operating system. Many Azure services provide a choice of running on Windows or Linux. In some cases, the cost depends on which you choose. When you have a choice and your application doesn't depend on the underlying operating system, it's useful to compare pricing to see whether you can save money. If you've purchased licenses for Windows Server or SQL Server and your licenses are covered by software assurance, you might be able to repurpose those licenses on VMs on Azure. Some of the details vary between Windows Server or SQL Server. We'll provide resources at the end of this module where you can learn more. Tailwind Traders is taking a methodical approach toward cloud migration. While proof of concept projects can help demonstrate technical feasibility, having a clear picture of the total cost of running in the cloud will further help the team validate its approach. To start, the Tailwind Traders team used the total cost of ownership calculator to estimate the cost savings of operating its solution on Azure instead of in its on-premises data center. From there, the team used the pricing calculator to get a more detailed estimate for running a typical workload on Azure each month. The team also created a checklist of cost-saving measures that it can use to help keep down costs. This list includes: perform cost analysis before you deploy, use Azure Advisor to monitor your usage, use spending limits to prevent accidental spending, use Azure reservations to prepay, choose low-cost locations and regions, research available cost-saving offers, apply tags to identify cost owners. With these measures in place, the Tailwind Traders team is ready to take the next steps toward cloud migration. As next steps, if you run existing workloads on premises or in the data center, try entering your existing workloads in the total cost of ownership calculator to see how the cost of running on Azure compares to what you pay today. Then, use the Azure documentation to map your current infrastructure to cloud services. Use the pricing calculator to get a more accurate picture of what it would cost to run your existing workloads on Azure. Hello again. In this lesson, you'll learn about service level agreements, or SLAs, in Azure and how they can affect your application design decisions. You'll also learn about the life cycle of new Azure services, from preview to general availability. Moving to the cloud removes the burden of supporting IT infrastructure. When network connectivity is lost or a hard drive fails, you rely on the cloud provider to restore service. Tailwind Traders' IT department hosts applications and services in its data center for the rest of the company. The IT department has agreements with other teams in place that state how available those services will be, which includes when and how planned maintenance can happen. As Tailwind Traders moves its workloads to Azure, it no longer has full control over the hardware and networks. How will its agreements around availability be affected? With this scenario in mind, and after you complete this lesson, you'll be able to describe what an SLA is and why SLAs are important. Identify factors such as the service tier you choose that can affect an SLA. Combine SLAs to compute a composite SLA. Describe the service lifecycle in Azure, including how to access new capabilities that are coming to Azure. A service level agreement, or SLA, is a formal agreement between a service company and the customer. For Azure, this agreement defines the performance standards that Microsoft commits to for you, the customer. Now you'll learn more about Azure SLAs, including why SLAs are important, where you can find the SLA for a specific Azure service, and what you'll find in a typical SLA. SLAs are an important part of your Azure subscription. Understanding the SLA for each Azure service you use helps you know what guarantees you can expect. When you build applications on Azure, the availability of the services that you use affect your application's performance. Understanding the SLAs involved can help you establish the SLA you set with your customers. Later, you'll learn about some strategies you can use when an Azure SLA doesn't meet your needs. You don't need an Azure subscription to review service SLAs. Each Azure service defines its own SLA. Service level agreements, or SLAs, describe Microsoft's commitments for uptime and connectivity. You can find the SLA for individual Azure services on the Service Level Agreements section of the azure.microsoft.com website. As an example, we will use the SLA for Azure Database for MySQL, a managed database that makes it easy for developers to work with MySQL databases. You can access this SLA from service level agreements in the Azure documentation. Azure services are organized by category. Under the Databases category, you can select Azure Database for MySQL. A typical SLA breaks down into these sections: Introduction, General Terms, and SLA Details. The introduction explains what to expect in the SLA, including its scope and how subscription renewals can affect the terms. The general terms contain terms that are used throughout the SLA so that both parties, you and Microsoft, have a consistent vocabulary. For example, this section might define what's meant by downtime, incidents, and error codes. This section also defines the general terms of the agreement, including how to submit a claim, receive credit for any performance or availability issues, and limitations of the agreement. The details section defines the specific guarantees for the service. Performance commitments are commonly measured as a percentage. That percentage typically ranges from 99.9%, or 3 nines, to 99.99%, 4 nines. The primary performance commitment typically focuses on uptime, or the percentage of time that a product or service is successfully operational. Some SLAs focus on other factors as well, including latency or how fast the service must respond to a request. This section also defines any additional terms that are specific to the service. The SLA for Azure Database for MySQL focuses mainly on uptime. Azure Database for MySQL guarantees 99.99%, or 4 nines, uptime. This means that the service is guaranteed to be running and available to process requests 99.99% of the time. Downtime refers to the time duration that the service is unavailable. The difference between 99.9% and 99.99% might seem minor, but it's important to understand what these numbers mean in terms of total downtime. This table shows how the total downtime decreases as the SLA percentage increases from 99% to 99.999%. For example, a 99.9% SLA has a downtime of 8.76 hours per year, while a 99.99% SLA drops down to 5.26 minutes. These amounts are cumulative, which means that the duration of multiple different service outages would be combined or added together. A service credit is the percentage of the fees you paid that are credited back to you according to the claim approval process. An SLA describes how Microsoft responds when an Azure service fails to perform to its specification. For example, you might receive a discount on your Azure bill as compensation when a service fails to perform according to its SLA. Credits typically increase as uptime decreases. For example, an uptime of under 99.00 will give you a 10% service credit. An uptime under 95% will give you a 100% service credit. Free products typically don't have an SLA. For example, many Azure services provide a free or share tier that provides more limited functionality. Services like Azure Advisor are always free. The SLA for Azure Advisor states that because it's free, it doesn't have a financially backed SLA. Azure Status provides a global view of the health of Azure services and regions. If you suspect there's an outage, this is often a good place to start your investigation. Azure Status also provides an RSS feed of changes to the health of Azure services that you subscribe to. You can connect this feed to communication software such as Microsoft Teams or Slack. From the Azure Status page, you can also access Azure Service Health. This provides a personalized view of the health of the Azure services and regions that you're using directly from the Azure portal. Typically, you need to file a claim with Microsoft to receive a service credit. If you purchase Azure services from a cloud solution provider or CSP partner, your CSP typically manages the claim process. Each SLA specifies the timeline by which you must submit your claim and when Microsoft processes your claim. For many services, you must submit your claim by the end of the calendar month following the month in which the incident occurred. Next, let's take a look at some other factors that Tailwind traders might need to consider that might affect SLA performance targets. An application SLA defines the SLA requirements for a specific application. This term typically refers to an application that you build on Azure. Tailwind Traders runs an application that it built on Azure called Special Orders. The application tracks special orders that customers have placed in the company's retail stores. A special order includes an item and any customizations that the customer needs. For example, a folding door might include customizations such as dimension and hinge placement. Because customizations typically require special handling, the customized item needs to be ordered from the supplier when a customer needs it. There are many design decisions you can make to improve the availability and resiliency of the applications and services you build on Azure. These decisions extend beyond just the SLA for a specific service. In this part, you'll explore a few of these considerations. A good place to start is to have a discussion with your team about how important the availability of each application is to your business. We will cover a few factors that Tailwind traders might consider now. If the special orders application goes down, customers can't place new orders through the store and staff can't check the status of existing orders. Customers will either need to try again later or possibly go to a competitor. The special orders application doesn't affect other operations, so the majority of the Tailwind traders' business will continue to function normally if the special orders application went down. Usage patterns define when and how users access your application. One question to consider is whether the availability requirement differs between critical and non-critical time periods. For example, a tax filing application can't fail during a filing deadline. For Tailwind traders, retail stores aren't open 24 hours a day, so if the application were down in the middle of the night, the impact would be minimal. However, because Tailwind traders has retail locations all over the world, it will need to ensure that each location has access to the service during its retail hours. Let's say that Tailwind traders decides that an SLA of 99.9% is acceptable for the special orders application. This gives the company an estimated downtime of 10.1 minutes per week. But how will it ensure that its technology choices support its application SLA? Next, you'll see how the team maps its application requirements to specific Azure services. You'll learn about some of the techniques you can use to help ensure that your technology choices meet your application SLA. Tailwind traders decides that an SLA of 99.9% is acceptable for the special orders application. Recall that this gives the company an estimated downtime of 10.1 minutes per week. Now you need to design an efficient and reliable solution for this application on Azure, keeping that application SLA in mind. You'll select the Azure products and services you need and provision your cloud resources according to those requirements. In reality, failures will happen. Hardware can fail. The network can have intermittent timeout periods. While it's rare for an entire service or region to experience a disruption, you still need to plan for such events. Let's follow the process Tailwind traders uses to ensure that its technology choices meet its application SLA. A workload is a distinct capability or task that's logically separated from other tasks in terms of business logic and data storage requirements. Each workload defines a set of requirements for availability, scalability, data consistency, and disaster recovery. On Azure, the special orders application will require 2 virtual machines, 1 instance of Azure SQL database, and 1 instance of Azure Load Balancer. This diagram shows the basic architecture. After you've identified the SLA for the individual workloads in the special orders application, you might notice that those SLAs are not all the same. How does this affect our overall application SLA requirement of 99.9%? To work that out, you'll need to do some math. The process of combining SLAs helps you compute the composite SLA for a set of services. Computing the composite SLA requires that you multiply the SLA of each individual service. From service-level agreements, you discover the SLA for each Azure service that you need. They are 99.9% for Azure virtual machines. Recall that you need 2 virtual machines. Therefore, you include the virtual machines SLA of 99.9% 2 times in the formula. 99.99% for SQL database, and 99.99% for Azure Load Balancer. Therefore, for the special orders application, the composite SLA would be 99.78%. Note that even though all the individual services have SLAs equal to or better than the application SLA, combining them results in an overall number that is lower than the 99.9% you need. Why? Because using multiple services adds an extra level of complexity and slightly increases the risk of failure. You see here that the composite SLA of 99.78% doesn't meet the required SLA of 99.9%. You might go back to the team and ask whether this is acceptable. Or you might implement some other strategies into your design to improve this SLA. For the special orders application, the composite SLA doesn't meet the required SLA of 99.9%. Let's look at a few strategies that Tailwind traders might consider. You can choose customization options that fit your required SLA. Each of the workloads defined previously has its own SLA, and the customization choices you make when you provision each workload affects that SLA. Let's look at disks and tiers. With virtual machines, you can choose from a standard HDD managed disk, a standard SSD managed disk, or a premium SSD or Ultra disk. The SLA for a single VM would be either 95%, 99.5%, or 99.9% depending on the disk choice. Some Azure services are offered as both a free tier product and as a standard paid service. For example, Azure Automation provides 500 minutes of job runtime in an Azure free account, but is not backed by an SLA. The standard tier SLA for Azure Automation is 99.9%. Make sure that your purchasing decisions take into account the impact on the SLA for the Azure services that you choose. Doing so ensures that the SLA supports your required application SLA. Here, Tailwind traders might choose the Ultra Disk option for its virtual machines to help guarantee greater uptime. There are application design considerations you can use that relate to the underlying cloud infrastructure. For example, to improve the availability of the application, avoid having any single points of failure. So instead of adding more virtual machines, you can deploy one or more extra instances of the same virtual machine across the different availability zones in the same Azure region. An availability zone is a unique physical location within an Azure region. Each zone is made up of one or more data centers equipped with independent power, cooling, and networking. These zones use different schedules for maintenance, so if one zone is affected, your virtual machine instance in the other zone is unaffected. Deploying two or more instances of an Azure virtual machine across two or more availability zones raises the virtual machine SLA to 99.99%. Recalculating your composite SLA above with this virtual machine's SLA gives you an application SLA of 99.96%. This revised SLA of 99.96% exceeds your target of 99.9%. To learn more about the SLA for virtual machines, you visit the SLA for virtual machines section of the azure.microsoft.com website. To ensure high availability, you might plan for your application to have duplicate components across several regions, known as redundancy. Conversely, to minimize costs during non-critical periods, you might run your application only in a single region. Tailwind traders might consider this if there's a trend that the special orders rates are much higher during certain months or seasons. To achieve maximum availability in your application, add redundancy to every single part of the application. This redundancy includes the application itself, as well as the underlying services and infrastructure. Be aware, however, that doing so can be difficult and expensive, and often results in solutions that are more complex than they need to be. Consider how critical high availability is to your requirements before you add redundancy. There may be simpler ways to meet your application SLA. Performance targets above 99.99% are very difficult to achieve. Recall that an SLA of 99.99% means 10.1 minutes of downtime per week. It's difficult for humans to respond to failures quickly enough to meet SLA performance targets above 99.99%. Instead, your application must be able to self-diagnose and self-heal during an outage. Now that Tailwind Traders has its applications up and running, it wants to start looking into new capabilities. One option is to look at preview services. Now you'll learn how Azure services go from the preview phase to being generally available. For Tailwind traders, migration from the data center to Azure is more about operational efficiency. The research and development team is looking into new cloud-based features that will keep them ahead of the competition. Tailwind Traders is experimenting with a custom drone delivery system for customers in rural areas. The company needs the ability to use real-time storm tracking in the drone guidance system, but the feature isn't ready yet. In this scenario, you will work with AI Storm Analyzer, a fictitious Azure service introduced here for illustration purposes only. AI Storm Analyzer service has just entered the public preview phase, so Tailwind Traders has decided to incorporate it into the early stages of application testing. Before the team moves forward, it wants a better understanding of how preview services affect its SLA. Let's begin by defining the Azure Service lifecycle. The service lifecycle defines how every Azure service is released for public use. Every Azure service starts in the development phase. In this phase, the Azure team collects and defines its requirements and begins to build the service. Next, the service is released to the public preview phase. During this phase, the public can access and experiment with it so that it can provide feedback. Your feedback helps Microsoft improve services. More importantly, providing feedback gives you the opportunity to request new or different capabilities so the services better meet your needs. After a new Azure service is validated and tested, it's released to all customers as a production-ready service. This is known as General Availability, or GA. Each Azure preview defines its own terms and conditions. All preview-specific terms and conditions supplement your existing Azure service agreement. Some previews aren't covered by customer support. Therefore, previews are not recommended for business-critical workloads. You can access preview services from the Azure portal. After you sign in, you can select Create a Resource. Then search for Preview. You can also launch the service if you'd like to try it out. Some preview features relate to a specific area of an existing Azure service. For example, a compute or database service that you use daily might provide enhanced functionality. These preview features are accessible when you deploy, configure, and manage the service. Although you can use an Azure Preview feature in production, make sure you're aware of any limitations around its use before you deploy it to production. You can provide feedback from the Feedback tab in the Azure portal or from the Azure portal Feedback Forum. The Azure Updates page provides information about the latest updates to Azure products, services, and features, as well as product roadmaps and announcements. From the Azure Updates page, you can view details about all Azure updates. Subscribe to an RSS feed to receive notifications. Search for updates by keyword. See which updates are in general availability, preview, or development. Browse updates by product category or update type. And access the Microsoft Connect page to read Azure product news and announcements. Using the Azure Updates page is an easy way to stay on top of the latest information. An SLA is the formal agreement between a service company and the customer. For Azure, this agreement defines the performance standards that Microsoft commits to for its customers. The Tailwind Traders team is working on quite a variety of projects. In addition to its main website, the team is adding a mapping feature to its special orders application so that it can calculate routes between suppliers and retail stores. The team is also exploring how severe weather tracking can improve its drone guidance system. As requirements evolve, it's important for the team to understand how the SLA for each service it chooses affects the overall performance guarantees of its applications. For example, the main website must be available as close to 100% of the time as possible. To accomplish that, Tailwind Traders might deploy extra instances of the same virtual machine across different availability zones in the same Azure region. Doing so helps ensure that if one zone is affected, virtual machine instances in the other zone can pick up the load. The special orders application might have more flexible tolerances. As long as retail employees don't lose data and can quickly regain network access, the special orders application might have a lower SLA. Here, the team can choose to include less redundancy in its design. When defining your SLA requirements, be sure to consider both your business needs and the time it takes to restore a component after a failure. Also consider how the use of preview services and preview features might affect your systems in production. As a next step, create a sketch or diagram for an application that you plan to migrate to the cloud. Include each Azure service that you plan to use. Use the documented service level agreements to find out the SLA for each Azure service involved. Then compute the composite SLA for your application. Does the composite SLA meet your requirements? If not, what can you do to improve it? You have now completed 3 courses in this program intended to prepare you for the Microsoft Certified AZ900 Azure Fundamentals exam. Introduction to Azure Core Concepts and Services, Azure Management Tools and Security Solutions, and Azure Services and Lifecycles. At this stage, you should have foundational knowledge of cloud services and how those services are provided with Microsoft Azure. You are almost ready to take the exam to prove your knowledge of cloud concepts, Azure services, Azure workloads, security and privacy in Azure, as well as Azure pricing and support. Each course you have taken has taught you the core concepts and skills that are measured by the exam. In the next course, you will get an opportunity to recap on all the content you have covered and test your knowledge in a series of practice exams. By the end of this program, you will be ready to take and sign up for the AZ900 exam. Microsoft certifications give you a professional advantage by providing globally recognized and industry-endorsed evidence of mastering skills in digital and cloud businesses. When you are AZ900 certified, there are many different paths that you can follow. The AZ900 certification is the entry level for any other Azure certification. It is the starting point to the associate level and to the engineer and expert level certificates. Depending on your interests, you can build on what you have learned by pursuing certification at associate level in many different areas. Microsoft's associate level certifications usually require around 2 years of working experience with the products they cover. It'll be helpful that you have already earned a fundamental certification before trying for the associate level credentials, but it's not mandatory. At the moment, there are a wide range of associate level Azure certifications on offer. Each certification is aligned to an Azure career. So if you want to be a developer, an administrator, a data scientist, or an AI engineer, you're on the right path. In the next course, you will be preparing for the AZ900 Microsoft Azure Fundamentals exam. You will find information about the Microsoft certification program, the topics covered in the exam, and also get access to study materials and practice exams. Make sure to cover the reading on what to expect next. Congratulations! You have now completed the Azure Services and Lifecycles course. Now you're one step away from completing the program. Let's get some practice preparing for the AZ900 exam so you can further your career in Microsoft Azure.
Hello, and welcome to the final course in this program, preparing for the AZ900 Microsoft Azure Fundamentals exam. The focus of this course is exam preparation. Here, you have access to practice exams that will help prepare you for the Microsoft AZ900 certification exam. You'll also have access to resources that will help you to prepare for taking the exam online, which is a proctored exam. You will also enhance your study techniques and learn how to develop successful exam strategies. By now, you may have already started thinking about learning and development or your career goals, or ask yourself, what next? In this course, you will have an opportunity to explore some further certifications that can help your learning and development strategy and assist you in preparing for your chosen career path. The practice exams in this course are designed primarily to help you assess your knowledge and application of the key concepts covered in the AZ900 Microsoft Certified Azure Fundamentals exam. You'll have an opportunity to recap key topics and take a practice exam for each of the 3 courses covered in this program. In this course, for a module to be considered complete, you must successfully complete the practice exam. Only then can you progress to the next module. Module 2 covers the key concepts presented in Course 1, Introduction to Azure Core Concepts and Services. Module 3 covers the key concepts presented in Course 2, Azure Management Tools and Security Solutions. And Module 4 covers the key concepts presented in Course 3, Azure Services and Lifecycles. Through the practice exams, you'll revisit the topics and key concepts covered in this program. These topics are mapped to 6 domain areas in the AZ900 Microsoft Certified Azure Fundamentals exam and include Cloud Concepts, Core Azure Services, Core Solutions and Management Tools on Azure, General Security and Network Security Features, Identity, Governance, Privacy and Compliance Features, and Azure Cost Management and Service Level Agreements. The final practice exam in Module 5 incorporates the key concepts covered in this program and is mapped to the 6 domain areas that we reviewed earlier. By taking the practice exams, you'll be able to measure your readiness to take the Microsoft AZ900 Azure Fundamentals Proctored exam. Once you've successfully completed a course and graded quiz, you will be awarded a Coursera certificate. If everything goes well, you will also receive a certificate at the end of this program. After you've successfully completed all the courses on Coursera, you'll be ready to take the exam. Good luck with your preparation. Hi, and welcome to this module, Certification and Exam Preparation. No matter your experience level, you can advance your career and demonstrate your achievements through industry-recognized Microsoft certifications. There can be many reasons to pursue a Microsoft certification. Microsoft certifications are among the most highly regarded certifications in the IT industry. In this module, you'll explore several Microsoft certification pathways that will help to develop your career. There are multiple certification options to choose from that will help you achieve personal success. You'll also get to work through strategies and techniques that you can use to successfully prepare for a proctored exam, including how the proctored exam is administered, testing strategies, access to study materials, and hints and tips for the exam. After completing it, you will be able to identify the opportunities available for your future development and Microsoft certification, and identify study techniques and strategies required to prepare for a proctored exam. In the next modules, you'll get an opportunity to recap on all the content you have covered and test your knowledge in a series of practice exams. The world is changing rapidly, and you must be ready to meet the challenges of today's economy. The skills required for jobs are constantly evolving. Employment criteria has changed from what was needed even just a few years ago. To be successful, it's important to keep growing your skill set, experience, and abilities. In this video, you'll explore jobs and careers in cloud computing. The demand for certified cloud computing professionals is increasing rapidly. The shortage of qualified professionals in this field presents a golden opportunity for you in your future career. A strong foundation of knowledge through learning and certifications can prepare you for developing a career in cloud computing. In this video, we focus on 3 of the growing professions in cloud computing: cloud system administrators, data analysts, and AI engineers. These jobs require a range of skills and experience that can cater to the increasingly expanding market. Let's dive right in and find out more. Is this the job for you? As a cloud systems administrator, you will have to deploy, configure, implement, and manage the systems that make up the underlying technical platform. You will also assist in setting up public or private cloud systems and support and maintain the virtual systems. As an administrator, you often serve as part of a larger team dedicated to implementing an organization's cloud infrastructure. Typically, a cloud administrator's responsibility can range from provisioning systems and services to managing and securing the cloud infrastructure. Cloud systems administrators often work their way up from a junior cloud systems administrator role, perhaps even starting in a help desk role. Getting certified can help you to become a cloud system administrator. Next, let's take a look at the role of an AI engineer and how that fits into cloud computing. AI is driving massive technical innovation across all aspects of life, from disease diagnosis to self-driving cars. This has led to an increased demand for AI experts. Organizations all over the world are gearing up for a future powered by AI, and they're looking for engineers who can create AI-enabled apps and bots to help improve customer service, drive cost savings, accelerate decision-making, and build agility and resilience with this new breed of digital technologies. Does this sound like you? Responsibilities for this role include analyzing requirements for AI solutions, recommending the appropriate tools and technologies, and designing and implementing AI solutions that meet scalability and performance requirements. AI engineers translate the vision from solution architects and work with data scientists, data engineers, IoT specialists, and software developers to build complete end-to-end solutions. To be an AI engineer, completing a certification course in data science, machine learning, or artificial intelligence is highly recommended. Getting AZ900 certified can be the start of this journey. Now let's find out more about data analysts. Data analysts collect, process, and perform statistical analysis on large data sets. The data analyst also identifies and interprets trends or patterns in complex data sets. Data analysts provide important information to key stakeholders to help solve problems or identify areas for improvement. Is analytics one of your career goals? As a subject matter expert, data analysts are responsible for designing and building scalable data models, cleansing and transforming data, and enabling advanced analytic capabilities that provide meaningful business value through easy-to-comprehend data visualizations. As in most fields of IT, the road towards becoming a data analyst can be a long one and requires a lot of hard work. But the rewards are good for those who stay the course. Aspiring data analysts are usually mathematically and analytically inclined and have a background in statistics, economics, or computer science, as well as expertise in using analysis tools. There are many jobs and career paths that you can follow. It's important to stay ahead of the technology learning curve and keep an eye on relevant training and certifications that could advance your career in cloud computing. Please remember to access the additional resources to continue exploring the exciting world of cloud computing. Hi, and welcome to this lesson on preparing for the AZ900 exam that you can take online from the comfort of your home or office. In this lesson, we will take you through the essential readings, how to prepare for the AZ900 examination, and the topics covered in the exam. You will also gain a better understanding about how the exam is administered and the techniques you can use that will help you to pass the exam and obtain your certification. We will guide you through the implementation of an appropriate exam strategy focusing on preparation and exam technique, and we will also provide you with some tips and tricks that can help in your preparation. You can take the AZ900 or any Microsoft role-based or fundamentals exam with Pearson VUE in person at an authorized test center or online at your home or office while being monitored by an off-site proctor. Whether you take the exam at a test center or online, you will need to complete a check-in process which involves ID verification, face matching, and a live greeter. Let's take a closer look at the OnVUE online proctoring, which allows you to take your certification exam securely from your home or office. A proctored exam is a monitored exam where the proctor or supervisor monitors the student during the examination process. Proctored exams usually have a time limit. During this time, you are monitored by a person via proctoring software that has access to your computer's desktop, webcam video, and audio. There are a few requirements that you need to fulfill before you can take a proctored exam at home with Pearson VUE. Firstly, you must have a functioning home computer with a webcam and strong internet connection. You will need to run a system check to test the compatibility of the OnVUE application. You need to have a space, ideally a room, that is free from noise or distractions, such as roommates and pets. Finally, you will need to make sure that the room or space is free of any preparation materials or unauthorized items in order to avoid exam violations outlined in the Microsoft Certification Program Agreement. On the Microsoft side, you will need to make sure that you have your Microsoft certification profile with your cell phone number, including country code, in case Pearson VUE needs to contact you during the exam. At the start of your exam, you must read and agree to the NDA and general terms of use for Microsoft certification exams. Let's take a brief look at the exam format now. You can expect between 40 to 60 questions in the Microsoft AZ900 exam. There are many different types of exam question formats. These include case study, multiple choice, short answers, and more. We will review all of these question types later in this lesson. A successful exam with a good grade is an achievable goal if you are well prepared and practice some basic strategies. As with all exams, different assessments may require different strategies. Here, we will discuss the main strategy that you should employ in order to maximize your chances of passing the AZ900 exam. One of the best preparations that you can make is to take a practice test before the exam. This way, you can monitor your progress and identify the areas that might require a little more study or attention. Throughout this program, you have taken practice ungraded and graded quizzes. These are specifically designed to help you monitor your progress while preparing you for the real exam. Later in this course, you will take 3 practice exams, where each one will focus on the topics and key concepts covered in the previous 3 courses. Each practice exam content is associated with an individual course. For example, practice exam 1 to course content 1, and so on. The exams must be taken in sequential order, meaning that you will have to complete them in order 1, 2, and 3. You will only be able to move on to the next exam once you have passed the previous one. Remember that you can go back over any lesson at any time for revision. Once you have successfully completed the practice exams, it's time to turn your attention to the real exam. A good exam strategy for the AZ900 exam can be summarized with a checklist of what to do on the test day. When the test day arrives, it's recommended that you do the following. Be well rested and eat a meal or snack. Try not to drink too much water as to not need to go to the bathroom during the exam. Give yourself enough time to get set up. The last thing you want is to feel hurried or be late for the exam. Bring the appropriate identification with you. If you are not sure, check the official documentation from Microsoft and Pearson VUE. The AZ900 is a closed book exam, meaning that you cannot bring any study or exam materials into the examination with you. For a full list, please see the Microsoft Program Agreement. Make sure that you read all test instructions and candidate rules thoroughly. And finally, take your time. Read the exam questions carefully. If possible, try to leave some time at the end to check back over your answers. To protect exam security, Microsoft does not specify exam formats or question types before the exam. Microsoft continually introduces innovative testing technologies and question types, and reserves the right to incorporate either into exams at any time without advance notice. To get a feel for what you might see on an exam, we encourage you to review some possible exam formats and question types from the Microsoft documentation. The exam may contain any of the following question types: active screen, best answer, build list, case studies, drag and drop, hot area, multiple choice, repeated answer choices, short answer, labs, mark review, and review screen. When it comes to answering the exam questions, here are some strategies. Keep calm and read the question in its entirety before checking the answer options. Students often choose the wrong option because they have misread the question. If there are multiple answer options, try to eliminate answers you know are 100% incorrect. By using this process of elimination, you can cross out all the incorrect answers. This visual tool will help you focus on the remaining answers, and this will help you find the right answer. If you are unsure between one or more possible answers, try to find the best answer to the question being asked. This may not always be the answer that seems most correct in isolation. Make sure to read every answer option before choosing a final answer. A common mistake that students make is to rush and pick the first answer that sounds right without reading all of the available options. If you're having difficulty with the question, move on and come back after you have answered all the questions you know. Remember to play the percentage game. Try not to spend too much time on only one question, which could leave you short on time for the rest. You want to make sure you have enough time to attempt all questions. Try to leave some time to review your answers. Depending on the question format, you may not be able to change your answer, but for those you can, you want to make sure that you have answered them correctly. During this review, you may be tempted to second-guess yourself at times and change your answer. While this can work in certain circumstances, it can be counterproductive. Be careful and try to trust your instincts. Once again, be aware that depending on the question format, some answers cannot be changed. The AZ900 does not apply negative marking, meaning that you will not be penalized for making an incorrect guess. If you are unsure of a question, try and make the best educated guess that you can. Try to apply your existing Azure logic from what you know and pick the best possible answer. Be aware that some questions will apply partial marking, as there may be more than one correct answer required. Remember, a successful blend of preparation, test strategy, and exam technique will help you maximize your chances of obtaining certification. Good luck! In this part, we explore some tips and tricks in order to make sure that your proctored exam runs as smoothly as possible. Prior to registering for and purchasing your exam, complete the required system test on the same computer and in the same location you will test from. Online exams can be disrupted by proxy servers, network packet inspection or filtering, or strict network security configurations. As a result, make sure that the Windows user account logged in to the delivery workstation has local administrative permissions. Some antivirus software can cause performance issues. Please disable antivirus scanning while taking your exam. You may need to ensure that your security software does not block the execution of required software scripts. If possible, take your exam on a personal computer rather than a work computer, because work computers could have software installed that will prevent the OnView software from launching. Also, if possible, use a desktop computer rather than a laptop computer. You may need to configure your internet security and antivirus software to make an exception for the Pearson Secure Browser executable file. Finally, when taking an online proctored exam, use a hardwired internet connection. If this is not possible, use Wi-Fi. Do not tether to a mobile hotspot, as this is explicitly prohibited. For more information or troubleshooting, we recommend that you read the Network Administrator Level Troubleshooting Requirements located on the Pearson VUE website. Hello again, and welcome to Module 2, Practice Exam 1. By now, you should have a good understanding of the Microsoft Certification Program and how to prepare for the AZ900 exam. In this module, you will have an opportunity to recap key topics and take a practice exam on Course 1, Introduction to Azure Core Concepts and Services. With that in mind, by the end of this lesson, you will have reviewed key concepts and taken a practice exam on the topics covered in Course 1. You have almost completed this Azure Fundamentals series of courses. By now, you should have a grasp of the basic cloud concepts, a streamlined overview of many Azure services, and hands-on experience deploying your very first services for free. First, you looked at the basics of cloud computing in Azure and how to get started with Azure subscriptions and accounts. You examine the advantages of using cloud computing services and learn how to differentiate between the categories and types of cloud computing. You also learned about several of the database services that are available on Microsoft Azure, such as Azure Cosmos DB, Azure SQL Database, Azure SQL Managed Instance, Azure Database for MySQL, and Azure Database for PostgreSQL. In addition, you looked at several of the big data and analysis services in Azure. You learned how to take advantage of several virtualization services in Azure Compute, which can help your applications scale out quickly and efficiently to meet increasing demands. You saw some of the different storage options that are available in Azure Storage Services. You learned about Azure Blob Storage, Azure Disk Storage, Azure Files, and Blob Access tiers. You also covered several of the core networking resources that are available in Azure. You learned about Azure Virtual Network, which you can configure into a customized network environment that meets your needs, and how you can use Azure VPN Gateway and Azure Express Route to create secure communication tunnels between your company's different locations. By now, you should be able to understand the benefits of cloud computing in Azure and how it can save you time and money. Explain cloud concepts such as high availability, scalability, elasticity, agility, and disaster recovery. Describe core Azure architecture components, such as subscriptions, management groups, resources, and resource groups. Summarize geographic distribution concepts, such as Azure regions, region pairs, and availability zones. Your next step is to take the practice exam that covers these topics. Hi, and welcome to Module 3, Practice Exam 2. In this module, you will have an opportunity to recap key topics and take a practice exam on the contents of Course 2, Azure Management Tools and Security Solutions. In Course 2, you learn about AI services and solutions, monitoring and managing in Azure, Azure Serverless technology, the Internet of Things, and general security and network security in Azure. In the Azure Management Tools and Security Solutions course, you were introduced to a wide array of tools and services from Microsoft Azure. You examined the features of these tools and services and were asked to help choose the best one for a given business scenario. Artificial intelligence, or AI, is a category of computing that adapts and improves its decision-making ability over time, based on its successes and failures. Microsoft Azure provides several AI solutions to choose from, each one depending on the problem you're trying to solve. You identified a few product options and their capabilities, including Azure Bot Service, Azure Cognitive Services, and Azure Machine Learning. You also analyzed certain decision criteria to help you choose one option over another depending on the scenario. You identified various product options and capabilities that help developers and operations engineers build modern solutions for both the cloud and on-premises. These included Azure DevOps Services, GitHub, including GitHub Actions, and Azure Dev Test Labs. You analyzed the criteria for choosing one option over another for each scenario. Then you applied those criteria to 3 separate challenges at Tailwind Traders, helping the team determine the best service option for the scenarios. DevOps practices and processes have changed the software development landscape, helping to accelerate software development and improve the deployability and quality of software systems. As you have seen, Microsoft offers a wealth of tools that can help organizations implement DevOps practices, experience better collaboration among technical teams, and achieve more consistent results from those teams. Azure Monitoring Services provide a comprehensive array of features that can give your IT organization insight into the health and performance of its cloud-based applications. You identified 3 monitoring services and their capabilities: Azure Advisor, Azure Monitor, and Azure Service Health. We analyzed decision criteria for choosing one option over another for certain scenarios. Next, you examined Azure Serverless technologies and chose the right service for your business scenario. When the company needs to build a solution that pulls code logic from an existing C# Windows service, you helped it choose Azure Functions. And when the company needed to orchestrate a workflow to improve customer retention after a negative shopping experience, you helped it choose Azure Logic Apps. IoT is an exciting evolution in computing that bridges the physical and digital worlds. You learned how Azure IoT services provide a significant amount of functionality for organizations that want to build device-driven and sensor-driven solutions. Using IoT, you can capture telemetry data from appliances and combine it with some machine learning to predict future maintenance and create a significant value-added service for customers by using Azure IoT Hub. and how you can use Azure IoT Central and the Connected Logistics Starter template to implement a complete real-time logistics system to track deliveries. And finally, you looked at designing and building a secure, modern, point-of-sale, self-checkout terminal by using Azure Sphere. Azure provides tools and services that can help you detect and act on important security events. It also provides ways to help keep your data safe, which can prevent security incidents from happening to begin with. Azure Security Center provides visibility of your security posture across all of your services, both in the cloud and on-premises. Azure Sentinel aggregates security data from many different sources and provides additional capabilities for threat detection and response. Azure Key Vault stores your application secrets, such as passwords, encryption keys, and certificates in a single central location. Azure Dedicated Host provides dedicated physical servers to host your Azure VMs for Windows and Linux. You learned about the Azure services you can use to help ensure that your network is safe, secure, and trusted. Defense in depth is the overriding theme when we consider security. Think about security as a multiple layer, multiple vector concern. Threats come from places we don't expect, and they can come with surprising strength. Azure Firewall is a managed cloud-based network security service that helps protect resources in Azure virtual networks. An Azure virtual network is similar to a traditional network that you'd operate in your own data center. A network security group, NSG, enables you to filter network traffic to and from Azure resources within a virtual network. Azure DDoS protection helps protect Azure resources from DDoS attacks. At this point, you should be able to describe the core solutions and management tools on Azure. You should also be able to describe the general security and network security services you can use to protect against threats on Azure. Take the practice exam and test your knowledge. Hello, and welcome to Module 4, Practice Exam 3. By now, you should have a good understanding of the Microsoft Certification Program and how to prepare for the AZ900 exam. In this module, you will have an opportunity to recap key topics and take a practice exam on Course 3, Azure Services and Lifecycles. With that in mind, by the end of this lesson, you will have reviewed key concepts and taken a practice exam on the topics covered in Course 3. In the Azure Services and Lifecycles course, you looked at how Azure can help you secure access to cloud resources, what it means to build a cloud governance strategy, and how Azure adheres to common regulatory and compliance standards. You also learned about the factors that influence cost, tools you can use to help estimate and manage your cloud spend, and how Azure's service level agreements can impact your application design decisions. First, you examined the difference between authentication and authorization, and learned how Azure Active Directory provides identity and access management. You saw how single sign-on, multi-factor authentication, and conditional access enable your users to securely access resources and applications from your intranet and from public networks. Identity has become the new primary security boundary, accurately proving that someone is a valid user of your system with an appropriate level of access is critical to maintaining control of your data. This identity layer is now more often the target of attack than a network is. Authentication, auth-n, establishes the user's identity. Authorization, auth-c, establishes the level of access that an authenticated user has. Single sign-on, SSO, enables a user to sign in one time and use that credential to access multiple resources and applications. Azure Active Directory, Azure AD, is a cloud-based identity and access management service. Azure AD enables an organization to control access to apps and resources based on its business requirements. Azure AD multi-factor authentication provides additional security for identities by requiring 2 or more elements to fully authenticate. In general, multi-factor authentication can include something the user knows, something the user has, and something the user is. Conditional access is a tool that Azure AD uses to allow or deny access to resources based on identity signals, such as the user's location. With these ideas in place, the organization can begin to integrate and improve their existing solutions, including multi-factor authentication and single sign-on. Then you learned how access policies, resource locks, and tags, as well as Azure services such as Azure Policy and Azure Blueprints, can help you build a comprehensive cloud governance strategy. Cloud governance requires good analysis and requirement gathering. Luckily, the Cloud Adoption Framework for Azure can help you define and implement your governance strategy. There are several services and features in Azure to support these efforts. Azure Role-Based Access Control, Azure RBAC, enables you to create roles that define access permissions. Resource locks prevent resources from being accidentally deleted or changed. Resource tags provide extra information or metadata about your resources. Azure Policy is a service in Azure that enables you to create, assign, and manage policies that control or audit resources. Azure Blueprints enables you to define a repeatable set of governance tools and standard Azure resources that your organization requires. With these points in mind, you're ready to take the next step towards building a good cloud governance strategy. Next, you learned about Microsoft's approach to privacy, security, and compliance. You explored resources specific to online services, including Azure, and how governments can use Azure to meet their specific security and compliance needs. The Microsoft Privacy Statement provides trust in how Microsoft collects, protects, and uses customer data. The Trust Center provides you with documentation about compliance standards and how Azure can support your business. The Azure Compliance documentation includes detailed information about legal and regulatory standards and compliance on Azure. Migration to cloud presents new ways to think about your IT expenses. The cloud also removes the burden of supporting IT infrastructure. You learned about the factors that influence costs and tools you can use to help estimate and manage your cloud spend. Use the total cost of ownership calculator to estimate the cost savings of operating solutions on Azure instead of in its on-premises data center. From there, you use the pricing calculator to get a more detailed estimate for running a typical workload on Azure. You also examine how you can use a range of measures to keep the costs down. Finally, you learned about service-level agreements in Azure and how they can affect your application design decisions. You saw how to access preview services and learn how they affect your planning. A service-level agreement is the formal agreement between a service company and the customer. For Azure, this agreement defines the performance standards that Microsoft commits to for its customers. When defining your SLA requirements, you should consider both your business needs and the time it takes to restore a component after a failure. Also consider how the use of preview services and preview features might affect your systems in production. By now, you should be able to secure access to cloud resources, understand what it means to build a cloud governance strategy, describe how Azure adheres to common regulatory and compliance standards, understand the factors that influence cloud costs, describe tools you can use to help estimate and manage your cloud spend, and explain how Azure service-level agreements can impact your application design decisions. Hi, you're now almost finished this Microsoft AZ900 Azure Fundamentals program. In this module, you will briefly review the weights of core concepts in the exam and take a full practice exam. You will also look at some specific information about how learners who have been unemployed or furloughed due to COVID-19 can secure an industry-recognized Microsoft certification at a discounted fee. Finally, you will get another chance to look at the detailed instructions on how to sign up for the Microsoft certification exam. First, let's have a quick recap on the weightings of the topics covered in the exam. Keep in mind that the exam requires you to demonstrate high-level knowledge of the Azure cloud and its various service offerings across the following 6 domain areas. Describe cloud concepts, describe core Azure services, describe core solutions and management tools on Azure, describe general security and network security features, describe identity, governance, privacy, and compliance features, and describe Azure cost management and service level agreements. The percentages for each domain highlight the weighting of that section to the overall exam. The higher the percentage, the more questions that specific section of the exam will contain. The next reading in this module links to the complete list of skills measured in the exam. Now good luck with the full practice exam. Congratulations, you are now ready to take the Microsoft Azure Fundamentals Certification exam. Before you do, here's a quick reminder of the certification paths that this will open to you. The AZ900 certification is the entry level for any other Azure certification. It is the starting point to the associate level and to the engineer and expert level certificates. Depending on your interest, you can build on what you have learned by pursuing certification at associate level in many different areas. Microsoft's associate level certifications usually require around 2 years of working experience of the products they cover. It'll be helpful that you have already earned a fundamental certification before trying for the associate level credentials, but it's not mandatory. At the moment, there are a wide range of associate level Azure certifications on offer. So, if you want to be a developer, an administrator, a data scientist, or an AI engineer, you are on the right path. Your next step is to pass the AZ900 exam. Good luck!